Welcome to Malaga and the first Global Photonics Economic Forum. In this room, we've gathered the world's most influential executives, leading the companies and research institutions that will define the future impact of photonics. Our discussions will explore the complexities introduced by current geopolitical tensions, including the US and European Chips Acts, and the critical role photonics plays in driving semicon forward. And because there is no existing forum that addresses the broad and urgent economic future of optics and photonics technologies, Optica decided to create one. Remember, DARPA and the defense industry funded Silicon Valley. But today, defense and many governments struggle when it comes to investments in AI, augmented and virtual reality, and sustainable photonics. So who are the new drivers? How do we influence what happens next? And there's a strong reason for meeting here in the vibrant technology center of Malaga, as we're just about to find out.
Muy buenas. Queridos amigos, dear friends, liebe Freunde, beste Freunde, cari amici, we've done it. Welcome to the Global Photonics Economic Forum. I'm Jose Pozo, Optica's Chief Technology Officer. It was very difficult to find the words to start the first edition of the Global Photonics Economic Forum. Let me start with a personal story of how I explain photonics to my daughter. She's 4 years old. Her name is Sarah. She's watching the YouTube stream. I told her that photonics is the magic that makes the world create, move, and receive light. And with this magic, you can do 3 things faster than ever before. You can make things, you can sense or feel things, and you can communicate things or tell stories. It's a way to bring light into every corner of the world and help people live healthy, long, and prosper. Ladies and gentlemen, this forum is more than just another industry meeting. It's a call to action, an opportunity to have real, honest discussions built on trust and mutual respect. Because if we are to drive this industry forward, we need to build that trust between companies, policymakers, and investors. And we need to act now. Look at today's headlines. Geopolitical shifts, restrictions, rapidly changing market demands, which are affecting each and every one of you. The photonics industry, which enables key sectors such as telecommunications, healthcare, advanced manufacturing, defense, stands right in the middle of this huge transformation we are living today. And it's no surprise that the global photonics market in 2027 will be worth 1.2 trillion, I said trillion, euros. This is a massive opportunity, but we also here in this room, we have a massive responsibility. If we want to build the future we all dream of, we must take real action, and we need to take it right now. Everyone in this room has a preferred future. I'm going to tell you mine. I dream of a world where photonics cures cancer, provides universal access to reliable information, and supplies clean energy. But we all know that to get there, we all have a long journey ahead. Our industry is highly fragmented. And very often, you think about it, we are more driven by competition than collaboration. And this is the main reason we are all here today. You all have a piece of the puzzle, and it's all about, and I love this word, those meaningful connections. To make the photonics magic happen, we need 2 things, revenue and people. We need to grow and diversify and improve gender balance. If you don't believe me, look around you. We need to convince end users, investors, young people, and especially women, that photonics is a field of immense opportunity, innovation, and impact. If you think about it, it's the field of dreams. Preparing today was the result of thousands of hours of very passionate work, very, very passionate work. Let me credit those who deserve it the most. Optica staff and all our volunteers, especially the members of the Optica Corporate Engagement Council and the Board of Directors who are with us today. Also to the Optica executive team, and in particular our new interim CEO, Elizabeth Nolan, and our former CEO, Liz Rogan, female leaders who supported us as we brought this forum forward. And of course, the inspiring keynotes, guest moderators, and panelists, more than 50 leaders in the photonics world will be on a stage over the next 2 days. A special thanks to Luxinar and their CO2 and femtosecond lasers for being our industry sponsor. And of course, to the Ayuntamiento de Málaga, to the Junta de Andalucía, to the FICMA, to the Malaga Tech Park, for making us feel so welcome. I believe that over the next 2 days, we are going to make photonics history. And to achieve that, we need your help. Now it's all about you. Think about your answer to the Optica question. What can you do for others? And what can others do for you? We need you to build meaningful connections, challenge ideas, and actively participate. This is our moment to drive change, to shape the future of photonics and the world. So let the magic happen. Welcome to the Global Photonics Economic Forum. Now it's my huge pleasure to introduce the co-chairman of the Global Photonics Economic Forum, the CEO of Focuslight Switzerland, Reinhard Volker.
Good morning. A dream comes true. Thanks, Jose. He already said everything, so what should I say? So let's start with a simple question. You open your computer and check what is the total revenue of the photonics industry, and you find SPIE 368 billions, ChatGPT 700 billions. My dear friend Lutz, Photonics 21, 865 billions. So I would not mind about some plus minus 10%, but you know, factor 2. And this is a challenge what we have as a photonics industry. So even if I have to explain you how many people work in your industry, what is the revenue, I don't know. So maybe ChatGPT thinks that solar industry is photonics. You know, solar panels, they take a photon and transfer the photon to an electron. Is there anybody in the audience working in solar industry? No. No, solar is not. No, solar is solar. It's not photonics. So CMOS image sensors, they take a photon, transfer the photon to an electron. No, this is semiconductor industry. But an optical sensor, converting a photon to an electron, yeah, this is photonics industry. Sorry, I cannot explain this. Nobody can do. So this is not good for our reputation. Are we an industry? So you go to politicians and say, okay, guys, you have other problems. Don't talk that. So now we could say we don't need politics because we are a rock-solid industry. We always make money. We grow 7 to 8%. We go to the trillion. And photonics-related things is about 15% of the GDP worldwide. So we're enabling technology. So some people say it is not relevant for us. So we don't need to talk to politics. You know, solar industry and semi, they get a lot of money from government. They need the money. They could not survive. So as you all know, and Jose repeated this, the world has become complex. It's a VUCA world, volatile, uncertain, complex, ambiguous. So let's take, for example, dual use. You know, the first telescopes 300 years ago, yeah, you could observe the stars, but you could observe your enemy. So that was already dual use. Today now, if you manufacture a pump laser, And the laser goes into laser manufacturing, into car manufacturing, whatever. So all of a sudden, the pump laser gets in a laser weapon. And the government decides, oh, stop. You're not allowed to export this anymore. So this happens all the time. You know, rules change, government change. There's somebody new in the administration. And one day to the other, you're not allowed to export anymore. So your customers go mad. You have 98% of your business is normal business, but the rules do not allow that you export. So this is a bit the challenge we have in our photonics industry, that we don't have clear rules, nobody really knows who we are and what we do. And so let's talk about the generation Z. You know, each and everybody in the room, photonics was a great deal. So we got a good job, we had a good career, making money, some made a lot of money. Okay, so now think, you're on stage here, and the room is full with generation Z, the kids. And you have to explain to the kids why they should come in our industry, why photonics is a good deal. So yeah, you know, the internet faster, so medical, lasers are everywhere, no car, no iPhone, nothing would exist without lasers, without photonics. So if the audience were truly Generation Z, you know what they would say? Hey, Dad, stop the sales pitch, you know? That was a good deal for you. But why should we go to photonics industry? Why should I go to photonics industry? We need to have a good answer on that. Global zero. So in former times, the glass makers, they were changing every 10, 20 years the location because all the forest was gone, because they were burning. They needed so much energy to melt the glass. Today, we want to be global zero. So that means we want to get glass making from gas melting to electricity, and get the electricity from water, sun, or wind. So now, what is the idea of the Malaga meeting of the Global Photonics Economic Forum? We need to form a photonics industry. We need to understand who we are, what we're doing, why we need help. We need to meet. And this is why Jose and I, we were sitting together and said, you know, we need to get the leaders of our industry. And today we have on stage executives for $70 billion on stage. This never happened because the many events we have, yeah, there's not so much value, and we never see the leaders. So the idea of Malaga, the spirit of Malaga is like Davos, where the US president comes, where Bill Gates come, where the leaders, intellectual leaders, the political leaders, they all come together. And we make industry stronger, we meet, so we have 2 days where we can drink a beer together with our competitors, discuss what is necessary. In a first way, it's clear we don't know each other so well. We never meet. So first we need to meet. But in a long term, we would like to get a message and speak with one voice to politics and have a real photonics industry. So this is the spirit. So I have 2 wishes. So the first wish is, this is your meeting. So you meet and you define the future topics. What is urgent? So Jose and I, we were sitting together with a team and said, okay, what should we do, Generation Z, and this and this and this. But, you know, we need the input from you. And we hope that you all come back next year, and each and everybody of you brings at least one other colleague. One other, because we have to make this a big thing. And my personal wish is, if I would register for the real Davos, for the World Economic Forum, in registering form, there should be photonics. And I would love to proudly make my cross at photonics, because today, when you fill a form, there's almost never photonics, so we have to, whatever, electronics or semiconductor, manufacturing, we never find photonics. So this is your meeting. We are the photonics industry, and I would love to see that this becomes the Davos of our industry, where all the leaders of the world come together, discuss, and bring a strong message to the world. Photonics is everywhere, and we are photonics. Have a great meeting. Thank you very much.
People don't go to the World Economic Forum anymore. They go to Davos. People shouldn't go to the Global Photonics Economic Forum anymore. They should come to Malaga. We couldn't have done this without the huge support we got from the local authorities. Allow me to give the floor to Antonio Sanz, Councillor of Presidency from the Junta de Andalucía.
Don Francisco de la Torre, alcalde de Málaga, delegada del Gobierno de la Junta en Málaga, Patricia Navarro, director gerente de la Agencia Digital de Andalucía, Raúl Jiménez, teniente alcalde, delegada de Nuevas Tecnologías del Ayuntamiento de Málaga, estimado Reinhard Walker, copresidente del Foro Económico Mundial de Fotónica, José Pozo, director de Tecnología de Optica, Luz van den Hoop, CEO del Centro Universitario de Microelectrónica IMEC. A todos, bienvenidos a Málaga, bienvenidos a Andalucía. Me siento muy afortunado de estar hoy aquí, en este foro que coloca a Málaga en protagonista excepcional de la industria fotónica. Ustedes son el mejor ejemplo de por qué Málaga atrae la mirada de tanta gente que se pregunta qué hace que Málaga sea hoy uno de los territorios más pujantes, dinámicos y propicios para la actividad económica. Me consta que la elección de Málaga no es casual, porque la capital y la provincia están emergiendo como un hub tecnológico a nivel europeo y la celebración de este foro lo coloca y nos coloca en el mapa de la innovación global. Y es una alegría no solo recibiros este año, sino además saber que el año que viene también volveremos a contar con este gran foro. Porque Málaga lleva años, como Andalucía, acogiendo eventos de relevancia mundial. Aquí estamos celebrando cada año uno de los mayores congresos internacionales de ciberseguridad, el Digital Enterprise Show o el Talent Land. Y miren, Andalucía es una comunidad líder en asuntos impensables hace unos años apenas. Hoy nuestra región sorprende en muchas cosas, pero de manera muy especial en digitalización, en estrategias que tenemos en marcha como la estrategia de ciberseguridad y el nuevo Centro de Ciberseguridad de Andalucía, o en inteligencia artificial con la Agencia de Inteligencia Artificial de Andalucía, que nos permiten ser hoy motores de un cambio en Andalucía. Queremos que la tecnología sea el tercer pilar económico de Andalucía. Hace 10, 15 años eso sería impensable. Además del turismo y de la agricultura, hoy podemos decir que la economía digital va camino de convertirse en el tercer pilar económico de Andalucía. Y Andalucía, por tanto, no es ajena a una industria tan pujante e importante para los avances tecnológicos como lo es la fotónica, y en esta área Málaga, sin duda alguna, es un polo de innovación y desarrollo. En el caso de la fotónica, no tenemos que irnos muy lejos para encontrar a gente pionera, como ha sido la Universidad de Málaga, donde se comenzó a trabajar con los fotones para llevar a cabo proyectos innovadores. El potencial de estas investigaciones y de la propia fotónica llevaron a la universidad a crear 2 empresas tecnológicas para poder sacar todo el partido posible a los estudios que se estaban haciendo. Y fruto de ello, surgidas del Grupo de Investigación de Fotónica de la Universidad de Málaga, nacieron startups como Bioherent, que aplica esta tecnología a los campos de la salud, la ciencia o la ingeniería, o como AGP Photonics, que está especializada en el diseño de dispositivos y sistemas basados en fotónica integrada para una amplia gama de aplicaciones, incluyendo comunicaciones por fibra óptica, comunicaciones ópticas en espacio libre, teledetección, biosensado fotónico, computación fotónica y aplicaciones cuánticas. Pero si decisivo es el papel de las universidades, no lo es menos el de los parques tecnológicos y científicos andaluces, verdaderos espacios de concentración de talento e innovación, como es Málaga Tech Park, y está aquí su director, a quien felicito por su trabajo, aliado total en el impulso de una Andalucía tecnológica de vanguardia. Y va a ser precisamente ahí, en el Málaga Tech Park, donde se instale el futuro centro del IMEC, Fundación, que va a situar aquí su centro de fabricación e I+D de semiconductores, el Centro Universitario de Microelectrónica. Una gran noticia y, desde luego, una satisfacción acogerlos en esta tierra. Hablamos del segundo centro de innovación de chips en obleas de 300 milímetros de la Fundación IMEC en el mundo, que va a ocupar 46.000 metros cuadrados y para los que la Junta de Andalucía ha adquirido los terrenos dentro del Málaga Tech Park, donde se instalará. Una nueva instalación que nace con el objetivo de desarrollar nuevos procesos de prototipado de chips, como decía, de 300 milímetros en nuevos materiales, alternativos al silicio, centrando la investigación, que hoy centra la investigación del primer centro del IMEC en Lovaina, que actualmente son complicados de combinar con los procesos del semiconductor complementario de óxido metálico. La nueva fábrica busca responder a las nuevas necesidades de investigación y desarrollo de nuevos prototipos para situarse a la vanguardia de los procesos tecnológicos que se desarrollen durante la próxima década en campos como la medicina, la fotónica, las tecnologías cuánticas o la realidad aumentada. Esto tendrá aplicaciones en campos, sin duda, como la salud, la biología o la ingeniería de precisión. Miren, estamos decididos en convertir a Andalucía en una región líder en transformación digital y posicionar a la comunidad como referente y pionera en emprendimiento y en innovación digital. Y para ello, además de la colaboración público-privada de la que este foro y el centro del IMEC son ejemplo, tenemos que facilitar a nuestros jóvenes también la capacitación necesaria para responder a la demanda de perfiles TIC por parte de todas las empresas que vienen aquí, que se instalan aquí o que son andaluzas. Afrontamos nuevos proyectos como la puesta en marcha de centros de alto rendimiento empresarial dirigidos también a la formación de nuevos profesionales en la economía digital, programas formativos de upskilling, de formación de un profesional en nuevas habilidades y competencias. Para eso hemos anunciado diferentes centros nuevos que instalaremos en la provincia de Málaga y el resto de provincias andaluzas. Pero hoy, además de centros físicos como los que les hablo, quiero lanzar un proyecto novedoso en el que pretendemos ningún joven se quede atrás. Por eso hoy les anuncio que vamos a crear un nuevo nodo, un nodo digital, virtual, con el que extendemos el proyecto a toda la sociedad andaluza y a todas las personas que quieran formarse en proyectos tecnológicos, en economía digital y extenderlo a cualquier municipio de Andalucía. Durante el mes de octubre vamos a poner en marcha formación específica para emprendimiento digital y el desarrollo de proyectos empresariales con asesoramiento personalizado adaptado a los proyectos de las empresas y de los emprendedores. Cursos para jóvenes desempleados que abarquen desde administración de redes, técnico de redes, analista y técnico de ciberseguridad, cursos de inteligencia artificial o el desarrollo de videojuegos o cursos de microelectrónica. Queremos contar, por tanto, con el talento digital de los andaluces e impulsarlo a través de la capacitación y los programas para emprendedores, ayudando a que se desarrolle ese talento y contribuyan al crecimiento de nuestra región. Pero también queremos invitar y atraer a ese talento de fuera, el que está ahora fuera de nuestras fronteras, y queremos darle facilidades para que hagan crecer sus negocios en Andalucía. Presentamos a Andalucía como una tierra abierta, con una forma de vida que invita a instalarse en nuestra región. Un lugar ideal para trabajar, para vivir y para emprender. Y la celebración de este foro es, sin duda alguna, una gran noticia que sigue consolidando a Andalucía como una tierra de innovación puntera que apuesta por la tecnología y por la innovación, no solo para impulsar la competitividad y la economía de la región, sino también para hacer más fácil la vida de las personas. Enhorabuena por este gran evento Gracias por confiar en Andalucía. Bienvenidos a Andalucía. Disfruten de Málaga y de esta bendita tierra, Andalucía. Muchísimas gracias.
A few years ago, 10 years ago, we were all excited because a president of the United States said the word photonics, and he actually didn't even mention it properly. How we have managed to get the public authorities speaking so highly about our industry. People in this room, like Evie Ross, the CEO of Photon Ventures, or Greg Bartlett, one of the drivers of the CHIPS Act USA. Thank you so much. Thanks to your hard work, we have now politicians loving our industry. Today, I must say, is one of the happiest days in my professional life. I'm about to introduce to this room a person who considers innovation as one of the driving factors to position a city that I love at the top of deep tech innovation. His word is Don Francisco, alcalde de Málaga.
The Regional Minister of Andalusian Government, authorities, ladies and gentlemen, good morning, everybody. Welcome to the first Global Photonics Economic Forum, and welcome to Malaga, a city where culture and technology converge to create a dynamic technology hub in Southern Europe. It is a tremendous honor for our city to host this event, and I would like to extend my sincere gratitude to the organizers, Optica, and particularly to José Pozo and Reinhard Woelkel for their visionary leadership in creating this important forum and in selecting Malaga as the host city. As we stand at the forefront of the microelectronic revolution, it is clear that photonics will play a pivotal role in shaping the future. This forum is essential, bringing together some of the world-leading experts to shape their insight, drive scientific breakthrough, and advance the development of faster, better, and more efficient chips. Malaga itself is no stranger to innovation. Over the past 2 decades, our city has undergone a remarkable transformation, emerging as a dynamic technological hub that attracts leading companies, research institutions, and talented individuals from around the world. With a metropolitan population of the 1.1 billion, Malaga enjoys one of the best climates in Europe and serves as the capital of the popular tourist destination known as the Costa del Sol. The beaches, mountains, over 50 golf courses, and year-round good weather provide a variety of recreational activity for residents and tourists alike. Our city boasts more than 3,000 years of monumental heritage and an extensive network of over 40 museums. At the birthplace of both Pablo Picasso and Antonio Banderas, Malaga is also a renowned center for arts and culture. However, Malaga is not just a cultural destination. The Malaga Tech Park, with over 680 companies, has transformed the city into a magnet for startup, research institutions, and multinational corporations. For example, Google selected Malaga for one of its cybersecurity centers to conduct research and development, as well as offer training, workshop, and mentorship programs in cybersecurity. Vodafone also chose Malaga as the location for its European R&D center, where they develop cutting-edge technological solutions and digital service. Other prominent companies such as Keysight Technology, Decra, EPAM, Oracle, Accenture, and EY have also been able to grow in Malaga. The Innova AI, is a public-private foundation dedicated to supporting the growth of the digital technology industry in Spain. Through a strategic initiative, collaborative projects, and training program, Innova AI plays a crucial role in fostering innovation and attracting investment. Education and training are equally vital to Malaga ecosystem. The University of Malaga was the first in Spain to offer a degree in artificial intelligence and cybersecurity, and currently has the highest number of shares focusing on microelectronic chips, demonstrating its commitment to cutting-edge education. Furthermore, we have strengthened our educational offering through the Digital Content Hub, providing program in collaboration with the EOI, the University of Malaga, and the 42 schools. Additionally, incubator like Go to Work, La Brújula, and IIT Metaverse offer support and resources for entrepreneurs in the digital content sector. Now, with the Inter-University Microelectronics Center decision to establish its first R&D center outside Belgium in Malaga, the city is poised to become one of the premier microelectronic hubs in Europe. I want to take a moment and express our appreciation to Luc van den Hoop, President and CEO of IMEC, for joining us today. We look forward to hearing his insight, along as those of Maria Marcel from TSC Europe and the many other distinguished CEOs and experts who have come to participate in this forum from many countries. This Global Photonics Economic Forum offers a trusted platform for collaboration and innovation, addressing some of the most pressing challenges and exciting opportunities facing the industry today. With the rapid advancement of photonic technology and its increasing relevance across sectors like artificial intelligence and data center, this forum comes at a crucial time. Our discussion will explore the critical role of photonics in meeting the growing energy demand of these technologies and how we can work together to overcome challenge and seize new opportunity. In closing, I invite you all to take part in shaping the future of the photonic industry. Through collaboration, innovation, and strategic partnership, we can unlock the full potential of this transformative technology. Remember, more than 1 trillion euro in 2027, Jose Pozo tell us some minutes. Finally, I invite you all to embrace the beauty, culture, and worth of Malaga. Explore our historical landmark, immerse yourself in our vibrant art scene, and savor the flowers of our Mediterranean cuisine. Discover the true essence of Malaga, a city that seamlessly blends tradition with innovation, welcoming all who seek a place to live, to work, and to invest. Thank you for being here, and once again, bienvenidos a Malaga. Thank you very much.
Gracias, don Francisco, por tenernos en esta maravillosa tierra. Things are shifting. They are shifting heavily. We see that the major authorities in this region are saying the word photonics so proudly. I was told by protocol that they wanted to take a picture because, as you know, there is a lot of press behind us and make this day memorable for everyone. So the person in charge of protocol is now allowing me for 25 seconds, that's how long they took me, it was going to take this picture on stage. And then we'll start with the presentation by Maria Marcel, who is going to tell us how a company from Taiwan, TSMC, is using Europe for manufacturing. Muchas gracias por todo. Bueno, vamos a... Muchas gracias por todo. Another round of applause for our local authorities. Thank you so much. So it was great to hear how magnificent photonics is. Now, let's get to work. We came here to work. We came here because it's a call to action. And we have selected for you a set of speakers who are here to tell us how we all fit in the puzzle. The first person I want to give in the stage is a person that has, for many years, contributed to Europe becoming a center for manufacturing, and to Spain investing heavily in photonics. I want to give the floor to Maria Marcet, the president of TSMC Europe.
Thank you, Jose. Good morning, everybody. By the way, just a remark. I am not anymore the president of TSMC Europe. I retired January 1st. But I retired, but I am still quite active on many different things, including forums, boards, and so on and so forth. And certainly helping a lot as well the European and especially the Spanish CHIPS Act to spend wisely the money. So I hope that also you will benefit, some of the companies here around photonics will benefit from this effort that the European Union and especially the Spanish government is putting to improve and to unlock innovation. I always say that semiconductors, and by the way, photonics are semiconductors. I know that the word is a bit funny. Semiconductors is not even fully conducting, right? But anyway, this is our industry, semiconductor chips. I mean, it's funny names, but anyway, funny, but one of the most important industries in the world. Because there is no innovation without semiconductors. This is why I always say that semiconductors power the world, power all the innovation. There is no innovation without semiconductors. Everything, from consumer electronics to communications to data centers to robotics to cars, more and more, virtual reality, and so on and so forth. I mean, every innovation really is based on semiconductors. To the point, and today you have heard already several figures, to the point that I will use McKinsey in this case. McKinsey last year forecast that the industry will be $1 trillion by 2030. But forecast, by definition, is always wrong, right? So this year, McKinsey says, sorry, we were wrong, and now, because we underlook, we didn't realize that generative AI is going to be so important. So including AI, now McKinsey is saying that by 2030, the industry will be $1.3 trillion. And by the way, data centers are going to require photonics in order to really have the communication among the CPUs. The figure is impressive. About $125 of semiconductors every person will have on Earth every year. So this is really an impressive figure. Why this industry has been so successful, growing so fast, and reaching soon the 1.3 trillion? Why? Well, in my opinion, one of the main reasons has been Moore's law. Gordon Moore, as you know, one of the founders of Intel. Moore predicted that some people, I heard several figures, could be 18 months, could be 24 months, doesn't matter. Every maximum 2 years, the number of transistors integrated in a chip in an integrated circuit will be double. No industry has been able to achieve this, because doubling the number of transistors means doubling the performance. At the same time, it has been really focused also on improving the efficiency of the energy, the energy use, and also doubling the number of transistors means cost. Although later on, it's been so difficult to produce that the cost is not really reduced by half. But doesn't matter. The point is, how this industry has been able to evolve thanks to Moore's law. So I am using now TSMC slide. TSMC is already starting the risk production, the manufacturing path on 2 nanometers. 3 nanometers has already started. Well, it's already in the market on the press is saying that the new iPhones are based on 3 nanometers. 2 nanometers started already in the production path, and even starting to research and having already good results on. Now we are talking about Armstrong, because it's 1.6 nanometers, so we are now below the nanometer figure. However, this has come at a cost. And by the way, those figures are quite obsolete. What I'm trying to show you here, that both the chip design as well as building fabs, every new node is really, you can see, really exponential cost. To the point that if you look at today a new fab, especially on 3 nanometers, you have to be looking at between 15 and 20 billion US dollars. Only one advanced lithography tool, the new EUV, the new extreme ultraviolet, required to manufacture 5 and 3 nanometers, only one costs around 500 million. One lithography machine. So you can imagine, how difficult it is. And this is why the industry has consolidated globally. You can see here, the different regions, how specialized are in different topics, from equipment to foundry to fabless, whatever. But in summary, let me tell you, the US designs, Asia manufactures, especially Taiwan and Korea. This is summarizing or simplifying this picture. So far, so good. This meant that, well, the scale, the manufacturing scale built by Korea and TSMC allow, Korea and Taiwan, primarily allow, reduce the cost tremendously. So far, so good. However, the pandemic came, disrupting the value chains. I remember the car makers that I never knew before in Europe because, well, they were very far away from being a foundry. However, after the pandemic, we became very acquainted because they were all calling saying, where are my chips? I cannot manufacture, I cannot finish the cars, where are my chips? So this was one reason, but then also it was the tension between US and China. Again, disrupting the value chains, disrupting the supply to the final customer of the required semiconductors to keep innovation. So what has happened after this? That, well, the globalization that looked beautiful because reduced the cost, because it really built economy of scales, then this didn't work. And every region wanted to have their own manufacturing. In the case of TSMC, well, no, not yet, but every region, so the US created their own CHIPS Act. They were first, allowing about 52 billion. Now they have increased the figure. Then Europe also launched their own CHIPS Act with about 40 billion, and Japan as well. They didn't call it CHIPS Act, but well, subsidies as well. Of course, China already did it before by investing a lot of money in building design centers and factories as well. There are three pillars of the European CHIPS Act. Probably Luc will talk a bit about the first pillar, which is very much focused on R&D, creating talent, helping SMEs, helping R&D, helping pilot lines, and so on and so forth. TSMC, of course, focused on the second pillar, which was manufacturing. In order to get access to the CHIPS Act subsidies, you have to be first of a kind. So we have to prove that we were going to manufacture in Europe was really first of a kind in Europe. And this is the case, as I will speak later. So this was the first thing. Then the third pillar, which was a bit controversial, was that the EU will monitor and especially help the companies to respond to the crisis, to avoid the disruption of the value chain. This was a bit controversial, as you can imagine. But anyway, I will not talk about this. So this led to break one of the key principles of TSMC. Morris Chang, the founder of TSMC, he really thought that the first thing, in order to build a good foundry, he was the inventor of, if you want, of the business model of a foundry. But in order to make this business model successful, you have to be really effective in cost, you have to design the technology that the customers are going to use, and you never compete with your customers, you only serve your customers. So going to using the CHIPS Act was in somehow breaking the principle of Morris, breaking the principle of foundry in TSMC. The first thing was approving Arizona. Well, foundry is servicing customers, so it's really a customer-oriented business model. The NVIDIAs, the AMDs, the Qualcomms, the Broadcoms asked TSMC, you have to come to the US. If you don't come here, we will find other solutions, because we really fear that the value chain will be broken again and we will not get the chips we need. So the US is about 60–65% of TSMC revenues, so it was a difficult decision for Morris, but at the end, he swallowed this decision because the customers asking for it. The next one was Japan. Japan, especially Sony and Denso, already customers of TSMC, they also asked for you have to come to Japan. This was relatively easy for many reasons. Keep in mind that Taiwan was Japanese for 50 years until the end of the Second War. So the connection with Japan is very, very high. Not only that, it's very, very close. So flying to Taiwan, very easy. The working culture, also quite similar, right? So to Taiwan, so very heavy workers, very committed workers, so relatively going to Japan was quite easy. Now, the next thing was my job of convincing TSMC to do something in Europe. Let me tell you how I did it. It was not easy. I was requested several times to stop, and I say, well, to stop the project, and I say, I don't stop the project, I only delay it. And my management said, okay, you delay it, you delay it. The main issue was, well, having behind all the, especially the car industry. So the car industry was calling Taiwan, was really pushing, because the main industry in Europe for semiconductors are industrial and automotive. There are not yet computing companies in Europe, okay? And photonics, yes, it will come, but it's still emerging, but we are counting on you. So I have the car industry pushing, and then I found 3 partners that are each of them owning 10% of the Dresden fab. So Bosch, NXP, and Infineon. So the 3 major customers supplying to automotive. So with all of this, then finally I was able to convince TSMC and also the EU. So in August the 20th, we have the groundbreaking ceremony. Luke was also there. Here you have the picture. Let me try to show you the people. Well, I think you know Ursula von der Leyen, the president of the EU. This is C.C. Wei, CEO and chairman of TSMC. This is Scholz, German chancellor. This is the chairman of Bosch. Then this is Hannebeck, the CEO of Infineon. This is the last one, and is the mayor of Dresden. Ursula, this is Kretschmer, the minister president of Saxony, and this is Martin, who is the strategy officer of NXP. So I think we finally made it. We did the groundbreaking ceremony, and I think it's going to be a fantastic first step in Europe to really build a strong and important semiconductor industry. And this is only the first one. There is land for a second fab, because scale is critical in foundry, so only one fab will not do it. We really need to have 2 or 3 fabs together. And with that, this is the model of the fab in Dresden. This person is the CEO of the fab, ESMC, European Semiconductor Manufacturing Company, instead of Taiwan. And this is the president of the fab that I hired. He used to run the Bosch fab. So again, innovation is critical. And the fab is not going to be just to have a fab in Europe. It's going to really unleash an ecosystem around. Because together with R&D, I think this is how you really create small companies that become big companies, and then you create an ecosystem that is going to be the foundation of the wealth future for Europe. So thank you, and enjoy, and please bring orders to the fab.
Thank you very much, Maria. Thank you so much. Maria will be with us during the day. I know many of you want to meet her in person, and we all want to ask her, if we are an emerging technology, what advice semiconductor industry can tell us so we can not be emerging for so many years, because we are very mature. So I would like to now, seriously, for me, it's a really huge honor to give the floor to the CEO of the most important semiconductor research technology center in the world. Ladies and gentlemen, the CEO of IMEC, Luc van de Hoven.
Welcome to this session, where we're honored to introduce Luc van den Hove, the president and CEO of IMEC, a world-leading research organization with headquarters in Leuven, Belgium. With over 5,500 employees and operations across multiple continents, their cutting-edge research is advancing crucial technologies for next-generation communication systems, healthcare innovations, and sustainable environmental solutions. IMEC plans to expand its global presence with the recent signing of an MOU with the Spanish government and the region of Andalusia, with the intention to establish a new 300mm R&D process line for specialized chip technologies in Malaga. This will further strengthen its role as a key player in the global technology landscape. Luc van den Hove has been a pivotal force behind IMEC's remarkable growth and influence. Under his leadership, IMEC has consistently pushed the boundaries of what's possible, establishing itself as a critical partner for industry giants. Please welcome our keynote speaker.
Well, I would like to thank the organizers for making such an impressive introduction video. And I would also like to thank the organizers for inviting me to give this keynote at this impressive forum. This year marks the 40th anniversary of IMEC, and I want to begin by taking a trip down memory lane, going like 40 years back. Some of you might find it hard to believe, but this was cutting-edge technology at that time. Tape recorders, videotapes, floppy disks. Well, what a change we have seen in those 40 years. Today, young people even rarely make phone calls. They chat, use Insta, TikTok, all on a small device that has the most sophisticated cameras with powerful embedded AI for image recognition and even simultaneous translation. We all have a supercomputer in our pocket now. The world has changed in 40 years in ways we could not have imagined. The explosion of technology applications that we have seen over the last few decades has caused a revolution. And this, combined with the AI revolution that we have seen over the last 2 years, I mean, this is truly phenomenal. We can fairly refer to it as a Big Bang. And it's all the direct result of Moore's law. With every step of miniaturization, more complex devices can be made. With every step of technology, more powerful applications become possible. Last year was the year of generative AI. With the introduction of large language models, such as ChatGPT, artificial intelligence has suddenly become accessible at everyone's fingertips. But initially, AI was off to a much more difficult start. It's only through the recent availability of massive compute power, to a large extent enabled through Moore's law, that the AI burst actually could happen last year. The compute needs for AI have been exploding, and recently, model complexity grew at a rate of more than 2 times every 6 months. In fact, faster than Moore's law. And this led to a massive expansion of compute capacity in data centers. However, just expanding those data centers in an exponential way is obviously not sustainable, as their energy usage would also explode in an exponential way, eventually requiring more power than what is available on Earth. So we need more energy efficient, more performant compute platforms. And this has been realized by the transition from classical CPUs towards GPUs, GPU architectures that leverage massive parallelization. Now, orders of magnitude compute efficiency have been realized by this move from CPU to GPU. And this in combination with, of course, drastically increasing the number of transistors per compute unit, reaching up to even 200 billion in the most recent examples. This has been achieved by using the most advanced technology nodes, and this in a chiplet configuration. But we're here today to talk about what is next. Only a continuation of Moore's law, we believe, and this in combination with new architectures, architectures even beyond GPU, will allow energy-efficient implementation of this exponential increase in the required compute power. But also, the AI models will evolve. The recent revolution in AI has been realized by using transformer neural engines to train these large language models. But if you want to evolve closer towards true intelligence, a combination of multiple models may be needed, each serving a specific purpose and interacting with each other. An AI system that can combine large language models, perception models, and actual models, gradually evolving to some form of reasoning. Whereas the GPU architecture may be ideal to implement large language models, to implement this next vision, we may need a broader variety of alternative compute architectures, each optimized for their specific AI workloads. This will actually drive a need for more versatile chip architectures and technology platforms, such as 3D, but also silicon photonics. A one-size-fits-all approach may not be optimal. Now, one way to combine these multiple chip platforms is through chiplet integration. The progress in 3D heterogeneous integration now allows for extremely high bandwidth interconnections between those multiple chiplets, nearly similar as if everything was integrated on a single chip. This allows the build-out of these massive compute systems, much bigger than what would be possible on a single chip. Now, whereas the HBM memories are nowadays configured as a 3D stack of DRAM chips, each of the processors is typically fabricated as a single monolithic chip. As the next wave of 3D integration, we have proposed several years ago to further disaggregate these systems on a chip into multiple layers, stacked using advanced hybrid bonding and true silicon via technologies. By splitting up the chip in different layers, each layer with its specific functionality, we can now optimize the process technology for each part of the chip. It actually allows one to also bring the memory much closer to the logic circuitry, which is very important for many AI applications. We could even consider to split up the logic layer into two layers, into multiple layers. One in which we optimize the transistor for density, another one where we optimize for drive current. This will allow us to scale the dense transistors much further than when the transistors need to be optimized for all requirements simultaneously. We refer to this approach as CMOS 2.0, a platform to further extend the scaling roadmap beyond what we currently assume possible. On this slide, we present our latest view on how we believe this roadmap can be further extended for many more generations during the following at least 2 decades, we believe. Whereas gate-all-around transistors, these nanosheet devices, will be standard as from the 2-nanometer generations, probably lasting for 3 more subsequent generations. A few years ago, we presented the CFET device, a complementary FET device, as the next possible device architecture. CFET is an extension of this nanosheet concept whereby we're stacking NMP transistors on top of each other. And by stacking these transistors, we're obviously realizing a significant scaling effect beyond litho-based scaling. However, by stacking those transistors, it becomes increasingly difficult to reach out to all the terminals of these transistors. We will need a rather complicated local interconnect structure. To leverage this density advantage that we obtain by stacking, we will need dense interconnects not only on the front side, but also on the back side of the wafers. This cross-section shows a TEM of the devices that we have recently demonstrated, fully functional CFET devices with backside interconnects. We're in this way, in fact, extending our roadmap by introducing a backside interconnect roadmap based on advanced wafer bonding with ever more stringent bonding requirements. Now, to realize terabit scale connectivity, silicon photonics clearly have emerged as a promising solution. By leveraging the mature and high volume manufacturing processes of the semiconductor industry, silicon photonics offers high bandwidth, low power consumption, and low latency in a cost-effective manner. For several decades, we at IMEC have been developing our silicon integrated photonics platform, thereby leveraging massive CMOS integration knowledge. We are continuously fueling this platform with new advanced features. This platform is available for industry for prototyping and low-volume production. We have a clear roadmap to further develop optical networking to meet the requirements of AI and HPC systems. Our state-of-the-art silicon photonics enables 800 gigabit per second and first-generation 1.6 terabit per second pluggable optics. Looking ahead, we're working on hybridized photonics, silicon photonics platforms. These platforms will push the boundaries, supporting pluggable optics up to 3.2 terabits per second connectivity. And wafer-level co-packaged optics aim to achieve further 100x scaling in optical interconnect performance. Wafer-level optical interconnects are likely to replace long-range copper interconnects by leveraging 3D-enabled silicon photonics. Now, how the future will look like exactly is obviously hard to predict. But what we do know is that the advances in these technologies and systems will kind of touch every corner of society, way beyond what we can imagine today. The automotive industry, for example, is undergoing one of its biggest transformations ever. To achieve the EU goal to reduce road fatalities to near zero by 2050, significant advancements in vehicle safety, particularly through advanced driving assistance systems, will be required. Advanced systems that can kind of mitigate human driving errors. Now, next to camera sensors and radar systems, LiDAR scanners are indispensable for smart cars to build an accurate, real-time picture of their surroundings. However, mechanical LiDAR sensors with rotating elements are too bulky and far too expensive. Integrated photonics will be indispensable to make them affordable and with appropriate form factor. The ideal solution is to integrate all the LiDAR components on a single chip, including an optical phase array with automatic calibration and antennas to accomplish the beam steering through controlled phase modulation without any moving parts, containing an integrated, custom-designed 3.5 laser source. A novel 2D detector array achieves coherent detection. And on-chip electronics can manage the calibration and signal conditioning detection and processing. An ambitious concept for which we are developing the enabling technologies and photonic electronic building blocks in collaboration with our Dutch colleagues in the Photon Delta program. To process the huge amounts of data coming from all these sensors, massive in-car compute capabilities will be needed. Last year, we have launched our automotive chiplet program. Within this program, we're developing the concepts for future super complex electronic control units to be configured in a flexible way, hence based on chiplets. We're doing this by bringing together the key players from the entire automotive ecosystem, including leading car manufacturers, tier 1 and tier 2 players, and chip and EDA providers. Microchips, integrated photonics, and AI are also transforming the healthcare industry, accelerating complex diagnosis, optimizing the efficacy of drug testing, and providing building blocks, the building blocks that are required to enable personalized therapies. We have witnessed the genomic revolution. As a matter of fact, many of the leading sequencing companies have partnered with us to build their next generation sequencing chip with higher throughput and higher sensitivity using our technology platforms, building on our photonics capability. Now, sequencing the protein actually is the next big frontier. However, analyzing a proteome is vastly more complex than DNA sequencing. To make proteomics accessible in clinical practice, we need scalable implementations for detecting, quantifying, and sequencing these proteins. We can achieve this by using highly parallelized protein sensing arrays that provide single molecule resolution. This involves CMOS image sensors with readout and actuation electronics. This combined with photonics for distributing, modulating, and amplifying the light across these chips. And this in combination with sophisticated microfluidics. All of this is being developed in our 300mm facility. Another emerging application domain in health where we see photonics playing a crucial role is biosensing. Axitra, an IMEC spin-off, is commercializing our Raman-on-chip technology for rapid therapeutic drug monitoring. The Raman-on-chip is built using our silicon nitride waveguide process module. Photonics has the potential to clearly revolutionize AR and VR technology by enhancing display resolutions and reducing the need for cumbersome headsets. Swave, another IMEC spin-off, is developing realistic holographic projections using advanced sub-wavelength diffractive optics and phase change materials to achieve high pixel resolution. This enables true realistic vision holograms without AR, VR headsets. Another application domain where photonics can be key enabler is clearly quantum computing. We're leveraging a silicon nitride platform to develop scalable and fault-tolerant photonics chips in collaboration with several startups, including Xanadu. Now, the awareness of the strategic importance of chips to enable all of this has increased enormously, especially as Maria mentioned before, during the aftermath of the COVID pandemic, and it has been amplified by the ongoing geopolitical unrest. As a result, as was mentioned, multiple CHIPS Acts have emerged. And if those are implemented in the right way, we believe that these CHIPS Acts will be very instrumental, not only to ensure a more resilient microchip supply chain, but also to further tackle the phenomenal innovation challenges. However, the various CHIPS Acts need to be done right. They need to result in an acceleration of the innovation process. Each region clearly has its strength. Also, Maria mentioned this. However, if the CHIPS Acts would be set up such that each region would try to do it all, try to become fully self-sufficient, we strongly believe that it would result in a major setback. To make real progress, the fastest possible progress, we need to rally the experts from all over the world. We should avoid duplication. As the R&D challenges are unprecedented, to tackle these effectively, we need critical mass, and we need to combine the best of the best through global collaboration. And that's what we're doing in Europe. By setting up these pilot lines, and these are the 3 first that are being set up, by setting up these pilot lines in a complementary way, each focusing on our strength, not duplicating, but collaborating. And I'm excited that IMEC has been selected to act as the primary R&D pilot line for the most advanced technology nodes as part of the EU CHIPS Act, and has been awarded with a major project that will allow us to expand our pilot line infrastructure. We'll add more than 6,000 square meters of clean room and more than 100 of the most advanced tools. And this amounts to an investment of more than 2.5 billion euro. This animation shows a detailed layout of the first phase of this facility expansion. The first series of tools will be installed in a next module in the expanded shell of our current 300mm fab. In this expansion, we will install more than 100 of the newest tools, including ASML's full suite of advanced lithography and metrology equipment, including the next generation 5200 high-NA scanner. We will then connect this module with the next fab, our Fab 4, which we will start building. This will be another 4,000 square meters. And this is currently being designed. And we will start the construction during next year. This major expansion will allow us to double our capacity and to install all advanced technology capability that we will need for the next 5 to 10 years. We will make these complementary capabilities in these pilot lines available to a large number of competence centers spread across Europe, focusing on chip design, design enablement, and skill development. But as was mentioned, we also signed a memorandum of understanding with the Spanish government and the region of Andalusia with the intention to establish an additional 300mm process facility where we will concentrate our work on specialized chip technologies, and this here in Malaga. The goal is to extend our R&D capabilities with a facility here in Spain focused on processes and materials to boost innovation in upcoming domains such as health and augmented and virtual reality. But we have to extend this model to a worldwide level. Our industry is global. It is one global ecosystem. Therefore, also the R&D needs to be organized on a global level. We should not decouple the continents. As we're doing here in Europe, we make sure that we need to connect the strengths. We have to tackle these huge challenges in the most effective way. I'm convinced that setting up a strategic partnership between these various CHIPS Acts, avoiding duplication and leveraging collaboration will be absolutely essential to effectively support our global industry. Now, on the people dimension, the success of those various CHIPS Act initiatives, but also the success of the growth of our industry in general, will depend on our joint ability to attract and develop sufficient talent. estimation of projected talent gaps are really enormous. It is clear that growing the pipeline, the talent pipeline, is a very important priority. We're facing challenges in many aspects of our education system related to content, infrastructure, and format. We're therefore rolling out a comprehensive talent development program targeted to all layers of education from primary, secondary school, over higher education to lifelong learning. A better match between curricula and the needs of industry will actually be crucial. And this is where we can play a role, obviously in strong partnership with our university and high school partners, also here in Spain and in Malaga. Because indeed, the opportunities for our sector are clearly endless. The swift integration of microchips, photonics, and AI into every aspect of our life is truly remarkable. And we at IMEC are putting everything in place, our partner network, our infrastructure, and our amazing people to contribute to enabling the roadmaps to build this future technology, starting from a rich legacy, our 40 years of history, but above all, with a promising future in sight. And that future starts here, and it will be one to love. Thank you.
Thank you very much, Luc van der Hoven, for being with us today. I know many of you have questions. He will be a panelist later today next to the CEO of TNO. Doesn't get any bigger than that, and interviewed by the Jim Kafka, president-elect of Optica. That will happen later today. But now, in all our industry events, we want to always have a CEO panel. We want the leaders of this industry to tell us where to go in 5, 10, and 15 years. And for that, I want to bring on stage the moderator of the CEO panel, CEO of Lightweight Logic, chair of the Corporate Engagement Council, and Optica board member. The person I'm bringing on stage is author of more than 450 patents, and is also a personal mentor. Ladies and gentlemen, Michael Levy.
Well, morning, everybody. Let's call the panel members up. So, Chuck, would you like to come up? John? Let's see where John is. Then we've got Thorsten, and we've got Matt Crowley. And so the companies that represent today, let me turn this chair around a little bit. A quick introduction. Chuck Matera here is recently retired chair and CEO of Coherent, one of the biggest optical component companies in the world. Next to Chuck is, I believe, is an old colleague, also from Bell Labs. I guess all three of us were Bell Labs at one point, is John Lee, who's the CEO of MKS, one of the biggest companies that deal with analytic systems and measurement, includes a lot of photonics. To John's left is Matt Crowley. Matt Crowley is the executive VP of, actually as of yesterday I said Jabil, but actually it's Jabil, I believe, right? Is the correct pronunciation.
That's correct.
And Matt comes from an extremely high-end technical background with Amazon and Dell, and really is leading the charge in optical networking. And the last person is Thorsten Mayer, who's the CEO of Vanguard. But Vanguard recently was acquired by Micronic. We originally had Anders here, but Anders actually 2 days ago got COVID and decided it was probably better for everybody that he just stayed away. And so we're glad to have Thorsten join us today. We have this panel, and I think I've got about 45 to 50 minutes. And just to get things going, because I don't want to speak all the time here, I've got one simple question. When I was 9 or 10 years old, I tried to figure out what I wanted to be when I grew up. And I think at that time I wanted to be a football player. I'm from England, so that's actually soccer. And that only lasted like 6 or 9 months, and then I realized I was really a techie. So Chuck, let's go down the line. Well, give everybody a feeling of when you were growing up, junior school, high school, did you really want to be a techie, or was it something completely different?
I did. My high school chemistry teacher inspired me, and I wanted to be able to connect the people of the world. And so in combination with both material science and other technologies, that's what I pursued.
John?
I think I was more like you, Michael. I wanted to be a baseball player. I got through 1 year of college, and I realized I wasn't smart enough or good enough to do either together. So I chose the more safe route and became an engineer. Yep.
I like that. I did the same thing. Huh?
Growing up, I wanted to be Michael Jordan.
Oh, wow.
But now I'll be happy if I get to be a retired grandfather one day.
Excellent.
Yeah, so I couldn't have been further away from becoming an executive. I wanted to become a professional session drummer and perhaps play in a famous band at some point. And that was could potentially be a reality till I told my parents. And I became an engineer after all.
Isn't it interesting that when you grow up, you really don't have any idea what your career turns out to be? But anyway, let's go to the next question here, and we'll go down the line. I'm not going to get into any techie strategy stuff for the second, but in terms of leadership, I mean, all of you are pretty much at the pinnacle of your career in terms of leading companies and leading technologies, but what are the 2 or 3 things that is really sort of you could convey to the audience that you've experienced over your career? I mean, what are some of the metrics? Chuck, I mean, how would you look at that?
Well, I would say beyond having functional knowledge in both technology, markets, and a bias toward business, I think the most important characteristics that had to be developed and practiced in a role like the CEO's role are humility, empathy, and a bias for urgency and action. That's it.
Simple as that. That's pretty succinct. John, are you similar?
Yeah, I agree with everything Chuck said. Hopefully we're not at the pinnacle of our careers, but another discussion. I would say, in addition to that, I think you're a people leader now. Right? You're not a technology leader or a business leader. You are trying to do something with people. And if you get good people around you who feel included, you have a much better chance of that organization being successful. And that becomes harder, especially with our particular history, where we went from 2,000 people 8 years ago to 10,000. So you're trying to scale, and then trying to teach everybody the kind of culture and evolve the culture. At the same time, trying to make everybody feel included. And when you're in a smaller company, it's easier, actually. You feel like a small team. It's much harder as you scale to try to get 10,000 people to feel as if they're in a 20-person startup. So I think that's where I spend a lot of my time.
That's good insight. Matt?
Yeah, well, I agree with Chuck and John, absolutely. The one thing I would add is, we try very hard to create a culture where people are unafraid to fail, especially in this industry. When you're trying to innovate, fear of failure can really keep you from achieving the goals that you have. And so in addition to everything that Chuck and John laid out, I think, a focus on don't let a fear of failure keep you from executing.
Good, it's good insight. And Thorsten?
Very difficult to follow these 3, but maybe a little bit of an anecdote from my own life. So when I joined Vanguard, I joined as an outsider, both market and technology. So by definition, I wasn't the guy who knew everything. And so it really requires, especially in tech, and we were still an early stage company. If you want to build something that can grow, you have to bring strong people in and empower them, and not build something that's centered around yourself. So that's been for me an interesting stretch, right? To come into something that you don't know, but build a team, empower them. Don't be afraid of having people on your team that are stronger than you are. That's something you got to be able to deal with and live with, because it helps the company. And then as you keep growing, another thing, so it's very easy to get distracted in one or the other direction. I'm a big believer in focus. And so spending my time on and focus and really questioning, is this going to help our mission? Are we staying on track? Is another thing that I would probably add. Otherwise, everything that's been said 100% agreed with.
Yeah, one other thing is, we sort of develop our own careers and we become, people sensitive because we're managing large organizations. But have any of you looked at giving back to the community? I think you have something at 2.6 Coherent that gave back to the community. Is that?
Sure, I can make a comment on two planes. One, before I talk about the Coherent Foundation, maybe make a comment about mentoring. So many of us in this community, like me, have been in the community for 25, in some cases 50 years. We all owe a great debt of gratitude for people all around us, for helping teach us, for mentoring us. And I would like to point out that John, 25 years ago, we had a relationship where I was John's supervisor.
Yeah.
And I learned...
Still turned out okay.
I learned what a remarkable person he is and what a great leader he is, among the very best in the industry. And he has all these characteristics, including of mentorship. Finally, the co-founder of 2.6, now Coherent, established with his own money, with his 2.6 stock back in 2007, had a desire to give back to this community to help create the future leaders. It established a scholarship fund, and until now has granted $40 million of undergraduate and graduate research grants, both in the US, in Europe, and in Asia, to be able to prepare the next generation of people who will sit in a place like this, who will be thinking about the next 25 to 50 years. And it's really an extraordinary example, which I encourage everyone to think about.
Similar to other large corporations, you have internship programs and scholarships and localized. We give a lot of the local organizations kind of a little budget to do whatever's important for that locality, because it's very different, especially if you're global. I think the only other thing I would add is when we looked at our markets and how they were evolving, the first thing we tried to do is educate our own people about what our markets were. This was semiconductor manufacturing, and then it went to photonics, and now advanced packaging. And we really didn't have a way to teach our own people how to do that, and so we wrote a book, internally. And then we made it free. So on the website today, you can get a semiconductor processing handbook. Now the first half is very much how do you do it. The second part is a commercial. This is where MKS plays for sure, but you don't have to read the second part. And then there's a photonics one, and we're working on a packaging one. It's just a way to help brand the company, but also to give back and to as Chuck said, teach and give back that way.
Matt, do you have anything to add?
Very similarly, we have Jabil Cares Foundation, and in times like this in Florida, our headquarters is in St. Pete, Tampa, and so we're very actively in helping the community rebuild as the hurricane just came through. One of the other things that we've looked at and are currently doing is providing scholarships specifically in geographies like the U.S., where there's a lot of discussion already today around geographies and regionalization. And so there's a lot of this technology that could be reshored, but then if you don't have anyone who knows how to do it, there's not much point in reshoring it. So we're trying to seed scholarship funding around specific locations to help ensure that there are folks who have the access to that education when it does get reshored.
Cool. And Thorsten, do you have any, you're close to Anders, so you're new to the...
I was just thinking, am I speaking on behalf of Mycronic or Vanguard? But I think I can wear both hats. Obviously, there's community outreach, internships comes to mind, even at Vanguard. So maybe Mycronic is not one homogeneous company, so we're sort of discrete divisions, if you will, and each of them is active in their own regard and a little bit in their own mission, obviously tying into the overall goals of Mycronic. So there's donation programs, there's internship programs. One thing we do is even as a smaller company, Vanguard Automation, we have lots of internships and people writing there, getting familiar with advanced packaging, teaching them. We have people from all over the place. So it's really working on getting the technology out and giving people a chance to become familiar with things they will not learn at university.
So let's ask an industry question, because let's get to it. A number of us remember the bubble, and I think I asked this question to you before. But in 1999, 2000, we had the internet bubble where everything went crazy, all the markets went crazy, everybody's market charts just had dog legs and things, and that bubble burst, and it's probably taken 10, 15 years for the industry in general to recover, and that included the photonics industry. So if you look back the other 18 months, 24 months, everybody's talking about GAI, generative artificial intelligence. Everybody's being really excited about more computational processing. I want to go down the line and just give everybody a feel. Are we in a bubble today, or is this something that is going to last, or is it everlasting? Be good to have your perspectives on this.
Yes, someone said when you're in the business of forecasting, you should forecast often. And I think it's a good reminder that it's very difficult to see 5 or 10 or 20 years out with any great clarity. But for sure, it feels like the intersection, to me, the intersection of electronics and photonics is now at a point where it is sustainable. So I don't believe for a minute that there's anything but more innovation to come inside this envelope, and I believe it will drive sustainable growth for decades to come.
So you don't see this as a sort of a bubble effect? This new renewed demand, if you like, is not going to go away?
I don't.
Okay, well, that's one for sustainability in terms of continued demand for a lot of our technology. I mean, John?
Yeah, I'm in the camp with Chuck, and I don't lose sleep on it because we look at AI as just the next thing in a string of next things that have been enabled by Moore's Law that Luke just talked about. So, if you think about Moore's Law and what it enabled, the most important one, I thought, most impactful for me personally, was as a sophomore leaving college, the computer room was a bunch of dumb terminals because the computer was in the central part of the university. There's only one, right? The big one. And then you come back junior year, and the room is full of dumb terminals, with boxes beneath them, right? What are those? Well, those are PCs. And remember what P stands for, right? Personal. Think about that. Every human being in the world can now afford to have one. Then you could carry one, and then you could carry one in your pocket, and you can talk to everybody in the world. And all of that is enabled by this relentless Moore's Law. And so, as Luke pointed out, AI, the concepts of large language models have been there for a while, maybe a decade or two. That's not the news. Right? The news is that you can actually do those computations affordably now. And that's when the public says, oh, it's useful. I can actually write my term paper. I can write my speech. I can search all kinds of things. So that's why I think it's just actually very sustainable. It's just the next thing. And the next thing after that is who knows, right? But if you keep making chips twice as efficient or half as cheap every 2 years, which we've done for 70 years in a row, then something new will come about as well.
So this is not a bubble. You see this as sustainable growth.
It's the next thing. Yeah.
Okay, Matt.
I'm relieved to hear Chuck and John's answers, frankly. So, I would say intuitively, when you look at the trajectory that's being driven, it's hard to conceive of it continuing to go up and to the right. But I agree with Chuck and John. I do think that AI isn't going anywhere. I think the effect that has on the industry is not going anywhere. Part of our job is to ensure that we have a strategy that's resilient regardless of what's happening in the industry. And so we've spent a lot of time looking at ways to add value in different places versus just focusing on high volume scaled out manufacturing. So, and then you think about some underlying trends where data centers are going to move from being air cooled to liquid cooled. And they're just getting going in these cycles of innovation, scale, and commoditization. And so we're on the front end of the innovation arm. So, I'm not going to start losing too much sleep for at least another 2 or 3 years, hopefully.
Well, that's a couple of you that sleep pretty well. I mean, about your...
That's not too bad. Yeah, I like to look at that, two ways. Obviously the big hype that's out there seemed to have some characteristics of the bubble back then, right? From valuations to very lofty expectations. But that said, the technology, I think, has now true potential to transform industries and create real value. It's doing it, in fact. And the other thing, it made me think of when I saw the question, I had an opportunity back then, very early in my career, to get in touch with, I would say, the first potential wave. It wasn't recognized maybe as one with knowledge-based expert systems. And so already at the time, this was the 70s, 80s, I wasn't quite ready back then, but in the 90s, I had an opportunity to work with that technology, but the computational power wasn't there, the tools weren't ready, so the time was simply not ready. But I think, as Chuck said, we are at things are coming together. We have the computational power, we have the tools, the interfaces, everyone is much further along in that, so I expect it to stay around. There might be some, adjustments in the market, but I think this will stay around, will keep growing, will be a very important part of, we can't neglect it.
So whoever suggested this was a bubble, it doesn't sound like it's a bubble at all. It sounds like everybody here believes that we've got some good demand drivers, good sustainable growth. This is incredible. It's exciting. So why don't we take that a step further? I mean, okay, so instead of 2,000 engineers doing machine learning and artificial intelligence, we now have 100 million users using all the different software apps and things. What's the business roadmap look like 5 to 10 years down the road, assuming we have this continual growth? I mean, all right, so demand stays, we get smarter in manufacturing, we get our costs under control, presumably. We have better techniques to analyze and monitor things. I mean, looking 5, 10 years out, what do you see, Chuck?
Well, I think between now and then, especially in John's business, and then from the great story about IMEC this morning, infrastructure needs to be built out. That's going to continue for quite some time. It's obvious. The capacity is inadequate to keep up with the demand. So I think infrastructure is a focus. And I think along with infrastructure, especially in the U.S., the demands for energy are going to continue to exponentially grow, driven by this demand for data, onshoring of reshoring of industrial factories, and then the acceleration of electrification of transportation. So that's going to go on in the backdrop. I think if you try to look out beyond 5 or 10 years, maybe these large language models will help us think about those things more. But the way in which I'm thinking about it these days, now that I'm retired from Coherent, looking out at a different time horizon on a different set of problems, including those involving photonics, I'm beginning to learn and appreciate the potential power of neuromorphic computing as a potentially really valuable technology that mimics the human brain and provides for low power consumption, higher efficiency, and the capability for making decisions with large parallel processing like the human brain does. So that's one. And the other one is I'm interested in both imaging and sensing, especially for the oceans. It seems to me that the oceans have taken a back seat to space. And there's probably among the most vital of environments that will drive innovation in lasers, photonics, camera technology, fiber sensing, for both mapping and monitoring the state of life in the oceans. I think it will be key for our planet's sustainability.
Well, that leads very nicely to John. I mean, you're MKS, you've got three major divisions: vacuum, materials, photonics. You know, you've got spectrophysics. I mean, you do a lot of gas detection and things. I mean, how do you see this, 5 to 10 years out?
Yeah, maybe I'll narrow the question because I think the question could be very broad. One of the things we always struggle with in our original markets, semiconductors, and even now, is this thing called Moore's Law. Can it sustain? That's a big question. That was asked 20 years ago, 30 years ago when I started. It was already being asked. In fact, before I even started my career, people were saying it was ending. And of course, that was wrong. But the real question is, can it sustain? Because if it can sustain, a lot of other problems get solved because we're going to be able to solve them more efficiently. We're going to have better computers, we're going to have better detectors, et cetera. And I think that is the central question for me as I determine the future roadmaps of the various technologies or acquisitions we could make for our company. And when I think about it, that's why we did our last acquisition, which is our biggest acquisition in history, which is 2 years ago, the $6 billion acquisition of Aditech. Aditech is a chemistry company. Mm-hmm. And we are a physics, electrical engineering, lasers, optics, instruments company. And we got a lot of questions, as you can imagine, from investors, like, what are you doing, right? Why? And the strategy 3 years ago was, we think semiconductors are hard to do and will continue to be hard to do, and it will be necessary to continue doing it. So thank God for places like IMEC and ASML and all the other guys. And while it's necessary, it's no longer sufficient. That's a big decision. And it's no longer sufficient because geometric shrink is no longer good enough. That's kind of what Moore said, in a way. So the industry got around it by saying, let's put chips together. And I love your slides, Luke. I'm going to use some of those. The animation's awesome. Let's put more chips together and figure out how to get them to talk to each other really fast. That requires something called interconnection. And that interconnecting substrate is just as important now as the semiconductor. You can't have one or the other. You have to have both. And so we said, we want to be a foundational technology company to whatever market we want to be in. That was semiconductor equipment. We did that. But if we see that packaging is going to become more important, we want to be a foundational technology provider to that market. And what does that require? Well, chemistry. Before chemistry, remember, there are lasers drilling holes, millions of holes per second in these interconnects. And you fill it with copper, and you put one layer on top of another on top of another. And there are now interconnects that are 20 to 25 layers thick because you have to put all these NVIDIA chips and all the memory together. And 15 years ago, 4 layers was like, that's hard to do. 6 layers is really hard to do. And now people are doing some things in the 40 to 50 layers, 1 layer at a time, these interconnecting substrates. So we said we want to be ahead of that. We want to have that portfolio in our company because we think being together is better. We can leverage and synergize and get to solutions for the industry faster. So I think we've kind of placed our bet. We think the roadmap for Moore's Law, or more than Moore's Law now, will continue because of packaging, and we want to position the company so that we are foundational to that beyond more than anybody else.
And that leads in really nicely to Matt. I mean, I was going to ask you the generic 5 to 10 year roadmap question, but you guys just picked up the Intel transceiver division. And so you're this very broad manufacturing company that's actually dug into optical transceivers. And I bring that up because we're a photonics audience here. But, from your perspective, 5 to 10 years out, I mean, do you see yourselves going up the value chain or down the value chain? I mean, I don't think you're going to get into semiconductors or silicon photonics because that's, we've got IMEC and Global Foundries and a few others, right, TSMC.
Yeah, I think so. So our strategy is always informed by our customers. We spend a lot of time listening to them. And we have very intentfully gone about building capabilities that we not only hear them asking for, but also we believe add more value that will help us create more accretive margins to our enterprise. That said, it's a big part of why we invested in the transceiver business. It's a big part of why we did the deal that we did with Intel. I think 5 to 10 years from now, I think as co-packaged optics evolves, as on-chip solutions evolve, that's part of why we invested in the capabilities now. That's why we've launched an NPI line for silicon photonics, OSAT in Ottawa, because we really believe that that is the future, and it's really hard to call the inflection point of when that creates scale and manufacturing really cranks up. But we think that's where things are headed, and that's why we're investing in the space. So we always look to move up the value chain where we believe our core capabilities add value for our customers, and we hear from them that they do.
Great. And Torsten, I mean, from the Micronic perspective, I mean, when I look at Micronic, I mean, you've got your classic test equipment, die bonders and things for the electronics industry, and now Micronic has gone into the photonics with Vanguard with some very innovative polymer-based technologies. I mean, how do you see that sort of over the next few years?
Let me try to answer this a little bit, maybe taking a step back, because I'm not sure how familiar everyone is with Micronic. So Micronic is a world-leading company in high-precision manufacturing equipment for electronic semiconductor. And the key markets, or the core markets, have been semiconductor and actually display manufacturing. And Micronics has grown tremendously over the last 10 years through innovation, but also very systematic M&A. And like you said, Micronics works very closely with their customer. A lot of the innovation is customer-driven, working together on helping to solve essentially their manufacturing challenges to make the electronics of the future come to life. And being working with many large industry players, it's very undeniable that photonics is going to play the key role, if not the role, in tackling the future challenges related to the data we need. Don't have to go into too much detail. And so that primarily has, that's been recognized. And so one of the moves very recently was to bring Vanguard on board, essentially complement the experience that has been built in several manufacturing disciplines, such as quality, process optimization, analytics, services, and also that in the framework of a very strict compliance framework, and combine that with photonics technology and really create another vector that we can work and support our customer base to be future ready. And maybe an add-on, actually, Vanguard is not the first acquisition in that space. Several years ago, many might be familiar, also MRSI became part of the Micronics family. So there's a strategy behind this, and especially in this space, we also see synergies between MRSI brings die bonding, active alignment technologies to the table, and we bring some disruptive packaging technology to the table to expand that offering, and in combination with the experience from semiconductor electronics manufacturing, become a value-add partner for our customers.
Got it. I just want a quick time check. Jose, how are we doing for time? Doing good? Okay, I got a different question.
Yeah.
So we heard from Reinhard and we heard from Jose at the start of this session. This is the photonics industry. And so my question to all of you is, some of you have got semiconductor backgrounds, some of you have got different types of networking backgrounds, even pure optics backgrounds. What does the photonics industry mean to you? Because, I ran OIDA, the trade association, a decade ago. O stands for optoelectronics, which doesn't get used these days. Everybody uses photonics instead. But the difficulty we saw a decade ago was photonics enables many different applications, many different industries, yet it's critical. So my question to all of you, and we'll start with you, Chuck, what does the photonics industry mean to you, and how can we really sort of get some momentum here?
Well, I think when I think about it over the last 20 or 30 years, it's been a journey, including in the U.S., the organization that you led, Michael, at OIDA, and it's morphed and it's transformed itself into a different community. I think this meeting, this Global Business Forum, is potentially a turning point for the conversation about it. A $368 billion addressable market seems to warrant a trade association. The semiconductor industry have enjoyed that, but it took them decades to build it. And they built it up against a force that came about as a result of regulation. And I think the challenge that we as a photonics community have was pointed out nicely by Reinhard. It's got fractions of technology, and on top of that, here comes an evolving regulatory overlay. And it needs to be considered first and foremost, in my mind, to everything that an organization like Optica thinks about. Because the roadmap for the regulatory environment over the next 5 or 10 years is likely to drive additional forces on a trade association like Optica. Not that it is a trade association, but it's headed in that direction. And I think I have to hats off to Jose and Optica and the entire team for really having done a superb job. But I think there is much more work, as Reinhard pointed out, that needs to be done.
Oh, agreed.
Okay.
You know, this is the beginning. I mean, John?
Yeah, I think we probably think about photonics more broadly than what than this organization might think of. And so with the acquisition of Newport Corporation, which had 20 different acquisitions of different types of companies, we try to describe it because it's complex. And we describe our company as surround the wafer, all the semiconductor products, 20 or so, and surround the workpiece as the second strategic explanation of why the products we have are the products we have. And when we say surround the workpiece, we're surrounding a workpiece that needs light to do something to that workpiece. So solar actually is that for us. Laser processing, absolutely. But if you think about laser processing as an example, drilling holes in PCBs, or making light to look at wafers or print wafers, for instance, there's a lot of other stuff that goes around it that is critical. So I have to be able to detect the laser beam. I have to be able to detect the shape of the laser beam. I have to be able to have the optics to get the laser beam from where it's generated to where the workpiece is. I have to move the workpiece around, right, fast and accurately. We call that part of our photonics solutions portfolio. So when we think about what else to develop organically or what else to acquire inorganically, we look at that wheel. Is this around the workpiece and enables something that uses a light to do something to that workpiece? If it's critical and enabling, we're interested. And so we actually broaden our view of what photonics is. And it's probably not the same as Optica is defining it, but as Chuck said, why not broaden it? You get a bigger pie. A lot more people will be a lot more interested.
Absolutely. I mean, it's a very different perspective than actually manufacturing optical components and modules and things. Matt, well, what's your perspective? I mean, you're high-volume manufacturing.
Yeah, so Jabil's been around 50 years. Core competency is around manufacturing at scale, and we operate in a razor-thin margin industry. Photonics for us really represents a commitment to invest in capabilities that are not necessarily indexed on returns now, but rather in the future. And so that's a material shift that we've driven inside of the company, and the commitment is we see photonics as opportunistic near term, which is a part of what we did with Intel last November, but we are really investing in the capability long term because we see the strategic value out in time and what's coming. So for us, it's a really big deal, and we're committed to it as an entire company.
Cool. And from the Micronic perspective, Torsten?
Not sure whether I give you now my Macronic or my Vanguard perspective, because the Vanguard perspective has me a little bit closer to the subject. When I joined this Vanguard, it was all about data and telecom. But if you take a closer look, the technology is proliferating, almost everywhere. From my perspective, it becomes an underlying technology that's enabling technology that's paramount for probably lots of the innovation to come moving forward. And it's a bit of I would say it's a blessing and a curse. It's a blessing in the sense, I think there's a lot of room to grow and to develop for all of us here. It's sometimes a curse in the sense of it really, us as a company, if we want to offer value-add solution, rather it forces us to narrow down and to develop standards and to have agreed upon interfaces to be able to create something that really becomes scalable. So one of the things that sticks out to me is if I look at the Euler report and you see the forecasts up to the right, but then you see against it the volumes that are being manufactured, which are still rather low. So I want to see these curves converging. And I think I see photonics as a tremendous opportunity, but also it'll force us to become very disciplined to deliver solutions and value.
Yeah, with deep roots from the electronics and semiconductor industry. I got the message from Isaiah. We've got a few minutes, but is there any obvious questions that folks really want to ask this panel from the audience? Yeah, there's one here.
I'm coming to you. Please remind us your name and your company.
There's a couple.
Johan Veenstra from Smart Photonics. I had a question. So one of the things that has driven the electronics industry is the change in how the value chain is built up, right? I mean, TSMC has made a major impact being vertically integrated and moving it to horizontally integrated. How do you see this in the photonics industry? I mean, how do you see the value chain evolve in the photonics industry in the coming years?
Who wants to have a bash at that one?
The most vertical value chain there, Chuck.
Well, okay. Let me take if you look back on it, for 40 years, things haven't changed that much. The importance of the enabling components and the value proposition that's imparted to the entire ecosystem by the advanced materials and the laser components themselves, and the ability to create value all the way through the chain, from invention and revolution on top of revolution. I think more of that's going to stay the same. Yes, the possibility exists for doing more integration, and that's happening and will happen. But at the end of the day, I think the balancing between the functionality and the value, between electronics and photonics, that will continue. And the system people are continuing to take full advantage of that. I expect that will continue as well.
Yeah, I mean, the only thing I would add is if you look at semiconductors, 50 years ago, the people who made telephones needed somebody to make the chips. So they had the same company, was vertically integrated, and they need somebody to make the equipment to make the chips. So that wasn't so rare, right? Because you couldn't buy equipment or chips from anybody else, so you did it yourself. And as industries scale in general, and if they scale efficiently, people start specializing, and you start getting stratification. So we only make the chips, we only make the equipment, we only make the subsystems, we only make the materials. And we don't vertically integrate because we can be more efficient. You know, Jabil's a great example of that efficiency. We're really good at this. We're better than anybody else. There's only 2 or 3 of us, and no one else can actually come in. And so photonics feels like semi 50 years ago because scale yet on the side of semi is not there yet. And so a lot of companies are probably finding, I got to do this myself, so I might as well do it myself. Because there's no other choice. But at some point, there will be another choice if the industry scales. There'll be people who can make the equipment better than you can, more efficiently you can, because they can sell it to multiple companies, right? I think, the company Chuck and I came from, American Telephone and Telegraph, made it all. And now they don't make, not even existing, right? It's just a name. So everybody's stratified, right? Equipment spun off, services spun off, subset equipment spun off. So, that's not a prediction, just an observation of history. History tends to repeat itself, but scale seems to be the factor that drives it.
And do you see enough scale, Matt?
I completely agree with John. I think if you think about the future of photonics, specifically silicon photonics, it is heavily dependent on getting to scale. The demands of the marketplace today require that scale, and so the faster we as an industry figure out how to support it, I think that will determine the trajectory and the timing of photonics in general.
All right, I know time's short. There was another question here.
Lutz Aschke, CEO of the Photonic Systems Group and President of Photonics 21. We heard a lot about the future growth, being future ready. And I would be interested to hear something from you, how you make yourself past ready. In terms of you have this ugly legacy business where customers depend on you for the next decades maybe, but there won't be growth. It's a shrinking business you have. So how do you treat that kind of business? Because it's still relevant, but it's not sexy anymore.
With Semi, we have things that were designed in to a piece of equipment 20 years ago. We desperately ask our customers to use the new stuff. And they desperately say, no can do, because it's expensive. Your thing is $10,000, my equipment is $10 million. I'm not going to redesign a $10 million tool and put myself at risk of competition, because when you tell TSMC, I'm going to redesign my tool because of a $10,000 part, they say, oh, well, we'll bring the other guy in now because you have two different tools. So we do have to figure out how to scale, to your point. 50% of our business is stuff that was designed a long time ago, and 50% is all about the future and the growth. And it becomes really difficult from an operational standpoint because during COVID, when no one can get any chips, the chips that we were running out of weren't the most advanced. We had meetings with TSMC that they said, we can't get the equipment from Applied and Lam and everybody else. And they blame you because we can't get the subsystem to them to make the, and we said, you're absolutely right. We can't get the chips from your old fabs, literally, to make our equipment to give to Applied and Lam to give to you. And they said, which fab? I said, this fab. And they said, really? Yes, go talk, because it's the 12-inch guy building N3, but it's the 200 millimeter guy doing 90 nanometer that has decided, you know what, I've got this long, broad portfolio of chips, a long tail, I'm going to get rid of the stuff that doesn't make a lot of money so I can be more efficient. He's doing exactly what he should do, but he didn't realize he's affecting his own company at the top end. So we use that as a great example to tell everybody, let's try to change. Let's try to get rid of that old stuff. But it's a problem with success. If you've been successful for 60 years, you will have, as Chuck knows, a lot of old stuff. And the reason they can't change is not because they don't want to. The economics or the risk doesn't allow them to, so we got to figure out how to support it, because it is still good revenue. We're not doing R&D, it's done, and so please buy more, and it's still a very profitable part of the business.
Anybody else want to chime in?
I mean, we're a contract manufacturer, so we think whatever our customer tells us is sexy is sexy. So we don't have quite the same issue.
I would agree. I'm probably not the most qualified to answer this question in the photonics industry, just given my tenure in it. But from other experiences, it's the struggle that John explains. And now, at the end of the day, if you want to play in a certain industry and a certain application space where the customer requires that, if you want to play there, likely you don't really get around that. You can kind of keep pushing the boundaries. Now, that being said, usually where that's a requirement, often in my experience is that there's also enough value created to make that happen. Otherwise, you can move to the new thing.
Dick.
Company.
Hello, good morning. Great panel, excellent discussion. Jan Meiser with AMS Technologies. I have a question on consolidation. So there was obviously a lot of consolidation in the datacom telecom space over over the last 20 years, and I'm interested as in what you see in the non-datacom, telecom space, as in how much consolidation we're going to see in the next 10 years.
Well, I know, John, you
just
guys
consolidated a whole bunch, and I just
you
consolidated a
guys
whole
are
bunch.
going after Coherent at the same time, but
You won.
well, paid a lot more money.
Well, there was a B behind every offer. But
Anybody want to address the consolidation? Yeah, go ahead, John.
well, I think, again, the semiconductor industry 30 years ago when I started, there were 30 chip fabrication companies. Now there are 4 or 5. There were dozens of applied materials, Lambs, and ASML was very small back then, and it was Canon and Nikon. Now there are 5. And there were hundreds of MKSs, and now we're a third of the market. So I think consolidation naturally happens when an industry matures and becomes more efficient. I don't think it's almost a law of markets, right? I think, though, that because we are now in photonics as our company, that industry is like semi 30 years ago. Lots of good small companies, lots of startups, lots of innovation. Only a few big companies. I think between Coherent and MKS, there aren't a lot of other, quote, photonics-like companies of the scale. So fast forward 10 years from now, 20 years from now, I've got to imagine that there is going to be consolidation because, to Matt's point, scale is how you get efficient, right? Scale is how, and efficiency is not a bad thing. Efficiency is how we get to live for the next day and how we propagate the products we make to more people because it's more efficient and cheaper.
Jan, did I answer your question? Some degree? Good. Well, we're down to the last couple of minutes, so why don't we just go down the row? Any last comments, Chuck, from your perspective on the view from the CEO, the top, the leadership of the industry?
I don't think so. In my case, that I retired from Coherent in June after 20 years there and 20 years before that at Bell Laboratories and its spin-outs. I'm super excited about what the next 20 years will bring. And I'm focused on my thinking. You heard some of it in my comments today about staying focused on helping enable the world to be safer, smarter, and sustainable.
Cool. John, last comments?
Yeah, no, we're bought into photonics. We actually bought a company,
Great.
Photonics. So I would say this: I would wish the Optica well. I think if you can make this the Davos of photonics, that'd be extraordinary. I would say to do that, broaden your thinking, bring in more people under the tent, and that might make this, maybe better than Davos. Who knows, right? At some point.
Yeah, we can all look to the future here, Matt.
We see photonics as critical to our strategy. We're certainly massively invested in it, and we appreciate the invite to be here at Optica. Thank you, guys.
Cool.
As I mentioned, we see photonics as a key underlying technology that will enable great things to come. And, we're still at a fairly early stage of our journey, so I'm most motivated by all the interesting applications that we work with our customer. But I think what will be important, again, to let's simplify it, let's collaborate, because I think if we want to drive this to scale and kind of fulfill the promise, we need collaboration, simplification, and standards.
Great. Yeah. Well, let's thank the panel for a very interesting discussion.
In an event like this, the most important session is the coffee break. Enjoy this one.
Okay.
Ladies and gentlemen, time for coffee and meaningful conversations. And please visit the exhibitor booths outside. We're delighted with the support from the following organizations:
SECFO, Fotónica 21, IMEC, Keystone Photonics, Malaga Tech Park, PIC UPD, PIC Spain, Vodafone, Disruptive, IFOS, Innova IRB, Cadence, Photon Hub, Bullnet, Vanguard Automation Micronic, GDS Factory, Bioherent, Vigo Ventures. Invest in Andalucía, Andalucía Trade, Junta de Andalucía. As I said, the main reason we're all here are for the coffee breaks. I hope all of you are making those meaningful connections. For those of you who went outside, who of you already, I mean, we are the first evening and now had the first break, who have already made a connection that you think you're gonna maybe follow up with afterwards? This is like 60%. Okay, after the lunch break, we are done. We can all go home. Thank you very much, all of you, for a great part of the event. I got great feedback already. The next session is really important for us. One of the main accomplishments that we want to do in the next years is to really connect the industrial research with you, with the executives. And for that today, we have a great panel with one of the best panelists we can think of. Ladies and gentlemen, the President-elect of Optica and Emeritus Fellow of MKS, Jim Kafka.
Staan we nog allemaal op.
Welcome, everybody. It's my first time in Malaga. It's obviously my first time at the Global Photonics Economic Forum. I'm looking forward to being able to say something different next year when we all get together here again. Very pleased that Jose and the rest of the gang have put all of this together. Oh, we're getting fancy chairs because we're more intimate. That's great. A little introduction of me, but that's not why you're here. I've spent the last 41 years at Spectrophysics building lasers. And for the last 8 years, I've been part of John Lee's MKS photonics business and learned a whole bunch of other things. But I'm a laser person from way back, of course. But I wear another hat. And that is I'm president-elect of Optica. That's exciting. That means next year I get to be president. They're going to send me a bunch of places. We have several of our board members here as well as our chief operating officer. And so it's wonderful that Optica has been able to support all of this. We're happy to get more suggestions on other things we can do for you. To reiterate one of the themes from earlier, it's certainly all about connections, but connections are all about people. And one of the things I love is that our CEO, John, talks about people, and it comes from the very top, and it's something we do in Optica as well. So unifying my two hats, people are very important. Making connections between people is very important. That's really what it's all about. So I'm going to welcome our panelists to the stage. Both Chark and Luke, please come on up and join us for the conversation. And please welcome them. Albert sends... Albert sends his regrets. Just yesterday, he became ill and was not able to join us, but we're going to have a lovely, intimate conversation anyway. So in order to get the introductions exactly right, I asked our two panelists to please show us a pretty slide of where they work and who they are, and we'll pull up the first slide, and let them tell you a little bit about how they come to be here, how they come to be at their company, and what it is they actually do. So could we cue up the first slide, please? And go ahead, Chark.
Thank you very much. I'm Chark Chin. I have been the CEO of TNO now for a little bit more than 2 years. Before that, I was CEO of Sanquin, which is more or less a sort of a biotech company, which also includes the Dutch blood bank. Before that, I was Director General of Statistics Netherlands, so CBS we call it in the Netherlands. But I have a background in theoretical physics, quantum field theory. And so I'm kind of back on base with my technology firm. We're about 5,000 people large now. We're among the 5 largest RTOs in Europe, like Luc as well, and Fraunhofer and some others. And we do a lot of research on many different topics. We're like IMEC, only we're kind of more diversified. So we have a more diverse portfolio of topics we cover, going from defense to health to climate tech and all kinds of other things as well. So that's a very brief introduction.
Brilliant, thank you. Luke, we'll take the next slide, please.
Okay, so yeah, I think you probably know me from my talk this morning, but maybe some history on myself. So I started with IMEC 40 years ago. So I only had one job in my life. So I was finishing my PhD at the moment when IMEC was started, so I was part of the starting team. And so we created IMEC as basically a spin-off from the local university, the University of Leuven, and created IMEC as an independent research center, focusing, but very focused, as Chark was saying, is one of the differences. I think we only work on chip technology, which is enabling, of course, a lot of innovation into many sectors. So in that sense, the fan-out is rather broad, but the focus is really all on chip technology. As I said, founded in 1984, 40 years ago. And I've been the CEO since for about 15 years now. Yeah, I think with the presentation I gave this morning, you probably have a good sense of what we are doing. So that we basically work with all key players, bring the entire ecosystem together, all material suppliers, equipment suppliers, fab companies, fabless companies, system companies, to kind of together drive the roadmap in the semiconductor industry. Total 5,500, 5,600 people at this moment.
Great. You can skip the next slide because you've covered who you are and where you come, and that's great. So the first topic is sort of the main topic, and that is how do we get from research to commercialization? Typically, RTOs maybe stop at technology readiness level of 6 or something like that, and you need companies to take the next step in what you're actually doing. So I want to hear a little bit about how successful you are, and in particular, what are the challenges you have in being even more successful?
Yeah, so it is usual for RTOs, in the past at least, to stop at 6, and this is the same for TNO, and we're kind of trying to get away from that, because it's not like a relay in which you pass the baton to somebody else and then they run with it, and your technical invention will become a real innovation in society. That's not the way it works. Usually, or often, too often, the baton drops. So nobody does anything with it, and that's a huge waste. When you look at the way we consider our organization and whether we've been successful in the past, of course, there are many successes that you could name. We're a big organization doing a lot of research with a lot of talented people. So it would be very strange if there were no kind of highlights that you could name. The thing you should ask is, given the fact that we've invested so much money and talent in this organization, does it yield enough given its resources over the past decades? And I would say that there's some room for improvement there, not only at TNO, but for all of us. And one of the things that I'm now trying to do is focus the organization a little bit more. We're diversified, and we will stay diversified. But still, you need a little bit of a focus in order to be successful. And IMEC is a great example of that. But in our case, it will also need focus in order to become more successful. And at the same time, work with these companies that will take up our technologies and work with them longer into the higher RTL scales to make sure that the technologies that we've developed are actually also making it to the market. And at the same time, giving us information on what the market is telling us on the lower TRLs. Because if you kind of separate yourself from the higher TRLs, then you actually are separating yourself from the discipline of the market, and I don't think that's a good idea.
Maybe as a follow-up, I can imagine that focus means not being so broad across so many areas, but in some sense we're talking more about depth, and that is going with a thing even longer. I can imagine as CEO, you may decide some areas are not as good as others, but how do you get that longer contact, or maybe getting to a higher level? How
so it is for us. It's stopping with activities that maybe we are not really the best at or very good at in the top, and also when you decide to continue with an activity. Of course, if you're talking about photonics, you're talking about a huge emerging field. which part of that value chain will you then start to do? Or, you cannot do it all. Even in the Netherlands or in Europe, we cannot do it all. We have to kind of choose. So then you will have to look at where do I have my comparative advantages as an organization, as a country, and as a region. And this analysis is not made so often. In our case, it wasn't made in the past. So we're now trying to do it and make sure that we find out where our comparative advantages are and where our future lies.
Luke?
Yeah, related to your question on TRL, how far do we go? Well, we are actually very much a customer-focused organization. We like to carefully assess in each of our partnerships how far do we need to go in order to create impact to our partners. And it very much depends on with whom you work. The majority of our activities actually focuses on what we call pre-competitive R&D. When we work with the biggest companies in our domain, think about TSMC, Maria, who was here this morning, but Samsung, Intel, all the big fabs. I mean, the model you propose there is very different from when you work with a startup company. So in that sense, we consider our goal as to drive the roadmap in a certain direction, align the ecosystem to it, and what is kind of a higher TRL level for certain parts of the value chain is lower TRL for others. And so it's very important to kind of adjust on how far you go, depending on with whom you're working. So most of the work we do is very much, as I said, pre-competitive, somewhat lower TRL levels, kind of working very close also with universities. I mean, the role of an RTO like IMEC is to kind of bridge that gap from lab to fab, take disruptive ideas in partnership with university and then validate those on industry-compatible infrastructure. And in this way, help the development teams of our partners to make the right choices and accelerate the introduction of new technologies in their manufacturing line. So in those aspects, we don't go to extreme high TRL levels, but when you talk about supporting startup companies, then we will go much further because they need access to these new technology platforms. For a lot of examples, like in the photonics area, especially also when we work with companies that don't have their own technology capability, maybe companies in the medical space, in life science community, and so, then we can develop prototypes up to much higher TRL levels. So it very much depends on with whom you work.
That makes lots of sense.
It's also very much tied to our main objective. Why was TNO created? TNO was created because in the beginning of the 20th century, people concluded that there was a huge gap between our academic sector and our private sector. It was kind of like they weren't talking to each other at all. So there was no overflow. There were no ideas coming from the academic sector into the private sector. And they wanted to kind of bridge this valley of death, as they sometimes call it. And so this is why TNO was created, to be kind of like the conduit for good ideas from the academic sector to the private sector. So this means that if you then take these ideas from the academic sector, you have to, stick with it until these ideas become really successful in the marketplace. And as I said, if you don't do that, then you never are exposed as TNO to the market and to the demand. And so this means that you can kind of stop at 6 and then go to your next topic and never mind whether it has been successful or not. So this is why I think that, of course, we are not primarily interested in the high TRL, but it's something that we are involved in some way on a less intense level, but still.
You brought up that in some ways you're the go-between between the very basic research and the applications. I would assume, having been in the middle of this, that there are some misspent expectations, maybe from both sides of the people who you're trying to get to communicate. And I was wondering if you can share, since we have lots of people in different parts of the value chain here, ways that you can overcome expectations that are not set correctly, either from the academic standpoint or from the commercial standpoint.
Well, I think in order to avoid wrong expectations, it's important to have very good discussions and set the right expectation level at the start of any engagement. So and I think that is true for universities, but it's also true for industry. I think that it's very important also to try to be very concrete in those discussions, because there has been so much discussion also in these CHIPS Acts about prototyping, and what university calls prototyping or what industry calls prototyping is very, very different. So being very explicit in terms of quantifying exactly what the scope is of where you can create impact is very important.
I think that's great. The fact that the same word has different meanings to different groups is always a big challenge.
Also, in addition to that, I think success story has been not to view it as a project-by-project situation, but look at it as a long-term partnership with universities and companies. And that helps to kind of build trust and build kind of like a pipeline also of interesting new developments, because it's always moving forward. So you're working with the same companies more or less year after year. So I guess building long-term partnerships is also very important.
I think those are both good advice for everybody. And it's almost a segue to the second topic, but I have to tell a quick story, and that is I had a lovely dog named Roxy, who whenever she got out the door would just go bolt down the street, and she would just run for fun, but every now and then she'd turn around and look to see if you're coming. And I thought it was the perfect metaphor for our job. We need to be out ahead of everybody, but we better make sure we're out ahead of everybody in a direction that they're all following us. So when you decide what you want to work on and what's your next hot topic or where your strengths are, how much do you depend on roadmaps from your customers? Or maybe they don't tell you what their roadmaps are, or maybe they don't know how much of it is then relationship instead of roadmap. And you were already discussing that having long-term connections with people helps with the relationship. I wonder what is the balance between where you get your information for the next topics?
Well, I think it's not one or the other. It's it is, of course, I would say the roadmap definition. We, as an RTO, it's one of our roles to kind of drive the ecosystem and align the ecosystem around a certain roadmap and set the direction there. I think that, and that's what we have been doing by bringing together the entire ecosystem. The innovations that we need now in the semiconductor industry and the R&D budgets that are required for it are so big that no single company can drive this on its own. So bringing this ecosystem together and then align the industry along this roadmap is one of the important roles we have as an RTO, I believe. But having said that, we should not become arrogant and say, like, we set the roadmap. No, we do that in name of the partners with whom we are working together with them. So, of course, we have a lot of internal expertise, but the input we have from all our industry partners, the input we get from the hundreds of universities with whom we work, all of that we need to bring together to build these roadmaps. Now, the semiconductor industry has been driven very much by this famous roadmap, Moore's Law, and I'm one of these believers that Moore's Law is not stopping. You just have to define what is Moore's Law, and it's not only enabled through scaling, but it's also enabled through all these new integration technologies, 3D stacking, 3D integration. But like this one roadmap we've marching along over the last couple of decades, I think is becoming much more diversified, depending on the applications. And therefore, I think on the application side, it's very important to also build up knowledge, because we should evolve from kind of a technology push towards a more application pull. And so therefore you have to understand these new applications, and not only AI, but also all the applications in health, automotive. And as an RTO, it's kind of impossible to be expert in all application domains. We have to build up the capabilities to speak the language, but we have to also partner with other research teams, with leading industry in those domains, in order to understand what are the needs for this long-term roadmap in all these application domains. So I think it's internal road mapping, but also very strong ecosystem, reliance on the ecosystem and partnerships. And it's through that bi-directional flow of information that we try to decide on what are the important things to focus on in the next decade.
Yeah, so I agree with that. We look at it like every company does it, I think. It's a combination of demand, so push and pull. You have a demand from the customers, and also you have a push where you have certain ideas of where the market may be going or the technologies may be going. And often, as a research organization, you have a very clear idea where the technology may go in a couple of years or 5 to 10 years. And that may be helpful to the customer as well. And you may be able to surprise them, but in the end, the roadmap is always very much influenced by the demand by the customers. And so it's not if this or that, it is both. But as I said earlier, there's another dimension that comes into play, and that's where's your comparative advantage? Because you can do all these analysis as the customer wants this, and we have our vision on where the technology may be going in a couple of years. It's very fine, but if you don't have a position in that market, then still you shouldn't invest maybe, or in some cases yes, but mostly no. So getting a clear idea of where your comparative advantages are, as I said, of your organization, of your country, of your region even, is very important. And that also will kind of influence the decisions you make on where to invest and where not to invest.
I wonder how formal, it's great that you're helping synthesize the roadmap with your customers. That's not something I'm used to as a laser person. How formal are your roadmaps? Are they published? Are there things people can read? And my background is that when we became part of MKS and suddenly all of the semiconductor roadmaps were very clear, those of us who had been in the laser business were incredibly jealous because of the fragmentation that we had dealt with. And so we were quite envious of our customers telling us explicitly things we needed. So how public are you with what you've synthesized with your customers? Or are you under NDAs and you're not allowed to share some of these things?
I would say it's a combination of both. Yeah. So of course we work with nearly everybody in our industry. At this moment we have like major meetings twice a year where we basically update all these roadmaps. That's kind of an internal meeting, but then the outcome of that we also publish at many conferences. So it's both, I would say. Yeah, but it's a very intimate process where we bring everybody together twice a year, where we update these roadmaps.
I think the roadmaps are constantly in flux, and
Sure.
this will be the same for us and for everybody here in the room. It's constantly evolving because this field is, and every technology field is evolving so quickly. And your position within the field also is evolving quickly, and then maybe the EU does something with new budgets, and then everything is thrown into the blender again. And so you will have to be very aware of the fact that everything can change on a dime, right now. And being flexible and being able to kind of change the course is also very important in this whole thing. So I'm not such a big fan of long-term roadmaps in this field, in this specific kind of area, because it's too dynamic. You do have to have a little bit of an idea. So like Luc presented, this timeline, right? So where the next technologies may come. But still, even that may be, may change next year when he stands here to present it. Maybe it will be different already because things change so quickly. So roadmaps are good to kind of like as a mental crutch, but they shouldn't be taken too seriously because they can change.
Well, I would question that a little bit. You asked us not to agree on everything.
I asked you not to agree on everything.
Exactly.
But I think these roadmaps are very important, at least in the domain where we work, because the investments in R&D are so big, and we have to make sure that the ecosystem is aligned. When we talk about introducing like a new lithography technology, EUV, ASML, preparing for the next version of high-NA EUV, it's very important for the material companies to understand when those technologies insertion points will be, because they need to make sure that their materials are ready in time. Typically, their R&D budgets are much smaller, and so it can be very catastrophic for them when they invest too early in getting a material ready. It's even worse when they're too late, because then their competition may be ahead. So having that alignment on timing for new technology insertions, I think, is very, very critical for the industry.
Excellent. Congratulations on your presentation to the new fab here in Malaga and getting to meet the mayor and all like that. But that brings us to the globalization question. Historically, you've concentrated in your home countries and then the rest of Europe, but you're all now doing things in Asia or other parts of the world. And I wonder, what really is your globalization strategy? And what about challenges? Because, as we said, people are very important, and there's also funding challenges in other parts of the world. Can you give us some color on your globalization plans, please?
Well, yeah, go ahead.
Okay, I already briefly talked about it about this topic this morning in my presentation. So indeed, we are mostly based in Europe in terms of our infrastructure, but already from the early days of our existence, we have positioned IMEC very much as a global R&D organization. We work with all the major players, whether they are in the US, whether they are in Taiwan, Korea, Japan, Europe. We try to bring together everybody at a global level, and we have been for decades. We've been a global R&D organization. Having said that, I think IMEC has reached a size where it becomes difficult to do everything on one location, and this then comes together with kind of the opportunities that emerge with the various CHIPS Acts and interests from various places to kind of take a strong position also in the R&D in this domain. And so we are looking at those opportunities and partnering with some initiatives like this one. But we also have a very strong partnership in the Netherlands with TNO, where we have a major R&D facility where we work on some of the applications in a very strong partnership. We have initiatives in the US where we partner with certain universities. And I think it's very important, as the point that I tried to make this morning, that in this domain, we really try to work on a global level, because the industry is also global. And I think Maria showed a very interesting slide this morning on illustrating which region is contributing where in the value chain, and it's a very integrated industry, and I think that has been, to a large extent, the reason why the industry has been successful. It becomes so difficult. If everybody tries to do everything, it will lead to mediocrity. We need to really strengthen the strengths, focus on the strengths of a region, and try to have a strong position in the global value chain. I think that is the best way to tackle these phenomenal R&D challenges. You have to bring together the best of the best. You have to build critical mass. We've seen so much consolidation in our industry, on the industrial players. We should make sure that the CHIPS Acts are not going to lead to a decoupling of the regions, whereas there has been consolidation on the industry side. We might get decoupling on the R&D side, which I think would be completely inefficient. And so we are strongly advocating, let's collaborate, because that has been the success of our industry, and we have to make sure that we collaborate even more in order to enable the future progress.
Yes, these value chains are intrinsically global. This is true for semicon, this is true for photonics, and all these other fields will be global value chains. And every region will have certain comparative advantages. And as it was said in the previous panel, you will have scale advantages driving specialization. So this driving of specialization and the comparative advantage will mean that the different regions in the world will kind of take up different parts of the enormously complicated value chains. So what you will get is not strategic independence, as people are talking about now in Europe. What you will get is strategic interdependence. We will all be interdependent, and that's okay. That's even okay in a highly stressed global situation like we are having now. Maybe it is even preferable because we depend on each other. So it might be actually good to have it for peace because we all need each other, and it's a natural thing to happen. So the main question for me when it comes to our international strategy is at which things are we very good compared to our global competitors or colleagues, or how do you call it? Because we don't have to replicate all of us the same technology, all the same activities. We should really, at a certain point we will say, listen, we have 5 other RTOs in Europe or in the United States or whatever, doing the same as we are, but maybe even better. So why then are we doing it exactly? At the same time, there may be other things that we are doing that we are certainly leading. We are a leading innovator. We're really pushing forward the needle when it comes down to technology development. In that case, that might be some area that we would like to invest in. So I think it's a natural process of consolidation. Once the technology becomes more mature, then these economies of scale, as well as comparative advantages, will kind of take care of who does what, predominantly, of course, because it's never 100%, 0%, and that's okay. And then we get an internationally interdependent value chain, which is, I think, even for the geopolitical tensions that we are seeing now, very beneficial. Also, by the way, our infrastructure is mostly in the Netherlands. We do have foreign offices, but the infrastructure is mostly still in the Netherlands. But when it comes down to the contract research we do, about 60% of it is not from the Netherlands, so it's quite a large part of it.
I think the pilot lines, as we're setting it up in the European Chips Act, also is a good example of how we are kind of emphasizing complementarity between those pilot lines, between the first 3 pilot lines that have been announced, but also now what is being set up in photonics. It's, I think, a good example on how we are connecting some of the strengths across Europe into an integrated plan rather than compete against each other.
What a great panel so far. We have some questions in the public. Please remind us your name and company.
Hello. I'm Nathalie de Baas from Brussels Photonics, and I would like to thank you for this great panel discussion about collaboration. And as IMEC and TNO are also partner in the Photon Hub project, I would like to ask to you, according to you, how important is it to have a European innovation hub that bridge the industry and the research world together?
Well, to be very brief, very, very important. Yeah, I think we should go all out to try to create a good position in Europe in this technology and several other technologies as well, by the way. Otherwise, we will miss out. You've all probably seen the Draghi report, and it's really not such a good situation in Europe at the moment. We really have to start changing our attitude regarding innovation and technology, and it will be very difficult. So, but this will be maybe one of these areas that we can really make a move.
Yeah, I agree. I mean, it's super important, and because it's one of those areas where I think we in Europe here can really have some very strong assets and can also create a lot of new opportunities, new startups in this field. So we need to have the technology platform to enable this. In these deep tech startups, I mean, you can create a lot of startups with 2 people in a garage, but in these deep tech startups, you need a mega garage to demonstrate your capabilities. And that's why these pilot lines are so important.
If you want to hear more about Photon Hub, they have a fantastic booth outside. Please visit it. We have a lot of questions. Jim, please remind us your name and company.
Hello, Brian Hall, Color Chip. So great discussion. Collaboration is wonderful as a first starting point, I believe. But how important is inorganic growth to your company over the next 5 years? And if it is, because there are so many wonderful companies here, I mean, small companies, 2 guys in a garage, 10 guys in a building, whatever they may be, a very, very intelligent group. How important is inorganic growth, and what would you say are the top 3 areas that may be interesting to you?
This is for you, I think.
Well, with inorganic growth, you mean acquisitions? Okay. Yeah, well, as an R&D organization, we typically don't acquire other organizations, although we have done it once with a major initiative where we had 2 R&D organizations actually in the Belgian ecosystem. We were focusing really on the technology, chip technology. We had another organization that was focusing more on the application, like cybersecurity, AI, Internet of Things. As there was this very strong need to kind of connect technology with system requirements, system technology co-optimization, we felt the need that we needed to expand and get more knowledge in terms of the application domains. So that's when we merged with the other organization. That was kind of a very good example of an inorganic transition in our growth. But that's kind of the only example that I can give.
Yeah, so maybe a little bit different than the question, but the big problem in Europe, in my opinion, well, especially in the Netherlands, let me talk about the Netherlands, but I think it's true for Europe as well, is that we do a lot of good fundamental research in Europe. I mean, we're leading, I think, in fundamental research in many areas. We also nowadays in the Netherlands, we have lots of startups, and in Europe as well. I mean, that's not the problem anymore. In 20 years ago, it was. In 20 years ago, we didn't have startups in the Netherlands. And maybe this was also true for many parts of Europe. Now we have a lot of startups, but if you then look at what happens to the startups, you see that they don't grow, they don't scale, they don't become the next Google, etc. That's the major problem we face right at this moment. And this is also one of the reasons why the percentage of R&D of GDP is not growing, especially in the Netherlands, because these companies usually, when they grow, they spend a lot of money on R&D, and then, of course, this pushes the whole R&D portfolio of a country or a region. But in the Netherlands, we see, and in Europe, we see this problem very clearly. And I think consolidation of these companies, merging, acquisitions, and maybe even by a TNO, an organization like TNO, this is actually something that we are now going to do. We have a new strategy in which we actually are willing to acquire parts or whole companies in order to bring them to the next level when it comes to the growth cycle. Because in Netherlands, one of the reasons that they are not growing is that first they cannot get funding, and it helps a lot, it turns out, if TNO is behind a certain technology or a certain company to get funding. And the second is that they don't have equipment, lab facilities. It's a very small country with a lot of people and not enough buildings and not enough labs. Of course, we do have those infrastructures, so that might help them to kind of facilitate their growth quicker. And that is one of the major problems in Europe at the moment, I think. So yes, a little bit different than what you said, but still, I think you are onto something.
We have 3 more questions and 1 minute of time, so I'm going to ask fast questions and fast answers, please. Please tell us your name and company.
Ashkan from NVIDIA. So I think that the customer to R&D pipeline it breaks the laws of thermodynamics, because everyone has a lovely idea that they want to push from R&D into product, but the correct figures of merit and barriers of success are not communicated downward. We try to change that. So, and then the other part of it is when there's an international pool of money like these various CHIP acts, it's a nice spin of the flywheel. Everyone gets super excited. There will be hundreds of PhDs, thousands of papers, very few cross the barrier like you just said. So can you quickly then talk about your philosophy or an example of when you said no? Somebody came and said, I have a wonderful idea, and you said, you know what? No, I don't want that.
Ooh. We will typically answer. We never say no, but we say yes. We say no for this one, but this is what we can do. This is what may help you even more than your question, your original question.
So we have a policy that when every year we have kind of like a process that when we vet new ideas that come to us, and we have a policy of only approving maximum 50% of them. So I'm not going to give you examples of things we didn't do, but that is, you have to say no to some things. Otherwise, you will be too diversified and will be just so in a lot of things.
As an ex-TNO, I can tell you that defining a business plan or your idea is key in that R&D center. Any further questions? We have two more questions. Please remind us your name and company.
Yeah, Robert Harrison, my name. I'm a board member of the European Quantum Industry Consortium and also an IP lawyer professionally as well as an investor. Both of your organisations have been extremely successful at establishing startups and spin-outs from the organisation. And yet one of the things that we've started also seeing that other RTOs have been pushing back, particularly the investors want exclusive access to the intellectual property behind some of this, and yet the RTOs have been pushing back and saying, okay, we cannot give you this, partly because it's public money behind it, the taxpayers don't want to do it. How have you managed this conflict within your organizations?
Well, in our case, we have a very broad variety of models on how we engage in our industrial relationships. But typically, and I think startups have been very successful recently as we are focusing more on the application domains. All these startups, they need access to technology platforms. Those platforms we typically keep common among various opportunities. We will never give exclusivity on the technology platforms, but in the application domains, we will give exclusive IP so that the startups can really find define a strong business plan and create a strong success story. But of course, as they need to leverage technology platforms, I mean, they can never pay for the entire platform. So giving them access is what is their need. So they don't need exclusivity.
Yeah, we do it the same way. We're reasonably flexible, but of course everybody's trying to maximize his position. I can understand that, and we also see investors that have more or less this attitude that we've been working on a technology for 20 years, invested a lot of money and a lot of effort in it, and then when time comes to spin it out, they want 100% of the shares and all the intellectual property. That won't work for us. So we do want to see that we also have a good position in that company, and that the technology is used in a good way and can be diversified to other fields if necessary, because certain technologies can be used in many different fields. So we always have to be aware of that. We're flexible, but up to a point.
From Photonics 21 is going to comment a lot on the investment panel tomorrow. We have one final question. Please remind us your name and company.
Hi, my name is Wenko Subtetz from the German Industry Association Spectalis. Luke, you mentioned we need the best of the best in photonics to master the challenges. There are other high-tech industries who compete for the same talent pool, also other regions in the world who compete for the best talents. What are your strategies to get the best talents for your company, for your institutions?
Yeah, go ahead.
No, please.
But, in our case, it might be not something that is on the mind of technologists often, or maybe they don't want to have it on their mind, but having a strong brand name is very important for people to gravitate towards the organization. So we haven't had that problem really in the past years. We've been able to hire all the people that we wanted to hire. But there's a big but. 40% or something like that is coming not from the Netherlands. So in the 2 years since I am now CEO at TNO, this organization has changed from a Dutch-speaking organization to an English-speaking organization completely, because of all the inflow of people from all over the world. I think it's a good thing. But you have to have, as I said, everything ties into what's the image, what's the brand saying to you. If you are very strong in certain fields, that alone will attract talent, right? If you're the leading innovator in certain fields, that alone will attract. But then also you will have to tell the story, and people will have to know about it. Otherwise, they won't know about it and won't want to work for you. I guess it's not much more than that.
Maybe, yeah, I just can add brand, extremely important. We also have a strategy where we partner with hundreds of universities to create an influx of talent to us and to this industry. We have about 850 PhD students who make their PhD. They obtain it from the university, but they do the research part in IMEC. And then thirdly, I strongly believe in the need to set up strong talent development programs. And we do that in partnership with universities, in partnership with our industry partners. But this industry needs a strong influx of talent. It's also one of the key priorities in the European Chips Act, or in the Global Chips Act, equally so in the US and in Japan. But I think it's these three pillars. But talent development remains a very important priority, because it's also our role as RTOs to bring up the talent to support our industry partners with their needs.
That's one thing I forgot, is that it's very important to signal your purpose and so the meaning of what you're doing. If you're just doing technical work in a lab, people, especially this generation, they want to have meaning, right, in their work. So we always kind of stress, what are we trying to create here? What technologies, what end goals are we trying to achieve using the technology instead of just focusing on the technologies?
Sure. I guess it's almost lunchtime. Jose is giving me the hands up. So thank you to both of our speakers.
Thank you.
So it's just me and Julie, besides you and the lunch. I'm Ulrike Fuchs. I'm with Aspericon, and also I have the privilege on serving on the board of Optica.
And I'm Julie Yang. I'm CTO of Coherent. I'm also on the Optica board.
And we have the pleasure of inviting all the women around here, because we heard so much about diversity, getting more women into the business, but we are also selfish. We want to know all the other women. And so we use this event to have lunch with you together. So everybody who would enjoy that, please follow me and Julie, and we talk over lunch and get to know each other better. Thank you.
Ladies and gentlemen, it's time for a 90-minute lunch break. Plenty of time for food and more meaningful conversations. And please remember to visit the exhibitor booths outside. Here's a reminder of the organizations supporting this year's Global Photonics Economic Forum.
SECFO, Fotónica 21, IMEC, Keystone Photonics, Malaga Tech Park, PIC UPV, PIC Spain, Vodafone, Disruptive, IFOS, Innova IRB, Cadence, Photon Hub, Bullnet, Vanguard Automation Micronic, GDS Factory, Bioherent, Vigo Ventures. Invest in Andalucía, Andalucía Trade, Junta de Andalucía.
Welcome to this session, where we're pleased to welcome Matt Crowley, EVP of Intelligent Infrastructure at Jabil, one of the world's leading manufacturing solution providers. With over 140,000 employees spread across more than 100 facilities globally, Jabil plays a critical role in delivering cutting-edge technologies. The company's work in photonics in particular is transformative. They enable advancements that are crucial for global communication, automotive systems, and healthcare diagnostics. In Matt's time at Jabil, he has pioneered new business models enabling manufacturing at scale. His leadership is marked by a deep commitment to innovation. He has a strategic vision that ensures Jabil remains at the forefront of technological advancements in the manufacturing industry.
Thanks. And thanks to the Optica team and Jose for having me. Our CEO, Mike Dastor, had an unanticipated surgery a couple weeks ago, and so I have the honor of stepping in for him, which excites me in a couple different ways. One, I have a photon joke. And I've been telling this photon joke to my 9, 12, and 15-year-old boys for a while, and it gets the kind of reaction that you would imagine. So I'm hoping I finally got the right audience for this joke. So here it goes. Photon's checking into his hotel room. Bellhop comes up and says, "Photon, can I take your bags up to your room for you?" He said, "No, I don't have bags. I'm traveling light." Yes. All right, well, okay. The boys will be happy to know it got about the same reaction that they got, so that's good. No, the other reason that I'm super excited to be here is that, photonics, silicon photonics is a huge part of our strategy at Jabil. And so having the opportunity to talk to you all today about the role that scale plays in the industry is super important for us. I think it's super important in general if photonics is really going to have the impact that it has potentially. So, a little bit about Jabil. Jabil, it's actually Jabil. We are a large enterprise, roughly 30 billion, 29 billion annually. We just reported earnings for fiscal 24 last year. We have 140,000 employees all over the world. We have factories in over 25 countries, and we've been around for 50 years. And so that is all to say that we understand scale and we understand longevity. Additionally, we have a ton of end markets, and they're very broad. So in addition to the business that I'm responsible for, where we have our wireless, 5G, cloud, hyperscale business, we also have businesses in healthcare, in automotive, in defense and aerospace, in consumer. And so we have a very unique view of not only scale, but of the marketplace, because photonics plays a role in a number of these different areas, not just in technology in the hyperscale space. We really feel like photonics has the capability to change the industry. And so we kind of think about some core end markets that we participate in, specifically around cloud and data center, in telecom and mobility, in automotive and transportation, where you have LiDAR, in healthcare, where you have optics helping to precisely navigate the human body, and in consumer electronics around AR and VR. And so all of these end markets have the potential to take photonics to the next level. And it's a big level. So it's discretely $35 billion from a component opportunity, but it supports a $2 trillion market. So everybody in this room has a massive opportunity to go and take advantage of what photonics means to the industry. So we're super excited about it. Now, when you think about scale, there are some requirements from the market that you have to be able to deliver. And so I'm going to touch on each one of these. Pricing is obviously a core component of it. There is a geographic diversity requirement, which I'll touch on briefly, but the ability to quickly scale and create volume is critical. So we'll go through one at a time. Now, for all the economists in the room, you're going to have to give me a little leeway here because these models are probably not accurate necessarily, but they're illustrative of a concept. And so traditionally, you've seen and are used to demand-supply curves, where volume and pricing adjust, price points come in line, volume starts to take off. But what we see in the industry today is that's changing because you have mega customers, hyperscale customers. They expect something different. They don't adhere to the traditional models. In their mind, they want to see pricing and scale all at once. There is no curve. They want the price point now, they want the volume now. Delivering into that is a significant challenge. And so you can't go about thinking about it in the traditional way. So we've thought about it a little bit differently. And this is true generally of our portfolio, but historically, a lot of product companies will look at a product, the price, the materials, the markup, the interest, and they'll target a specific profit by widget, let's call it. And that traditionally works, but with the hyperscale space, you can't think about it individually. You have to think about your portfolio a little bit differently. So for us, we focus on return on invested capital because we can create velocity inside of that, return cash to our corporation, which ultimately is the earmark of a good business. And instead of focusing on just lower margin widget business, we focus on the economy that we create and the cash that we return to our enterprise. And so typically where you would see inventory turns at 2 to 3 times per year, we're focused on turning inventory 5 to 6 times per year. And we're focused on return of invested capital in upwards of 90 to 100% back to the company. And so that creates the ability to manage a portfolio. So the focus on the traditional margin per unit is less impactful when you're returning more cash to the company. And we've done that successfully in our server and rack business. We are doing it now in our silicon photonics business. And it creates a really nice complement to the portfolio. Okay, so what does the market require? Lower price points. Geographic diversity, and I'll just touch on this briefly. Everything happening in the world today has required the de-risking of locations for manufacturing. That's just table stakes. Specific to silicon photonics, there's a bit of a nuance in that you have parts that move all over the world because you don't have one centralized ability to take a silicon photonic part through OSAT in one place. And I'll touch more on that in the scale piece. But you've got to have the ability to de-risk dependency on one region. And that goes back to our footprint all over the world, where we have 100 plus factories in 25 countries. So it fits well into our model. When you think about scale and velocity, so there are 3 challenges, and we'll go through each one. For photonics OSAT specifically, the ecosystem is fragmented. We'll talk more about that. Automation has not been deployed at scale. It needs to be. In order for this business to be economically viable, we have to create that capability. And the capital intensiveness of this business is significant. So how do we address that and still adhere to the return on invested capital tenet that I just talked about? We'll go through each one. So the fragmented value chain. Today, you'll have a part that goes to a number of different touch points all over the world. A couple problems with that. One, a lot of times you may have fiber hanging off of these parts. The risk of scrap is significant, and customers don't like a 50% loss on parts that in some cases cost up to $25,000. So how do you move the parts around the OSAT process without the risk of scrap? Additionally, each time these parts move, it's hitting a different supplier potentially, which creates a margin stack. And that margin stack is not something that customers are super interested in either. So figuring out how to address that, finding synergies, finding ways to consolidate, finding ways to do more of this process in one place versus all over the world is critical to the ability to scale. Automation. So today, you have automation requires a whole lot of parts be fed through it. We don't really yet have the right alignment cycle times. So if you think about a machine that can do 30 parts per hour, you would have to have a whole lot of those machines in order to serve a hyperscale customer. That creates a capital intensity that becomes problematic to the return on invested capital model. On the other side of the automation piece, you have bottlenecks that are human beings. And so while you have some automation that you can deploy, you still have people that are feeding that automation. And so solving the automation problem becomes core to our ability to create scale in the space. And capital intensity. So when you have these machines that are massively massive cost, you have to deploy a ton to be able to hit the scale that customers want. And in order to have the right line for silicon photonics, you're talking about $250 million potentially for 150,000 wafer per year. And so how do you create an economic model that makes sense in this environment? It's a challenge, and there's probably a big part of this story that a lot of the folks in the room may disagree with. That's okay. But we have to find some alignment across some core verticals. So technology owners in the room, and I know nobody wants to hear this, but if you're innovating around technology, from day one, in order for photonics to really scale and really impact the industry to the degree that it has potential, you've got to be thinking about what does it take to succeed at scale with volume. It can't just be about the technology, because the technology can be absolutely amazing and differentiated, but if you can't get to the hyperscale volume and the hyperscale expectations, the technology is not going to get into their fleets. For manufacturers, we've got to think about known good workflows. We have to find leverage from one generation to the next. We have to be able to reuse the things that we build and create as we go through the process from generation to generation. And then we have to consolidate the value chain. We have to be able to eliminate the risk of scrap in the OSAT process, and we have to find those synergies in order to make this economically viable. And then finally, on the end user side, we've got to get to the point where there is some level of standardization. Because if every single customer is insistent on a snowflake-like process and/or product, we're never going to be able to get it to scale. Now, the truth is, in the hyperscale space, probably only takes one. Not going to name them. Probably some folks in the room from them. But if you get that one, you can make it work. But if you find some level of standardization across all of these processes, then you have the ability to make this incredibly economically viable. You can focus on the return on invested capital, and you can focus on turning your inventory and returning cash to your company more frequently. And so that's what we do at Jabil. It's what we're really good at, and it's been very successful for us to date. And so we think there's a ton of opportunity here. I think the folks in the room, if we can find ways to address some of these issues, then photonics will be a massive impact to the industry. But we've got a lot of work to do to get there. And hopefully we'll have conversations for the rest of the week to talk about how we do it. That's all I got. Thanks.
Matt, please stay with us. We have a bit of time for a Q&A, and there is a few things that we would like to ask you as a community. Of course, the floor is open for questions. If you have any question, raise your hand. I would like to start. Today we had, in my opinion, one of the highlights of this morning was the CEO panel. I love every single part of it, but especially when all of you agreed AI is not a hype. So let's assume it's not a hype. Let's assume that for real, the amount of data capacity processing a data center is going to multiply by three orders of magnitude. I believe that that means that in the short distances, we are going to get a massive demand of capacity. Hence, our competition is copper. Do you think that as an industry, as a community, we should align forces to be cheaper or more power efficient than copper? Is that the way that we should go? And what kind of ideas do you have for this community in that respect?
Well, look, I'm not the most technical person, but what I would tell you as a concept is if photonics is going to accelerate and take over the industry, then we absolutely have to find ways to get to price points that exceed copper. So how we do that, I think that our next panel is probably better suited to speak to technically. From a business perspective, is that how silicon photonics wins in the space? Yes, absolutely.
We have quite a few questions. Please remind us your name and company.
Chris Fisner, Avicenna. Hey, Mac, great presentation. You mentioned the OSAT stack, like all the different steps, and how we try to avoid frequent flyer miles for the components traveling all over the world.
Yep.
But it is a fact of life that today they do travel. But how do you think about, because sometimes there's a trade-off between you could try to do everything in one place, but it's not going to be ideal, or if you go to the best-in-class stops, then you have to travel. So how do you think about that, the trade-offs?
Well, we think about it in the context of, is there a way to get not from, call it 20 hops today all over the world, but to get to 3? Because if you can do that, you can eliminate the margin stacking, you can eliminate a lot of the risk on scrap. And so I don't know that any one company is going to solve it. I think there is still a problem of volume as it applies to the big OSATs. Are they really interested in the volume around silicon photonics specifically? If we were to be able to form somewhat of a consortium of a tight-knit group of companies who would then address those critical few processes that you could aggregate, then I think that's the way to address it.
Hi, Dan Cohen from Google X, not the data center team. Thank you. Just a great graph that you put on the screen, sort of defying the rules of microeconomics. Does this to suggest that there's like a single ASP for a product lifecycle for a transceiver, let's say, during its entire product lifecycle?
I think there's a starting point ASP. I think that competition in the space will always have a downward force on it to try and take cost out. I do think that there is some value in the fact that customers will always want or need to have diversity across geographies. And so becoming dependent on Asia-specific suppliers and allowing consolidation with the China supply base, probably not going to happen. I think you're going to have to chase that market a little bit, because if the price point discrepancy and the ASPs become too different, it's going to really hurt the fact that the geographical diversity has value. But I think you can do that and still remain relatively profitable, especially if you're focused on the return on invested capital.
Please remind us your name and company.
Yeah, Erwin, Lucida Photonics. This morning we saw that, okay, there's some geographical decoupling, and we see fabs being created, let's say, everywhere in the world. What is it going to take, according to you, to make this profitable?
For the fabs, I don't know. I think for silicon photonics, there has to be some consolidation, and I think it's going to be between the China supply base and the non-China supply base. For the fabs, I think there's going to have to be an inflection point at which there's enough commonality around the technology that you don't have 5 different fabs trying to deploy and design 5 different specific technologies. And so the more commonality that we can find so that the price points become in line with customer expectations in the hyperscale space, the more volume you'll see. And I think it's just going to have to take some level of consolidation or aggregation to get there.
Matt Crowley, thank you very much for a great presentation. Thank you. As you saw from the first question I asked, now it is time to really compete against copper or to really see if we are a semiconductor technology. And for that, I would like to call to the stage the panelist of the panel 2 session, Is Photonics a Semiconductor Technology? Please join me on stage, Greg Bartlett, CTO of Global Foundries, Borja Silca, CEO and co-founder of Allo Semiconductors, Ed Bailey, the General Manager and VP of Jabil, Martin Schell, Executive Director from Hofer Heine Hertz Institute, Thorsten Barenkamp, the CEO and co-founder of PyContech, and the very well-known Ashkan Seyedi, Principal at NVIDIA. Thank you very much for having us. A round of applause for the next panel. So let me start with you, Greg. In your opinion, is photonics a semiconductor technology?
That's an emphatic yes and an emphatic no. And what do I mean by that? Okay, so, at the risk, Global Foundries is a semiconductor foundry, right? So, what's the phrase? If all you have is a hammer, everything looks like a nail. And I'll tell you, the first several years we were developing photonics technology, we were trying to make it look like a CMOS technology. And that works for a lot of it, but you need to deeply appreciate the aspects of a photonic, in this case, a silicon photonic solution that does not behave like anything else built in semiconductors. And it's all about, curvilinear shapes, germanium photodetectors, unbelievable levels of requirements for waveguide technology, resonators. There's a lot of things that don't look like foundry today. And if you don't appreciate the distinction between the two, then you're going to have a lot of trouble.
Greg, allow me to ask you this. So a few years ago, you invested heavily on a quantum computing company, PsiQuantum.
Yep.
And we just heard from Jabil that we are looking about ramping up to volume production quickly. What you did with PsiQuantum really was incorporating new building blocks onto a fab to really enable single photon operation. What's the strategy? Do we want to accelerate quantum computers? Do we want to use those building blocks into other applications?
So it's interesting. If you think room temperature or data center photonics is difficult, imagine operating at single-digit Kelvin or millikelvin on there. And it just amplifies all of the challenges, right? Insertion loss, the link budget, trying to do single photon sampling is unbelievable. So we found two things. There are some aspects of the quantum solution that are very, very specific. Characterization of the devices over temperature down to millikelvin range is a key aspect. There's some other areas like the need for very thick waveguide materials of incredible cross-wafer uniformity, far beyond anything that exists all the way down into our 12 nanometer FinFET. Mm-hmm. And we've been able to leverage learning from the quantum solutions up into the data center solutions.
Let me get another perspective. Let's go to Borja Silca from Allo Semiconductor. You are a manufacturer of gallium nitride on silicon material. Is photonics a semiconductor technology?
When we look at the device, I would say certainly yes, right? We are using the same materials, we are using very similar manufacturing technologies, and with silicon photonics, of course, you have, by definition, the integration already. And even more, you talked before of overcoming copper. Photonics more and more take over functions which previously have been executed by electrons, if you want. So one field we are in is indeed doing materials for LEDs, and if any one of you is interested in talking about LEDs faster, catch me in the break. So from a device point of view, yes, clearly yes. On the other hand, of course, there are differences. There are differences in technology nodes, right? So rather micrometer versus nanometers. There are differences in wafer diameters, and that sounds trivial, but it's difficult to scale certain materials to large diameters. Some people like us, we are doing, again, on silicon on 200 and 300 millimeters. So a material which is traditionally used for LEDs is now coming on larger wafer diameters. Why we do this? Because our customers use silicon fabs to make LEDs for micro-LED displays. And they need to do this because they need the incredible yield advantages. So indeed, these industries are coming together more and more.
I believe that ultimately it's about the automation and the increased volume production. So allow me to go to one company that made a difference in Europe in the sense of manufacturing photonics-enabled modules with active alignment. I'm talking, of course, about FICON-Tech. Standardization, automation challenges are there, but in your opinion, is photonics a semiconductor technology?
When we started that whole business 24 years ago, for sure it was not, because there was nobody talked about anything close to semicon. If we now, since the last 3 years, we get all the machines, or a lot of machines we are building, we get qualified for semi-standards. So we get more and more requests, okay, when you build a machine, make sure it qualifies according to semi-standards. When I see where our machines are located today, it's not semicon. If you see these typical assembly lines, our machines are always looking like the aliens because they are separate from everything else. And that is something I think we should definitely change as an industry. We have to fit into the lines.
Do you see a convergence? You think that we should get there?
Yep. And we're heavily working on this with several manufacturers to make sure that we fit to, we say, common electronic manufacturing lines. And it has to change.
I believe, I'm looking, of course, at Martin Schell. We think about photonics as semiconductor technology. Do you think that we are a semiconductor technology, or do you think we should become a semiconductor technology?
I translate that into the question, is an Airbus 380 an airplane, and is a Piper Cessna an airplane? Both are airplanes, and both obey to the laws of aerodynamics, but the result, the final product, looks very difficult simply because the scale they operate on is a factor of 1,000 or 10,000 different. And so there's lots of parallelities between photonic chips and electronics chips. For example, the performance is made by the semiconductor die, and the performance is destroyed by packaging. So it's equal in both cases. Different is if you have a packaged semiconductor chip, 80% of the value add is in the die and 20% maybe in the packaging. And photonics is completely the other way around. It's 20% in the die and 80% in the packaging. And in terms of maturity, I would say the photonics industry is right in the Cambrian period of the main age, with the explosion into 20,000 different types, and this still has to consolidate. So electronics is a couple of 100 million years later and has already consolidated on the technical base much more.
This year at OFC, well, no, last year at OFC, you gave a great presentation, one of the best presentations I had in my entire life, about the fact that indium phosphide was the right material to take photonic integration to volume production. Do you still see that way? I mean, in that sense, what can we do as a community to make that happen?
If you have a look at a single 6-inch indium phosphide wafer, it's about 100,000 laser dies, and each of these lasers can transport 200 gigabit. The silicon photonics have a big disadvantage in size if you don't count the inches, but the number of devices they get on a single wafer, right? So it's still open who's going to win.
Ashkan, this year at OFC, I never heard in my entire life anybody who has challenged the photonic industry as you did during the OFC. You were coming to us, telling us we need to overcome as a community some challenges when it comes to cost, when it comes to not so much power losses, but it comes to manufacturability. Maybe you could tell us a bit about those learnings, and also tell us if, in your opinion, we should become a semiconductor technology.
So to answer your question of is photonics a semiconductor industry, my answer would be, what the hell else could it be? But also at the same time, you could ask some questions grammatically correctly, but they may not make sense. So you can say, what does the number 5 smell like? And you think about that and you're like, what does that question actually mean? So look at all the pluggables that could ever be sold in 1 year. It's tens of millions. So if you call that volume and then you go to an iPhone vendor company who builds parts, they look at that and they're like, come on, man, that's not volume. I don't get out of bed for less than 6 zeros or 7 zeros. So I think that the punchline of looking at photonics and what it helps you do is the value add. It's an enabler. Simply put, you cannot build higher performance machines and ASICs and packages and generative AI training machines or inference machines without the use of optics. That by nature will drive the volume, that will by nature drive the value. So we have to, I challenge the industry to position optics not as yet another wafer volume play, how many connectors, how many pluggables, how many lasers, whatever. It's a value add. Are you bringing value? Are you letting someone do something they couldn't do before? That's it. If you can, you have a chance. If you cannot, good luck to you. Doesn't matter how many wafers you ship out there. So that's number one, is reposition the photonics as a value add and an enabler for what we need tomorrow. And what we need tomorrow, as you heard Luke talk about from the foundry perspective in some sense, AR, VR, sensing, the stuff that we do with GPUs and enabling co-packaged optics and high-density pluggables, that's like the last 20 meters of climbing Everest, okay? You have to do there's opportunities to do so much more down here, this base camp and this other base camp and then this other base camp before you worry about these high-end systems. Now, some of these high-end systems, quantum compute being my favorite one to pick on, which will never go anywhere. But from that, you can derive, it's like the NASA program, okay? From that, you can derive usefulness in other areas of technology applications. So working with, I saw Peter O'Brien in the audience earlier today. He's worked on these fiber connectors that can withstand the coldest of temperatures with water around them or other fluids around them and whatever. That's cool. That's a solution waiting for a problem, okay? And then the thing about the cost, I'm in my era of just telling people no, which is why I was asking the question that I asked earlier. I think this Cambrian era that was mentioned just a second ago, I think that's very good. We photonics people have an emotional attachment to, well, I think I can design a better grading coupler. I think I can save you 0.1 dB. I don't care if no one will ever be able to assemble it, or it's $1,000 per connection. So you have to ask yourself, is it really worth it? Again, going back to full circle, does it actually bring me value to save that 0.1, 0.2, 0.3 dB savings in power? On a blank slate, yes, it does. But if it makes your technology non-manufacturable by the likes of Jabil and other high-volume partners, are you actually able to deliver that value? So I think by saying no to a lot of these wonderful ideas, figuring out, okay, this is the thing that we got to just like run this groove and get it to work, we can drive to standards. And the point that Matt was making earlier about this thing bouncing all around, it's not so much the transport or the frequent flyer miles, like Chris said. It's not so much the transport that sucks. What sucks is I'm vendor A, he's vendor B. I do my part and I give it to him, and then somewhere along the way it breaks, and then the customer's like, who broke it? I'm like, well, I didn't break it. It was working fine when it left me. And he's like, well, I didn't break it. I mean, it just showed up on my doorstep. How could I have possibly broken it? And then now you're stuck. That's the problem. And how could you do that? Standardized testing, outgoing, incoming inspections, defined, blah, blah, blah. The only way you can do that is by not having a Cambrian era, letting ideas die away. It's lovely that you can save me a quarter of a dB. Thank you. Call me in 5 years. Let's figure out how to make this awful solution work first, and then optimize once we have some grooves figured out. Long answer, sorry. Thank you for listening.
Thank you very much. I cannot top that, but I would like to go to Ed now. We have discussed with Matt Crowley before about the need for volume production, and for that we need to scale up photonics. And for that there are certain lack of standardization and lack of ways to address those challenges that come when you take something to very high volumes. In your opinion, what are the main challenges that we're having in scaling photonics manufacturing?
Well, look, I think you just touched on a lot of the good points, right? I mean, at the end of the day, we think in terms of things as, when we start driving these processes, first you got to really industrialize the design, right? And you think in terms of, we talk in terms of standards or standardizing, but if you don't design it for scale and you don't drive that process, we talk about kind of shifting left, in the design process. You can have the greatest design, greatest performance in the world. If it's not ready for industrialization, you have no hope of automation, you have no hope of scale, right? And so understanding the requirements, what are we trying to solve for? Obviously, we're driving a technology solution, we need to understand what's the price point, right? You know, in Matt's presentation, we were talking about that, someone asked the ASP question. You know, really, what's the inflection point where this technology becomes adoptable and it makes sense to replace copper? I love what you've just talked about, right? If I think in terms of what we're talking about today in photonics, I also liken it to, you know, something else we're heavily involved in around liquid cooling. Some of these technologies were kind of nice to haves. They have been previously about maybe an efficiency statement, maybe a best-in-class statement. Now they're really about capability enablement. We're getting to the point where we have to have them for the rest of the system and ecosystem. So if we want to drive that scale, we need to make sure that we're defining what we're solving for, we're defining the price points. As a community, we're engaging the right partners at the right point in the process so that we're enabling that design to be industrialized and then enable the scale.
Optica staff is around here. Whenever you have a question, please raise your hand and the microphone will come to you. And now I have to address another topic, which is the photonics packaging. We've been talking about photonics packaging as a challenge already for many, many years. But now we are hearing it every year at OFC, 200 gig per lane. This year at the ECOC we saw a demo, 400 gig per lane. Actually, RF is becoming part of photonics packaging. And I would like to see some of you, what are your views on that, and how do we need to address the RF community and bring it closer to photonics, because it looks like we need it. Ashkan, starting with you, is in those high-speed applications, what are the current challenges of bringing RF to the photonics industry?
So nothing is new. It's just that people retire and then young kids like me forget what was done 30, 40 years ago. And so you think you have a new idea, but then you talk to someone and they're like, oh, we did that in the late 70s. So the value add, and this, I can point to a clear example from our own company, the value add and capabilities of systems and of packages is through multi-chip packaging. That's why your cell phone does what it does. It's 50 different companies with 40 different chips inside this tiny little box. We showed that moving from our Blackwell or our Hopper GPU into Blackwell, you build a bigger chip. It's 2 ASICs, 2 die talking to each other, high bandwidth memory, interposers, and the cooling. So amalgamation of various parts helps you bring more value. So when you do that, then if you're a mechanical engineer who's working on reflow and fiber attach and thermal management and warpage, you have a very good job security, because as more of these high power ASICs get integrated together, this is where you can deliver that goodness of the value. So your question was RF into photonics. It's all about signal integrity and minimizing and eventually eliminating the electrical channel. Digital compute will always be there, but then how can you turn that signal optically as soon as possible? And the vision is, look, if you could build a hyperscale data center or a supercomputer where the optics and the networking and the I/O were completely free, you look at the entire power savings and you're like, actually, that's still a lot of power because compute is pretty expensive. But if we can get to a place where optics and interconnects are effectively free, which is what I was saying at OFC, then what could you build? And let's work towards that. And high-speed integrity kind of goes away if you can eliminate that high-speed channel, thereby requiring advanced packaging.
Indeed. Actually, 2 weeks ago, I went to Denver, Colorado, and I visited Library Logic. And I was really surprised on how much a company has invested on RF testing.
Yeah.
However, last week, I went to ECOC, and I said, where are the microwave photonics companies? And they are, of course, they are a European Microwave Week in France. So we tend to have a problem here of bringing these two communities together. What's your take on that?
So much about technology application and adoption in the market is about storytelling, understanding what it is that you do, what are you actually good at versus what you think you want to be good at, and then who needs that capability, and how do you align these interfaces between what you do and what someone else does and what this other person does. So the analogy is like, I have a really good cattle farm, and like I could make really high quality beef, but how do I sell that as burger patties? Well, you need someone in the middle who's like, hey, they care about organic, grass-fed, humanely treated beef. Why? What does that mean for your health? So you got to completely close that loop. We try, and I try with the platforms that I'm given, thanks to you, to try to illustrate that whole story, to try to say, hey, yeah, if you do save me 1 dB on the coupling loss, what does that mean for 130,000 GPUs and a giant building? If you can close that map, hopefully you see the problem that we deal with end to end, And you understand why I don't care about the 1 dB that you're going to save me, because it's going to be 10x more expensive. So as more people get educated and they understand where their piece fits into the bigger puzzle, they can help close these gaps. And I will say this to anyone who is thinking they have a solution that can work for anyone on stage or everywhere else. Please approach the conversation with a lot more open-minded, rather than saying, you should just buy what I have, is ready to go. Be like, hey, I'm really, really good at doing this. Do you need this? Does it help you? Again, find that value, not look for the PO, basically. Help me understand how what you do maps into the problems that I have, which are millions, and then we can find this symbiotic existence here. It's a small world, fragmented world. I feel like also so much of the conversation today is around integrated silicon photonics, but lasers, 3.5, making a reflections insensitive EML so that I don't have to have an isolator. EMLs are shipping by literally the millions across the planet today. Solve that problem. That's a photonics problem. Solar cells is a photonics problem. CD burners, CD-ROM players, and DVD players is a photonics institute, right? The reason we have silicon germanium is because CMOS used germanium, and we just happen to pick that up. Everything is interrelated. Everyone works for us. Everyone works for us in the photonics industry. You can pull from all of that, but always find the value. I challenge you to do that.
I believe we already have some questions in the public. Please remind us your name and company.
Steve Katowski with Vanguard Automation. So my question, let me just first start out with a description of silicon photonics, which is supposed to be CMOS-based, but you need germanium for the photodiode, you need silicon nitride because the waveguides are high loss, you need undercutting, you need to do etching for V grooves, and now you're at the point where a Mach Zehnder kind of peaks out at 200 gigabits per second PAM4. Where do you go with silicon photonics? What's the future of that? And Greg, you're probably the best person to answer that.
Yes. I'm happy to start. So you properly identified all the challenging aspects of, today our platform is 100 gig per second. We know that 200 gigabit per second is there. I do think it's going to be moving from single lambda fibers to CWDM followed by DWDM. And of course, that puts a lot more challenges on your modulator designs and performance. You got to get from today our POR is 35 gig on the germanium photodiode. We know that we need to get to 65 to 75 gigahertz. So I think it's going to be moving into the DWDM domain as the only long-term approach to the overall bandwidth.
Any further questions? I want to continue with you, Torsten. You have identified one of the biggest challenges of the photonics industry is the fact that we need better wafer level testing. At some point, photonics, as it was defined, and I don't necessarily agree, by Maria Marcet this morning as a promising technology, we need to address the yield, but we also need to address the way that we test. And for that, we need to work closer with the RF community. Mm-hmm. How have you defined the business of eye contact into solving that particular challenge, and what is your preferred future in that respect?
So on the wafer level testing, there's several platforms which are already very standard for the semiconductor industry, for the pure electronics part, but there's not a specific machines for the optical part. So that is actually what we are tackling from Ficantech, and we just had a very interesting discussion with Louis Raphael from Femtum, where we kind of will cooperate in order to build machines which are actually finally also able to trim the wafer. So I think there's a lot of things going on. We can work when we work together, when we are collaborating, and we understand the problem of each individual party in the whole value chain.
So you're talking that not only you can test the wafer, but you could potentially fix
test, trimming, test. Actually, where we can then tune the Mach Zehnder's on the wafer.
Greg, this is what comes to me in my mind. If you are thinking about incorporating photonics to semiconductor fabs, there is so much effort in testing. We saw the diagram of J-Bill, we saw the business of Ficantech. Is that photonics is not mature enough not to be reliable, and we need to test and spend so much money in testing? Is that the challenge that we have now?
It is indeed a quite significant challenge, and to use the term that Matt said earlier, right, there's a lot of snowflakes right now, so every time you're trying to figure out how to do testing on there, once you get beyond insertion loss measurements and modulator frequency performance and into full-blown, optical circuit functionality. It's an area of the largest investment we're making, as we've realized that our customers are asking us increasingly to align with them on a test strategy.
And what are the 2 or 3 main challenges that we need to solve ASAP?
First of all, as said, complete lack of there being, industry standard platforms for test. We've been doing optical testing for a decade in GF, and today they're still homebrew tools. Right now, the inline optical test, finally we worked with Keysight to be able to commercialize their existing platform, but for the functional testing, those don't exist.
And why not? Because we are really good at standards in photonics. We standardize the single mode fiber, we standardize connectors. Why couldn't we standardize this?
Same reason the OSATs don't have photonic assembly capability, because the demand is not there. Tell me you got 30, 40, 50,000 units a month, you start getting people's attention. But when you're still in the early prototyping phase, you just don't get the investment.
We got some questions in the room. Please remind us your name and company.
Hello, I'm Ali from TNO. I have kind of 2-part question. One is, why do we want photonics to be a semiconductor technology? I wasn't here 50 years ago when semiconductors started, but probably it wasn't cheap, it was probably expensive. Or we know it was more expensive than the other solutions. And that takes me to the second part of the question. Why don't we take photonics to be kind of the high-end expensive solutions? Because we're competing with a huge giant that's called semiconductor.
Who would like to address that? Should we stay in niche markets and charge high prices for low volumes? Martin.
First question, why do we want to be a semiconductor technology? Because all the photonics people believe that if they transfer their processes to semiconductor technology, they achieve a yield of 100% and they achieve 300,000 wafer starts per year from a similar fab. If this would be the case, then the testing industry would not exist. So some photonics people have some very too optimistic imagination about photonics in semiconductor technologies. The second thing is, if you restrict photonics technologies to high end, it's very nice for HHI, for example, but it's very difficult to feed a company with the already small volumes if you cover the whole photonics market. And if you then restrict yourselves to the high end, it's very difficult to utilize the equipment you have. So it's a nice niche, but for industry, it's very difficult, I would say, to feed a company with that.
Did he answer your question? Any further questions in the room? I agree that there is a lack of standardization. I agree on that. But Ed, you have in this presentation by Matt, I could see a spot of testing in Europe, and I believe testing in the high volumes that Jabil is looking at needs to be standardized. Is it happening that companies are doing the standardization themselves and not sharing it with the community and not making industry broad standards?
Well, look, I mean, there's certainly a lot of companies that are out working on their solution or their design, when we see that often today. And that's not just unique to this industry, right? But in our experience, that's, again, it's going to limit scale. It's going to limit getting to the price point where adoption's, going to be mainstream, if you will. And so we see we certainly see a lot of people working on their solution, their optimization. Maybe it's their point they believe of differentiation. We frankly don't see a lot of work around the standardization. And look, I think where it's going to come from at the end of the day is the pressure in the marketplace from the end customers. The customers that know that they need this technology in order for their solution or their value to get to market. And just like, Greg mentioned, once you see the demand is there, then all of a sudden, some degree of standardization will occur. It's going to be whoever drives the volume first is inherently going to drive the standard.
I try to not say anything, but I'm going to say something. It is not volume. It is the crux of it is no one wants to give up their IP. That's it. Okay? No one wants to give up their IP because, Greg, you got a top silicon that's some thickness, and you have a grading coupler that you like. And Luke's got a different top silicon thickness and a grading coupler that he likes. And Torsten's got to go make a standardized tester. And so, okay, he asks, hey, at 1310, is it an 8-degree emission angle? Is it 9 degrees? What's the reflection like? What's the polarization sensitivity like? And you're like, well, it is the way it is. I don't know. What's the Rayleigh length? How far do I go? Oh, well, you know, it's proprietary. Someone else paid for that grading coupler, blah, blah, blah. Like, come on. It's just a grading coupler. I don't want to see the apodization and the chirp of your teeth and the etch of the grading coupler. Just tell me everything else. Tell me a mode profile. Tell me the emission angle. Tell me the polarization sensitivity loss, the emission angle, blah, blah, blah. So I can go and say, hey, if it's 1 dB or less, it's a good one. If it's 1 to 2 dB, it's a bad one. And that's it. And so you got to put a little bit of that skin in the game. I mean, that's like saying, hey, TSMC and Samsung, you have a proprietary micro bump. TSMC uses 160 micron, and Samsung uses 158 micron bump pitch. And then now you got to go design 2 probe cards. And what the hell, guys? It's just 2 microns. Can't we just align on one number? So the opposite of the question is, why do we have electronic standards? Because these fabs and these OSATs realized, I'm not going to differentiate and derive value from the hardware. It's just a testing interface, and a rising tide lifts all boats, so that if I just agree we're going to both equally have shitty gradings, but everyone can test them day in, day out, all day, and get a 1 sigma variation, a 6 sigma variation that's the exact same, great. Then we all can at least move product out the door, and one guy can build 1 testing script and 1 alignment algorithm. Right now I have 2 different grading couplers and then 4 different connectors. So that's a matrix of 2, 4, and then another 4, and then his machine's got to go figure out how to align 8 different things. It's like, holy cow. Why? And they're all, by the way, the best case scenario, all within 0.1 dB loss of each other, and everyone thinks that they're the snowflake. It's frustrating. For 10 years, this is the frustrating issue, right? So that the crux of it is the emotional detachment, and let some IP go, and share some of the know-how so we can all say, okay, now it's the same thing, right? Sorry, one last guy. The utopian place I want to get to is, without knowing what the physical structure looks like, to say that his grading and that other guy's grading are the same. Statistically, they're the same. Oh, man, that'd be beautiful.
I can't agree more. So why do you think whenever we go to a foundry, any foundry, so not only
he's on stage, so we're picking on him, yeah.
But I go to Smart Photonics, or I go to IHP, or I go to any foundry. The first thing to tell you is, here's the PDK sign and NDA. Why there is such a, in your opinion, I'm going to ask, of course, Greg afterwards, but why there is such a protection about the building blocks themselves?
Because they've paid out the nose for it, and they think that that's where their value is. But it's not. A PDK is an enabler. It's an enabler. We will give you the GPU for free if you will pay for the software.
Your life.
Right?
Greg, you're desperate to say something now.
So I think Ashkan is giving a view of the world we are today, but I actually agree with Martin's statement earlier. This is a discussion about the Precambrian period. Just think back, and I've long since forgotten when IBM invented C4 bump technology. That was a damn differentiated technology when they invented it, because they were able to do a pitch and reflow process that didn't exist. Today, how much drama is there around copper pillars and tin silver? It's not. The industry has ramped to volume. There's no differentiating. Of course, you're always trying to drive smaller bump pitches and tighter copper pillar, but everybody's doing the same things. They frequently land on slightly different pitches just because there isn't any standard or roadmap.
So why did IBM let that go?
So this is the key point for me. If you look back in that era, those things that differentiated then no longer differentiate. So today, you're right. Everybody's grading coupler, everybody's fiber attach process is out there.
It's pretty vanilla.
Yeah. And let me use the example that I think volume does matter. When Intel announced their Tri-Gate, 15 years ago, the industry went, that answers the question between fully depleted SOI versus FinFET as the volume driver. They literally, because they drove that volume, standardized what the industry adopted. Silicon photonics, I agree with you that eliminate the non-differentiated misalignment that exists, but a volume driver is a really loud voice that flattens a lot of those discussions.
Yeah, you can't deny brute force. Even if the technology sucks, you can't deny brute force. What I'm saying is you'll never have that magnitude of volume.
You saw the original Tri-Gate when it came out, right?
Yeah.
It was not a
With
pretty thing.
photonics, we're never going to have that kind of volume, ever. Even if you consider all the use cases of sensing and all that stuff, it's just not going to be.
It's never going to be high volume wafer manufacturing. It will be extremely high volume component manufacturing.
Okay. I mean,
and to Martin's earlier point, that 75% of the bill of materials is after the wafer leaves the factory.
So could we agree that if you eliminate the differentiation things that help you make components, we can drive volume?
I think that's a big part of it, yes.
Hey, so that's the interfaces, right? The electrical and optical interfaces. So go design whatever modular that you want, but couple to it all the same, so these guys can test and build modules all the same, because he doesn't care what's in the silicon. He just wants to stamp them out.
Agreed.
Agree is nice, but what do we do now? Do we take somebody from Tower here? Do we get anybody here and we say, okay, let's share the PDK? Do you think that's realistic today?
Well, that's unrealistic. I'll just go on record saying that today. Having said that, you know, ITRS was driven by end market customers, right? That these were IDMs vertically integrated, or the Qualcomms of the world that drove enormous volumes on there. Never underestimate the ability for NVIDIA, AMD, Intel, Broadcom to be the four elephants that said, we want all of you guys to align on these 5 things. Then we'll go work on our modulators and our waveguide materials, et cetera, and differentiate those technologies for superior performance and in particular cost, but it would remove a lot of the ambiguity and uncertainty outside of the wafer if in fact there were more.
We try to do that by speccing the effective price point. So if I want optics to be 20 cents and a machine is $500,000 and the best thing you can do is 30 units per hour, you're never going to get there. Then you got to say, why is it 30 units per hour? Why does it take 20 seconds to do this thing? Oh, because I got to get all my 16 fibers in the V groove just right and zap, 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 and cure them all. But oh my gosh, should I be doing something different? Go figure that out. I mean, we don't want to be too descriptive, and at that point, do that magic to figure out how to make it reflowable, how to make it scalable, so you can go from 30 units per hour to to 150. I think that's pretty realistic, to be able to amortize better.
We have some questions in the public, but then I'm going to come to you with that comment. But Michael, tell us.
Michael Levy, Lightwave Logic. Greg said something that really sort of got me thinking. It's the C4 from IBM, which happened in the 60s. I mean, it was differentiated. So the question is in the electronics industry, we've had a very, very successful CSP, chip scale packaging. Basically, throw away the package. So if you think about photonics, historically, we've had gold boxes. There's been some innovation around trying to get rid of gold boxes. What does the panel think about chip scale packaging for photonics, just not having the package at all?
Who wants to address that?
I'm not sure I understand the question, Michael. I mean, you're going to have optical chips somehow touching the ASIC in the digital domain. So bumps and fiber attach is all you got.
We're not going to have a gold box, right? So you're going to have maybe a PIC chip or maybe a couple of PIC chips. You're definitely going to have fiber attach of some kind, and maybe you'll have some bump in or pin grid arrays or some type of interposer. But it's not going to be a gold box. It's going to be something that's more electronically aligned. Is sort of where I'm coming from.
Yeah, I mean, even the EML business today, it's all wire bonds on a very nice ceramic COS. That's why they're expensive. So this integration play, I mean, your question earlier was, why do we want to be silicon integrated? Because we're going to be integrating. EML functionality, you just give it a supply current, then you have a backside monitor, and that's all you get. Integration gives you monitoring, gives you health of your links, health of your optics. You can do exactly this, build a large interposer that talks optically between various ASICs. That's why you want to be semiconductor-based technology, because you can derive value. Piece parts, optical benches, micro lenses, isolators, focusers, that kind of stuff. It's mom and pop shop. You're never going to trigger volume and deliver value, because you're always going to be too expensive.
Thorsten, we have semiconductor fabs manufacturing photonic integrated circuits. We have large companies bringing them to the next generation AI challenges. And we have companies offering packaging solutions, like, for example, Fix here in the room. the automation that was addressed just now by Ashkan. They were talking about high volume, but we have machines that only package certain small units. How can we accelerate that? Because at the end of the day, you are one of the market leaders, and you're a company with how many employees?
We're now in total 250 people.
Correct. Yeah. How can we accelerate that?
Working together, finding exactly what Ashkan just said, understanding why it takes so long, whereas still epoxy, which takes a long time to cure. We have the delicate fibers to handle. We grew quite a bit with very customized tool. So it was actually how we made good money over the last years. But actually, what we have to do as a company now, as Ficantech, we have to say no. No to all the different things, beautiful, wonderful, weird and wonderful packaging methods. And that's what my team is heavily working on. What we did is we did a map of all the transceiver packages and the co-packaged optics we did over the last 3 years. We put them next to each other. We built a machine out of it, and this is like a standard tool now, which we can go to customers. But it's like up to now we are like our customers were driving high speed through the fog. We saw the backlights. Now we overtake, and then finally we don't see anymore where the industry is moving to. So it's actually not our expertise to tell the customers, okay, that's where you need to go. But I think we have to.
Do you see a shift in our photonics industry? Because I saw the presentation by Luke and the Hoven today, and photonics was a layer in a semiconductor manufacturing line. And for many years, we've taken a photonic device, and we have aligned a fiber next to it. We have controlled the temperature. Tomorrow, we'll see great things from Peter O'Brien. Do we see a change in the mentality of packaging, in which we go more into less packages in the CMOS perspective?
Yes, so we're moving away from this individual packaged device to the co-packaged optics, which completely changes the machine layout. So that is, and the players are different. So we are talking now really to big CMs instead of to a larger number of smaller players.
Have some questions in the public. Please remind us your name and company. Yes.
No? Yeah, so this is Íñigo Artundo from BLC Photonics. We have been providing test services for the last 10 years or more to the photonics integrated industry. And I agree that standardization is really a must. We are working with software companies like Lucida or Synopsys to have some level of standardization of the layout of the photonic circuits, not to have the NRE cost for testing escalate into things that are not acceptable for industry. And we have been working very closely with Ficantech also to standardizing the wafer level testing tools that you need for that. But I think maybe this is a request for you, Jose, and for the whole Optica community, because we need more people like Ashkan, actually end users that are able to tell us what is really needed, because most of us here are technology providers, but of course without this kind of road mapping driven by end users, we will never be able to push this standardization forward, and this is also needed on the foundry side as well. So this is just more of a comment, right? Trying to push the end users who are actually driving the applications and the markets to really sit down with us on road mapping tables to really drive the road mapping of all these technology providers forward. So, yeah.
I do agree, and having Ashkan, having more end users in the room is mandatory. Now that you have the microphone, you have been designing for many, I would say almost all the foundries of photonic integration in the world. Is it true what Ashkan just said, that the difference between building blocks between similar foundries and materials is small? Is it easy to adapt a photonic design from one foundry to another today?
Unfortunately, Ashkan is right. There are plenty of differences on the PDKs, and not only between different material platforms, because we are talking here about silicon photonics, silicon nitride, indium phosphide. Now we have contenders like thin film lithium niobate, BTO, polymers. So this complicates very much the design work, but not only that, the software implementation into different frameworks of the PDK at every foundry also makes it more difficult. So if you really want, as an end user, to port one design from one foundry to the other to really drive volumes up or have double sourcing, it's really mission impossible nowadays. So it really requires huge investment and delays in delivery times.
I'm curious about...
So just a comment that sounds like it is missing the equivalent of a TSMC, a dominant player, who's actually setting the norm, because in my understanding, in silicon semiconductors, TSMC has their PDK and every other foundry needs to think about how to fit into that. So that actually this transfer from one foundry to another, it becomes much easier. So the dominant player sounds for me like is missing.
So we're conflating a couple of things, right? Porting processes requires a level of abstraction. When you port from Samsung 4 nanometer to TSMC 3 nanometer, you have no idea what the gates look like. You have an effective VLSI or Verilog A model, right? That lets you say, well, look, this transistor and this transistor are, the FTs are slightly different. Like you have a test bench, you pop in their components, you pop in this other person's, and then you look at the results. That level of abstraction, definitely not there for optics, because first to do that abstraction, you need volume data and blah, 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 blah. Companies like his exist because fabs can't test. What he gets paid to do is check their stuff. And then when I test that grading and it sucks, and I'm like, Greg, the grading sucks. He's like, sorry. Met my process standards, what do you want from me? I'm like, okay, well, this is the problem. You just sell me a wafer and wish me luck, and then I got to deal with it. So actually, you need to buy him and put him in your fab, so that all I get from you is a known, good, qualified PDK. And then what I spend my money on doing is functional testing, ADST, Adman test, where you have no idea what's my circuit. It's like the prototypical example is a PLL. I design a PLL, phase lock loop, the way I want to do it. But I need TSMC or Samsung or Intel to tell me, did their resistor, inductor, capacitor, whatever, hit spec? They have their own test keys. They test all that stuff. They give me that report. So when my PLL doesn't work, I look at the process monitors. I look at the PDK component test results. And I'm like, yo, fab, you are absolved of your responsibilities. My designers are a bunch of idiots. I go choke their neck. But if I don't have that, the designer's like, hey, man, I designed it right. The fab sucks. And the fab's like, hey, man, you designed it wrong. My process is good. And I'm stuck in the middle. That's the real problem, right? So porting is a very simple statement to make, but there's a lot of complexity under that we're still not there yet.
You have to comment, Greg. You cannot just leave it there.
I just met him yesterday, and Greg hates me
I
already.
think I just got M&A advice a minute ago.
Honestly, right? And I mean, your point ago about like standard footprints, that's spot on. Absolutely. That's a huge bottleneck.
We have some questions in the room and only 5 minutes to go. So all the way in the back, please remind us your name and company.
Tolga from ICM. We do see in the last years that photonics coming to the interposer. So is it a case that photonics becoming kind of packaging platform for high bandwidth microelectronics?
Absolutely. To me, it is. I think optics is just another very good scalable transmission line. You got to think about it like that. It can be a transmission line on the chip. It can be a long distance wire with fiber. Right? That's the holy grail.
We have more questions. Please remind us your name and company.
Alex from Inalum. So we're doing lasers, and it seems like an active device is a big issue when you compare it to copper because it's less reliable and so on. So my question would be, do you think systems like WDM systems to reduce the amount of active devices we use is the right way to go to reduce like the issues with the reliability and so on? Thanks.
I'm talking too much. Somebody else take this.
Go ahead. You want to.
So I think WDM is going to struggle for two key reasons. And the flip side of that is you have to ask yourself, why do we have high-speed SerDes? We have high-speed SerDes because, as you just very clearly heard, we had 160 micron bump pitch C4 70 years ago. Nothing has changed. Metallurgy sucks. It doesn't get smaller. So the only way to increase stuff is to just shove more bandwidth density. So if you come to me and say, hey, what used to be a 200 gig single diff pair, now I want you to make it 8 diff pairs running at 25 gig or 32 gig, I'm going to tell you, can you give me a package that's 8 times bigger? Because I'm going to need 8 times the number of diff pairs. And then go talk to all these folks who make organic interposers, silicon interposers, and find out that the cost at 50 millimeter on edge to 60 millimeter on edge to 70 millimeter on edge is like this. So no, it's not tenable. Not to mention all the other stuff you got to do in the optical domain. But just from a bandwidth density perspective, we're not there yet. Packages are too expensive at the sizes that you would need in order for me to be able to build a 50 terabit ASIC.
Martin, would you like to comment on that?
So I'm a bit more optimistic about WDM in that application segment whenever shoreline densities plays a role and you have simply a problem to get too many optical interfaces on a given centimeter of space. And on the other hand, as far as I know, all optical technologies which are capable for DWDM, DWDM would require temperature stabilization on a 1 degree level. And if that would be possible, I mean, that would open up completely new room for optics, but I'm a bit skeptical about that.
Yeah, I agree with that part too, to pour on more bad news.
Let's finish with some good news. We have
come on.
2 minutes to go. So I'm going to go through the panel now, and I would like to ask you, when we have the Global Photonics Economic Forum in 2030, somewhere here in Malaga, what would be your preferred future? What would you like the photonics industry to look like with respect to semiconductors? Let's start with you, Greg.
Well, very simply, to have successfully made the transition from SerDes copper and electrical into the photonics world. And that's a statement about pluggables, certainly co-packaged optics we expect to be in very high volume manufacturing. But the dream is there's an ecosystem of partners that have aligned on things that don't differentiate a product, that allow equipment providers to make lower cost, high throughput, highly automated solutions. And I think, given the significant cost associated with the post-fab processing, that's really where the work needs to be done. By no means am I suggesting we got everything licked at the wafer level. There's still lots of work to be done, but we need industry-wide effort convening to drive the cost down.
Thursday.
So my vision is having our equipment fitting into standard electronic packaging lines, no touch points anymore, no manual labor in between, blister in, blister out, fully laser marked, so fully automatic lines with photonics packaging.
Ed?
Yeah, we've had some discussion around interposers and co-packaged. I think a lot of this stuff, not just at the wafer level or at the optical component level, but really at the system level, right? I mean, today we build, we'll build 30,000, fully integrated hyperscale racks a year. We're building stuff for automotive, a lot of other industries, and it's not just about the testing post-wafer. It's really the testing of the system. And oh, by the way, the systems are getting much more complex and much more expensive. So, I'd like to see us, as we really get these things integrated at the system level, the opportunity around obviously latency and power, throughput, and then really optimizing the test end-to-end. It's a significant opportunity for our customers in the end market. So I'd really like to see the community come together and see us go whip this thing, because the upside's significant.
For me, it's actually a dream having Jabil talking about photonics like this. It's actually, for me, you just made my day, the two of you, really, honestly. Martin.
I don't have a vision, but I have a dream. So my dream is that the CTO of Coherent, the CTO of Lumentum, CTO of NVIDIA, Global Photonics, and Google, Facebook, they notify this discussion here. They sit themselves together, start some standardization activities on optical submount level for co-packaged optics, and next year they sit here and report about their progress.
That's not a dream, that's a challenge. Challenge accepted. Burkhard, what's your preferred future?
I like that as well. Well, I have actually a wish list. So on the one hand, I have a wish list on to the foundries. I think you guys need to figure out how to handle low volume and integrate them and still generate value. So going back to Michael, I think it's Michael's question of Michael, right? Of wafer level packaging, for example. You can do this today. You can do a back plane for a micro display. You can make a front plane. You can make a wafer level bonding. Everything wonderful. And then and you can do this only in a quite advanced 300mm line. But you guys would doubt, and your colleagues would say, oh, the volume is too small. So we need to overcome that.
I imagine a scenario where fermions and bosons can intermingle and the transition of information from one to the other is seamless. So electrons, photons and phonons can kind of mingle and live together, so you can do optical communication and optical compute heterogeneously inside of a package. If we can get to that state, then we've been as successful as physics, the laws of physics, allow us to be.
Wow.
Nerdy answer, but
He asked for a vision, right?
Yeah.
That was awesome, wasn't it? Well, the coffee break is now and it's the most important part of this event, so enjoy it.
Thank you. Thank you.
Ladies and gentlemen, time for coffee and meaningful conversations. And please visit the exhibitor booths outside. We're delighted with the support from the following organizations:
SECFO, Fotónica 21, IMEC, Keystone Photonics, Malaga Tech Park, PIC UPV, PIC Spain, Vodafone, Disruptive, IFOS, Innova IRB, Cadence, Photon Hub, Bullnet, Vanguard Automation Micronic, GDS Factory, Bioherent, Vigo Ventures. Invest in Andalucía, Andalucía Trade, Junta de Andalucía.
For our next keynote session, we're honored to introduce Dr. Chuck Matera, retired chair and CEO of Coherent Corporation. In that position, Dr. Matera transformed an optics materials technology pioneer into a leading global photonics business innovator, today spanning 5 continents with more than 26,000 people. Along the way, the company's annual revenue grew to more than $5 billion. When he retired from Coherent in June this year, Dr. Matera left Coherent well positioned to outperform its competitors. Now he's excited to kick off the next 20 years of his career. Please welcome Dr. Chuck Matera.
Well, good afternoon, everyone. It's really great to be here. I'd like to say up front before I start my remarks, and before I say anything else, I don't have any jokes to tell. I don't have any forecasts. I don't have any financials. And I've heard somebody fondly describe me outside of the coffee break as no longer being incoherent. I want to wholeheartedly thank the incredible team at Coherent for the privilege of serving them for more than 20 years. I also want to thank Optica for 108 years running. Optica has been making a profound impact on our industry and on our world, from the recent Frontiers in Optics conference to this inaugural forum. Optica is inspiring engineers, scientists, executives, academics, researchers, and regulators to put the science of light to work for humanity. As you will hear this week, together we're solving not only the most fascinating problems of our time, we're also preparing the next generation to meet the challenges they'll face 25 to 50 years from now. Sustainable, long-term innovation takes vision. It takes patience and commitment. And most of all, it takes time. On this point, Einstein put it beautifully. It's not that I'm so smart, he said. It's just that I stay with problems longer. And that, in a few words, is what I came here to talk about, staying with problems longer. I know it sounds old school. After all, we are in the age of disruption. The AI race is on, and no one is standing still. Megatrends are transforming industries, and the planet's climate clock is ticking faster than ever. As the speed of change accelerates, taking the long view can feel like daydreaming. Investing in innovations that are a half a century away might feel like a fool's errand, but it's not. In fact, it's essential that we stay with problems longer. And I speak from experience. When I started my career in 1984, our industry was even more future-focused than it is today. If you were a forward-thinking scientist, you could find a place at one of the many great industrial research labs like AT&T Bell Laboratories, where the business model was designed to provide long-term funding for endeavors that wouldn't bear fruit for decades, if ever. Today, this way of thinking and working is increasingly called into question. Worldwide, our investments in the long-term R&D horizon seem to be growing short-sighted, at the very moment we should be doubling down on long-range innovation. Be it for new materials, new lasers and optics, or the next generation of photonics. But no matter how fast our world changes, Einstein is still right. We need our smartest people to stay with problems longer. Some of the most important innovations now underway may not be ready for deployment until, say, 2050, and maybe even 2075. And that's exactly what should be expected for some part of what we're doing. Let me share a few examples to illustrate my point. In 1983, the world's first cell phone had just hit the market. It was the size of a milk carton. It took 10 hours to charge. The battery lasted 30 minutes. Oh, and by the way, it cost $10,000. Back then, I was part of a team exploring the frontiers of semiconductor lasers. Looking back, it's satisfying to say that our work was well ahead of its time. But I can assure you that back then, feelings were mixed. Even back then, feelings were mixed. Of course, scientists found our work completely thrilling, but for the executives and investors, it was hard to see if, when, and how it would ever pay off. And yet today, your iPhone, our iPhones, run on lasers. To be fair, it isn't that executives in the 80s were asleep at the wheel. Back then, there was just nothing obvious about the long-term prospects of using lasers in a mobile device. Indeed, it's a textbook example of an age-old problem on how we think about innovation. In his Nobel lecture, the legendary Herb Kramer described the problem like this. Typically, he said, we value innovations based on how they improve existing technology. And too often, we discount the new capabilities that an innovation will unlock with future technology. Kramer learned this lesson the hard way. In 1963, he wrote a paper describing his idea for a radical invention, the double heterostructure laser. After applied physics letters rejected it, eventually it was published in the Proceedings of IEEE, but it was largely ignored. Kramer then secured a patent that went mostly unused until finally it expired in 1985. Today, of course, we know that Kramer invented a core technology for modern semiconductor lasers. Now, the world that Kramer and his colleagues came up in had little use for this innovation, but ours would not be possible without it. In 1977, Professor Iga in Japan took Kramer's work even further with the design of a vertical cavity surface-emitting laser, or VCSEL. Again, here was an innovation that was decades ahead of its time. 12 years later, in 1989, my old friend and colleague, Jack Jewell, led a Bell Labs team that demonstrated it was possible to fabricate more than 1 million VCSELs on a 0.5 centimeter squared piece of gallium arsenide. It was a marvelous achievement, permanently redefining what was possible. Then in the mid-90s, our very own Julie Yang envisioned a world where datacom transceivers could harness the power of the VCSEL. For the very first time, she and her team at Finisar incorporated VCSELs into data center infrastructure. Back then, nobody could have expected ChatGPT to emerge, but now it has. And it's standing on the shoulders of Julie's work. That's about 30 years after Julie's breakthrough, 45 years after Professor Iga's invention, and more than a 0.5 century after Herb Kramer failed to get his paper published. Even for the most profound scientific advances, it really does take that long to change the world. Which means we have to ask ourselves, does the next Herb Kramer or Julie Yang have whatever they need to invent technology that won't be market ready for decades? Who's investing in their work right now? These questions are critical because even as the world moves faster, we need innovators to stay with problems longer. Another example of a long-range innovation that's only now proving to be a game changer is EUV lithography. The possibilities that EUV technology unlocks could easily be confused with magic. And it's entirely thanks to the patient, visionary investments that were made decade after decade. Looking ahead, I believe that perhaps the single most valuable problem that photonics can help solve is, interestingly, both long-term and urgent. And that is sustainable energy. In fact, you could argue that the AI energy crisis is urgent today because for too long we haven't had enough people or resources invested in long-range innovation. Consider that for a single query to ChatGPT draws enough electricity to power a light bulb for 20 minutes. Imagine what it means at scale. If you multiply it by the number of daily internet searches, you're talking about enough electricity to sustain millions of people. Earlier this year, the International Energy Agency warned that the amount of electricity consumed by AI and data storage could double by 2026. That's like adding another Japan to the world's power grid. And as urgent as our energy problems are today, they'll be even more serious tomorrow. This isn't just a technical challenge. It's an existential threat. And considering that photonics is at the core of the AI revolution, I believe that we have an opportunity and a responsibility to help solve it. For the first time in generations, the trillion-dollar question is changing. Instead of asking, how do we compute more data faster, the smarter question is, how do we consume less power during the computation? In other words, how do we rely less on electricity and more on light? What innovations are needed for us to take the leap from the century of the electron to the century of the photon? Well, even as we speak, our field's leading innovators, and to be clear, I'm talking about many of you, are bringing that future within reach. For example, an award-winning team at Coherent is making it possible to retrofit data centers replacing mechanical switches with optical switches. Basically, they're effectively switching a signal's path, moving packets of information with a fraction of the energy required by electrical switches. Similarly, lasers are making it possible to revolutionize data storage. Just as we did with CDs and DVDs, we can use light to encode data onto light-sensitive materials, except now we can do it at the nanoscale, and depending on how light travels through the materials, we can even think about adding a fourth or fifth dimension to data storage, opening up orders of magnitude more capacity using orders of magnitude less power. If any of this sounds unrealistic, just think of the ways we used to use light to overcome time and distance. A half a century ago, before I started at Bell Labs, the world's telecommunications systems were strung together with copper wire. Then we discovered how to increase bandwidth, sending more information farther and farther away by stitching together fiber optic cables undersea. Eventually, we made the technology scalable so that we could start building fiber optics right into our cities. Then we made it small enough to fit inside a data center, then onto a server rack, now onto a microchip. Next, many experts believe it's just a matter of time before photonics and electronics are fully integrated on the same chip. And then we're talking about a brave new world of wearables, hospital gowns with biometric sensors literally woven in, uniforms that allow soldiers, nurses, and emergency responders to share information instantly, hazmat suits that help factory workers stay safe even in the most dangerous working environments that millions of people on the planet work in. Our future may be unpredictable, but this much I know for sure. The most valuable innovations ahead of us, technologies that will dominate the next 50 years, will be the result of patient, visionary investing. And we need to ramp up those investments not tomorrow, but today. As the management consultant Peter Drucker once said, the best way to predict the future, to create the future, is to predict the future is to create it. That starts with dreaming bigger and with a larger cross-section in our ecosystem. photonics is about so much more than producing ingredients for some other sector's technology. When we're at our best, we make the impossible possible. In countless ways, we can and we must continue to make our world safer, smarter, and more sustainable. No doubt, whoever creates the optics of the next generation of smartphones will be handsomely rewarded, but we have to ask ourselves, how long do we really expect to live in a world where we walk around with these devices? I'm sure that you saw from recent news of Meta about their advances using silicon carbide optics to enable AR glasses. Well, soon enough, a whole new generation of optics may dissolve the physical screen and embed small digital displays directly into our environment, allowing larger format displays to emerge with micro LEDs. Now, if we're serious about building that future today, we will need to get more comfortable with my favorite F word, failure. It's a fact of life. From physics to business to football, our greatest success typically comes after many spectacular failures. Scientists know this in our bones. Executives and investors spend unholy amounts of time and money trying to avoid it. But speaking as a scientist who just spent 20 years in a C-suite, let me assure you, our ability to create failures fast, to learn from them, and then overcome them is a powerful competitive advantage. Indeed, that's what I miss most about working at Bell Labs. As far as I can remember, the only directive we received from the top was to be brilliant. And it worked. Critical mass, diverse skills, interesting problems, deep resources drove Bell Labs to win 10 Nobel Prizes and 5 Turing Awards. Looking back, it was the only place in human history that could have invented transistors, lasers, solar cells, satellite communications, and even the foundations of modern AI. There are other examples of a modern-day renaissance in R&D investments in the US and in Europe. For example, this morning, we heard an inspirational overview of IMEC. Today, most business models do not provide the infrastructure or resources required to generate long-range breakthrough solutions. Instead, more and more of the resources we should be investing in long-range innovations are being spent on short-term goals. And that's not all bad. It's not bad at all. The good news is that organizations like Optica and strategic business forums like this one really can help academia, industry, and government move forward together. And to that end, I encourage all of us to own our expertise and our experiences. Our industry underpins and augments nearly every major growth industry on the planet. Communications, computing, imaging, sensing, navigation, cryptography, AI, quantum, and even the clean energy transition. Not only can we see a whole world of possibilities 25 to 50 years out, we also know what it takes to get there. In closing, I want to share a few words for anyone who hears this from overseas. Over the next 50 years, innovations will emerge from places that are not only in Europe or in the United States, or in the most developed economies in Asia. Very likely, they'll also come from places that few people can even think of as innovation hubs today, including in East Africa, Latin America, and other places across the global south. All to say, if you're coming up in this field and you don't see yourself yet represented in the ranks of leadership, please do not be discouraged. Do not settle for solving narrow technical problems. Rather, have the audacity to take on the greatest challenges of our time. Let someone else focus on increasing bandwidth or decreasing latency, all of which are important. But we don't need everybody focused on those. Instead, think about the innovations that will give energy-efficient access to every person on the planet for the internet. Now, conventional wisdom says that technology is neither good or bad, it's value neutral. But after 40 years of working on the cutting edge of photonics, alongside so many of you here, I'm proud to say that it hasn't been my experience at all. I believe that photonics is fundamentally bent on harnessing the power of light for the betterment of humanity. So, instead of doing what's realistic, show us what's possible. If you can stay with those problems longer, then I guarantee that the rewards will be worth everything you have to give. So be bold and know that we have your back. Thank you all for your leadership and contributions to this vital community. My money is on all of you, and I'm betting that the best is yet to come. Thank you very much.
Well, thank you, Chuck, for that wonderfully inspiring speech. I'll start us off with a couple questions, and then we'll open it to questions from the audience. Chuck, you joined the board of 26, I think, when they had 50 million in revenue, and you became an executive there when they were 150 million, and by the time you retired, Coherent was a $5 billion company. And you did that both organically and also through acquisitions, not all of which were understood at the time that you did them. Maybe can you just tell us a little bit more about how you think about acquisitions and growing a company?
Okay. Thank you very much, Julie, and thank you for your kindness. We took some very, very simple and basic steps to the process. We focused on the market. We understood that it's better to be a good company in a great market than it is to be a great company in a good market. Of course, my view is that Coherent is a great company in a great market. We took a long-term view about technology platforms and the ability that we would be able to drive them across multiple end markets. And we had the very disciplined approach to the financials with regard to returns on the investment. And we spent a lot of time thinking about the talent and how the talent and the culture would fit in. We surprised people. We did 25 acquisitions in the time I was there. We surprised people from time to time because they couldn't see how the pieces would ultimately fit together. And it was a challenge to be able to explain. But that strategy of both disruption and operating with some ambiguity and taking full advantage of the surprise, the element of surprise that we must in a public company. And it really ended up so far at this stopping point as an extraordinary platform. As I've said about the industry, I believe about the company, the best is yet to come.
Great. Thanks, Chuck. Very, very interesting. And now you've retired. So have you picked up any hobbies since you've retired? And do you want to give us any view of what's up for the next phase of your life?
Oh, okay. Well, I'll keep both of them short. I worked for 20 years at AT&T Bell Labs and the successors. I worked for 20 years at II-VI and Coherent. And I retired from Coherent, but I'm dreaming about my third and final 20-year act. And I'm focused on those aspects of resiliency for the planet that will allow us to remain or get even safer and smarter and more sustainable. So I'm focused on that. The energy transition is among them. But as far as my hobbies, I really never had any, but I have one now. And if you make a quad chart with performance on the y-axis and fun on the x-axis, I'm in the lower right-hand corner of the quad chart as it relates to my passion for playing rhythm guitar for blues music. That's what I'm interested in. Yeah.
Great. Thanks, Chuck. All right. Any questions from the audience? And if so, raise your hand and please identify yourself.
Chuck, thanks for that great talk. I'm David Hagan, one of the few academics in the audience from Creole, the College of Optics and Photonics. So thanks for the nod to long-term research. We've been in that business for a long time. I'd also just like to maybe make the comment that serendipity has got a lot to do with it as well. And just take Jack Joule's example. He wasn't trying to make VCSELs. He was trying to make optical logic elements. And he put a lot of work into that, and it paid off in a completely different way. So thanks for the nod to long-term research. We're still doing that in universities, but hopefully companies can find some way to invest in that as well.
Thank you, Dean Hagen. Yep, thank you.
And just as a follow-on, also, Chuck, maybe you could talk a little bit about how you balance, like the long-term view with sort of the short-term, you know, all the pressures that you get from investors, the board, et cetera.
I think it all starts with setting the values for the company and a strategic direction, and being sure that the culture has a centripetal force to it. And that's what we were able to create, is this force to the center about a purpose that we had that was much bigger than any of us. And we have to balance. We're a public company. We have to say what we're going to do and do what we say. But the reality is that the time goes by fast. It's 40 years and I'm here. If we didn't have a view and didn't have people that could see out to the horizon and maybe even beyond the horizon, we would never be ready. And every business case that we ever did was wrong, because all forecasts are wrong. We either arrived too early or we arrived too late, but in any case, we had to make adjustments so that we could win. And it was all about balancing the short term and the long term with the talent that we have and their aspirations to change the world. Okay?
Hey, Andrew Ace, IDEX Optical Technologies. So you said you went through, what was it, 25 acquisitions over the course of your career there. I forget the statistics exactly, but I believe something like 60% or more acquisitions fail from a perspective of financial results and other things. So what do you think was some of your guiding principles and success in guiding the acquisition strategy that you had? And then also, what were some of the biggest lessons learned?
We have a discipline. We have a process. We have a discipline. We stick to it. Some of the best deals that we did were the deals that we didn't do as a result of that process. Our board guided the management team at every step, so we had a view from the outside, if you will. I think you have to stick to the discipline, and the amount of due diligence and the amount of time that we spent with management teams before we acquired a company. We're really acquiring a set of colleagues, a set of collaborators, and people that we need to have a foundation of trust with from the day that we get started. We put a lot of effort into it in addition to the financials, and everybody knew from the moment that they came in on day one, they belonged.
Chuck, thank you very much for your Bell Labs stories. I, too, started at AT&T in 1984, so some good memories, 4 ESS, 5 ESS, DAX, all that stuff. But so you've gone through a lot of acquisitions. You encouraged everyone in this room to focus on the long term, stay with it longer, be patient. Yet the financial community today is not very kind, right? You hit your numbers every quarter, you keep growing, EBITDA, whatever it may be. How did you balance your customer set, which these days is the hyperscalers and not so much the service providers, because that market has slowed down a bit? How did you balance your long-term investment with a group of very large customers who are relatively risk-averse?
Let me clarify. I'm imploring a focus on the long term, but I'm not suggesting to ignore the business realities. That has to be taken care of. It has to. That's table stakes. That only gets you so far. And you wake up and you find out. You either have the wrong platform, you don't have what you need. I'm suggesting to take that long-term view and sustain that long-term view as a way to sustain the platform that we're in. There's no way around it. We were focused, the company is focused on sustainably growing. But if you're only looking out 1 or 2 or 3 years, we do a 5-year plan and even a 10-year plan, it's not enough. You need to have some people who are encouraged and have the skill set and the passion for looking well beyond that. Because in the meanwhile, you can take your eye off the ball and miss it. As far as the large customers go, I mean, we have enjoyed a tremendous experience with that. And the largest customers, the largest blue chip customers in every one of these industries, I don't think, at least I can say for me and for the company culture, we wouldn't trade any of them away.
Thank you.
Yep.
Okay, I think we're out of time, right, Jose? Okay, thanks Chuck again. Thanks, Chuck.
When that speech reaches thousands of views on YouTube, you can tell everyone you were here seeing that in person. Thank you very much for, so far, a fantastic day. Many people talk about sustainability in photonics. They think, okay, this is the next thing that we need to address. And I tell everyone, we are really sustainable. We use the most sustainable material in the world, glass. And for that, I wanted to have a nice discussion on that particular topic, the future of glass. And there's nobody better in the world to moderate that discussion than my co-chairman of this event, Mr. Reinhard Volker.
So good afternoon. Glassmaking, 1,000 years of innovation, making nice things. Nothing works without glass. So please take a seat. So I have the big honor to have 2 of the key brains of this industry. So Hartmut Sahel-Marberg from Schott and Horst Appel from Corning. So let's start with a very short teaser, who you are, why you love photonics, and please, Hartmut.
Yeah, thank you very much for having me here. This morning it was asked what the people were dreaming of, if they were dreaming of photonics. So actually I was dreaming getting a rocket scientist, but unfortunately I just made it to physics in high school, and then I ended up with a degree in business administration. But now I'm back on track. I'm within optics. I'm responsible for our optical glasses and for our components. And yeah, why I'm finding it fascinating is actually what you, Reinhard, this morning said is our challenge being recognized as an industry. I think the reason why we are not, because we are an enabler of many industries, and we as material providers are even enabling you as enablers. Yeah, but that is where the fascination I have with it, because it's so dynamic, it has so much potential, and yeah, I like what I do.
Thanks for coming here. Dear Horst, please.
Yeah, my name is Horst Appel. I'm 64 years old, married since 36 years, with 2 adult sons that are out of the house. Yeah. And in the meantime, we have got 3 grandchildren that I love a lot, and I'm a PhD in chemistry. And I worked for 11 years in the area of analytical instruments here in Europe. And in 2001, I joined Corning in Wiesbaden, and my first job was I was responsible for this big company located in Oberkochen that starts with a C and ends with an Alzheimer, you know. So this was my first job. And in the meantime, I'm responsible for business development for Corning here in Europe, Middle East, and Africa. And until approximately 960 days ago, also for Russia, but this is discontinued, as you can imagine. And you asked the question about what fascinates me. There's the following story. About 21 years ago, the astronomers from the Hubble Space Telescope, they directed the telescope to a position at space a little south of the Orion star constellation, and to a place where they assumed there wouldn't be nothing, right? And then they did this short before Christmas. They left over Christmas, returned in the new year, and then they downloaded the picture they recorded from this tiny spot in the universe that was integrated for 11 and a half days. And then this was the wow effect. Until that moment, there was a discussion going on our planet whether there were more sand cones on our planet or whether there are more stars in the universe. And this one picture, if you want to Google it, it's the deep ultra deep field picture of Hubble Space Telescope. If you Google that, you will see that just this tiny spot of the universe contains 10,000 galaxies, and no one was aware of them before. And the spot they examined was kind of, if I would place a euro underneath the roof here, that was the tiny spot. If we would like to map the entire universe, it would take 12 million additional similar pictures to get a full mapping of sky. And since this is so fascinating for me, I could talk hours about this, but I give back to you if you...
Well, thanks for sharing. So this is maybe the answer for the Generation Z. We need to create heroes journey for the kids. So something that really, wow, tears them into our industry. Now, sustainability, global zero. So I just mentioned in the morning, so glass makers had to go from one place to the other some 100 years ago because all the wood was chopped, all the forest was gone. So what is the future of sustainability, global zero for the glass makers? Hartmut, please.
Yeah, we are of course as well confronted with this challenge, highly energy intensive, you can imagine. And we took the challenge. So 2019, that's our reference year. We calculated that we have a CO2 footprint of roughly 1 million, scope 1 or 2 and 2, those of you who are familiar to those calculations, and heavily dependent on fossil energy, gas, and partly, luckily already as well, electricity. I can already spoil a little bit. Meanwhile, some years afterwards, we are on track. We have saved 60% roughly. Major lever is electrification, and that's as well the major lever we are continuing to do. It's technology change, yeah. But you can imagine it's challenging. At SCHOTT, a lot of fossil energy, but that's not the only challenge. The other challenge is we do have at least 200 different glass types, at least, if not more. We have all kinds of different tank sizes. So the ones I'm responsible for in optical glass melting, that's the easy ones, yeah, because they are partly the smaller ones, just a desktop size, yeah. But you imagine in the home tech industry or in pharmaceutical industry is much, much bigger. So many glass types, and those, we've talked about this today as well. It's about chemical properties, it's about mechanical properties, and of course about optical properties. And we need to switch them within a technology change, and firing with a different firing technology does have an impact on the glass properties. So what we did recently is we have done our first test with hydrogen powering of an optical glass. So we took a catalog glass, and together with a large component supplier, we made a test, and we have proven now that we can produce in specification, and we are on track, but it's still a long way to go, but we will make it, yeah. So the objective is 2030 being the first CO2 neutral specialty glass producer.
2030 is challenging. That's not so long, huh?
Yeah, but
wow.
there's a roadmap in place. Yeah.
Yeah. Horst, what is Corning doing?
Well, Corning is taking this topic very, very serious. So what I can announce is during the past 10 years in a row, Corning was awarded from the US Department of Energy as the Energy Star Partner of the Year. So we are continuously improving our processes. We are releasing once per year a sustainability report that anyone can download if you want. And in this sustainability report, we're not just looking to energy, we are also looking to fair payments, we are looking to fair treatment of genders, for example, because everything fits together at the end of the day. The Corning perspective is we have a footprint, a sustainability footprint. And the footprint is basically what we are doing, how we operate, how this reacts, what is the outcome there. And I can give you an easy example for the footprint. For example, what we have done just recently, we have signed a contract with one of the largest photovoltaics plant here in Europe. Actually, it's located here in Spain. And this will enable to supply our entire European organizations with electrical energy to the fullest extent. The plan for the next upcoming 4 years is to also perform identical steps in the US, for example, and to have until 2030 all operations in the US and in Europe where we cover the electrical energy by renewable forms, right? But now there is a second thing, which I said is called a handprint, right? The handprint for us is what do other companies are doing with our products? And I guess the easiest example is our business for our environmental filters. As you probably know, Corning is manufacturing ceramic substrates that since more than 50 years are making our air cleaner. Nowadays, we are removing 99% of the poisons coming out of an exhaust system from a car. As a matter of fact, we are now, during the last 50 years, we have removed 4 billion metric tons of nitrogen oxides, of hydrocarbons, of carbon monoxide, and of course on fine particles from the exhaust systems of our cars. And this is basically our handprint. And handprint and footprint basically belong together.
So that means you could fly around the planet for the rest of your life and you would have a green balance. Very impressive. So when we prepared the panel, so then I learned about that glass makers are doing something with laser fusion. So I could not believe it. So Hartmut, please explain. Laser fusion, why is this a market opportunity?
Yeah, it's a big market opportunity, and it's of course connected as well, possibly in future, to getting CO2 neutral. Because one thing what I didn't disclose about the challenges we have with getting CO2 neutral is of course as well infrastructure, getting the energy, the CO2 neutral energy available, and having it as well as at competitive prices. And here, laser fusion could play a major role in future. I don't dare to say when it will happen, but meanwhile, what I understand that scientists are getting more confident it's getting closer or more tangible, because we had, with a net gain event at Lawrence Livermore, end of 2022, I think we had an industry change. Yeah? An industry change in that sense that it switched from science to startup, or to startup meaning to companies getting interested in commercializing it and as well industrializing it. Yeah, and that makes us as well very confident, and that's the path we would like to support, and we do support it with our laser glasses. That's the one part, it's for the active laser generation part, and the other part is in the beam pass components that we provide. Yeah. And this change this change of dynamics from science to startup makes us confident it will happen. But looking forward, I think there's still a far way to go, because there's, as far as I understand, still fundamental issues. I would assume those fundamental challenges are not that much within this community here, or let's say within the optics part of it. There's a lot of challenges, but things are in place. Yeah, how to scale up, and solutions are in place, so they shouldn't be showstopper challenges in the optics, but within the fusion process itself, there's probably fundamentals to be solved to really make it industrialized and scalable.
Yeah. Well, this world is facing a dilemma. In 2020, the world capacity of energy was 20 terawatts. In 2060, some people predict that we will require a capacity of 60 terawatts. And at the same time, of course, we are increasing renewable energies, no doubt about this. But at the same time, we want to stop using fossil fuel to the fullest extent. So this leaves us at 2060 with a gap of approximately 30 to 40 terawatts of energy, of capacity. And no one at the current time knows how to close this gap. And therefore, as Hartmut said, we need to look for all kinds of possibilities to close this gap. Laser-induced nuclear fusion is a great possibility. So how it works is they fire high-energy lasers into a target. The target is like 2 millimeters in diameter, and it contains hydrogen isotopes, basically deuterium and tritium. And then the inferno breaks out. They introduce about 1.3 or 1.8 megajoule into this cell, and then the nuclear fusion starts. It creates a temperature of 100 million degrees Celsius and a pressure of 10 million bar. To give a perspective of 10 million bar, you have to put 10 battleships on your thumb and focus the pressure of this battleship to a size that is 10 times smaller than the diameter of your hair. 5 microns times 5 microns, 25 microns. That's the pressure we're talking about. And then the nuclear fusion starts and it creates helium. That's what our sun is doing, fortunately for us, every other day, right? and we're getting out 3 megajoule. So what is the difference? 2 megajoule of difference. So what is 2 megajoule? That's 1 bar of chocolate. That's it. Not more. And you know how long a chocolate lasts if you open it at the TV, right? So there are a bunch of challenges. We could speak very long about these challenges. Let me just pick out 1 or 2. First of all, the fuel. The fuel, deuterium, is plentiful available on our planet. Every 10,000 molecule or every 10,000 atom of hydrogen in your body is deuterium, because that's the isotope distribution on our planet. Okay? The other isotope, which is tritium, that contains 2 neutrons and 1 neutron in the nucleus of the atom, is not available. In our stratosphere, there are available about 2 kilograms of this material, of this gas, but in the entire atmosphere, created from space radiation. And the only way we can make tritium is we can do it in high-pressure nuclear fission reactors. And the current world inventory of tritium is approximately 20 kilograms. And now comes the bad message. This stuff is radioactive with a half-life time of about 12 years. So in 12 years from now, we only are going to have 10 kilograms of this material. And it's quite expensive. So tritium and deuterium both are required. Tritium is a challenge, but with the laser-induced, I'm talking too long, am I? Right?
That's okay. I love your hobby.
Okay.
I love your hobby.
I give you
we know what you will do after retirement.
Photonics is emotion.
Well, so if it's okay for you, I continue. So they need deuterium and tritium, because if you do the nuclear fusion with deuterium and tritium, just 100 million degrees Kelvin are required. If you do it with deuterium and deuterium, you need 400 million, okay? The big problem we face is the energy we need to put into the lasers to create a 1 megajoule pulse that lasts about just 1 nanosecond. We need to enter 300 megajoule at the current time because the lasers are not efficient enough.
Yeah, we need better lasers. But that's not for the glass makers, yeah?
Yeah.
Now that's now to something completely different.
Yeah.
So I recall my dear friend Bernhard Gress was hired by Google in the first time of the Google class, and he invited me to the Google campus, which was, that was when the Google campus was super hype. So since then, I follow the augmented reality, which is also a subject for glass makers. So is this something for Schott and for Corning, augmented reality?
Definitely. Yes, the short answer is yes, definitely. Just last week we did have our inauguration of an expansion of capacity in Malaysia factory for optics components, and one of the target applications is augmented reality. But let me come back to why we are confident in it and what technologies we are following. So confidence we already talked about a lot this morning is due to the consumer electronic companies globally, not only from the US, but as well from China, heavily investing here. Of course, we are all aware the must is AI, yeah, that's a must, and the vision, or let's say the promise, is AR, yeah. And the promise, AR is not the gadgets we are seeing so far, Snapchat, Meta, Ray-Ban, Microsoft, you name them. Yeah, that's not the promise. The promise is a full immersion experience coming up, or everybody is waiting for.
I have to challenge you. So this is for discussion. Daniel Kahneman, who died this year, he was writing a book about thinking fast, thinking slow, and the fast brain lets you drive a car. So if you text in your car, the slow brain gets in and you smash against the tree. So now what do you think? So because gigapixel we saw in the glasses, I'm really very skeptic. It's like 3D television, you know? There was 1 year you could only buy a 3D television. You cannot buy this anymore. We didn't want to have it. So now is the vision for you to get millions of colors and have the glasses better than reality?
Well, first of all, that's the vision of the consumer electronics industry, and that's not our vision. Our vision is that we want to enable.
You're following your.
We want to enable what they are working on, and our assumption is that it will not be done with classical optics because it's simply by Etondu rule you cannot do classical projection with your holographic image. So what we believe in is that it will be waveguide based, and either it will be refractive based and/or it will be diffractive based. We trust that this will be possible. Both technologies have their pros and cons. And at the end of the day, it's about usability. Usability meaning for consumer experience, that's image quality. The consumers will expect a perfect image, which we don't have yet today. Secondly, they will expect that it's a light and form factor nice device, not so big and what we have seen, and energy efficiency. Beside, of course, how to steer it, that's not up to us, that's up to AI. But about optical performance and about lightweight and energy efficiency, there's pros and cons for diffractive and refractive waveguides, and we assume one of them will make the race or they will coexist, and we are preparing for both, therefore.
Wonderful, it sounds like a plan. Who in the audience thinks that augmented reality glasses will come in our everyday life in 5 years? Who thinks, yes, we will all have it at home?
Okay. I'm wondering, is it a big overlap with CEOs? I hope so.
Okay, so we're coming to the end. So maybe a last word, future trends, a wish, or so you, the glass makers, without you, nothing works. We cannot do anything in optics and photonics. Semiconductor also needs more and more glass. So what are the final words or the wishes, big wishes?
Well, I spent a lot of time to talk about nuclear fusion, of course, so I give you back some minutes.
Enjoyed it.
No, for me, this is not a corporate point of view, it's just my personal point of view. Coming back to energy, you know, it's for the entire history of mankind, when we created energy, we were destroying something, right? We are burning wood, we are putting fuel in our cars, and we are burning the hydrocarbons. We are burning oil. We are splitting uranium 235 nucleuses in nuclear fission reactors. When is mankind learning that we may do the opposite way by putting things together? Like nuclear fusion is, we are putting together two hydrogens making helium. Our sun is doing this since 4.5 billion years. Oh, our plants out there, they're using a little bit of UV light, they're using a little bit of carbon dioxide, a little bit of water, and a little bit of nitrate from the soil to make carbohydrates. Right? And maybe in the future we will be smarter in this respect.
I guess we all share this comment.
And if we can participate, you by delivering the laser glasses, the neodymium doped glasses, and Corning the fused silica material for these projects, I think this would be wonderful. And the world in 20, 30 years from now could be much, much better. That's my dream.
Hartmut.
Yeah, you asked for wishes. So first of all, there's a message, and then there's two wishes. The message is glass is more than 2,000 years old, and it's still innovated. Yeah, there's still room for innovation. You mentioned just semiconductors. We just ramped up a new strategic business field within shot to support their specific requirements for future interlayers. And then my two wishes. First of all, I think what we are doing here today, I think cooperation, that's that's bringing us forward. And you see already perfect harmony between two competitors here on the stage. But I think the cooperation is really important, especially if it comes to innovation, in addition to persistence, what we just heard from Chuck. And and last but not least, I would personally hope that by deglobalization, we don't see this confronted with some slowing down and not using the efficiency of really, this morning somebody formulated for a really interconnected industry globally and not into different regions and disconnected, yeah.
Thank you very much. After this very inspiring path to a green future, I'd like to have some inspiring questions from the audience.
So it's Mike Powell from Renevo Capital. So the conversation about fusion reactors is amazing, but why not take advantage of the fusion reactor up in the sky and build collectors on the ground and then store that energy? And that kind of makes me wonder whether either Corning or Schott actually make many glass substrates for solar panels, and if not, why not?
Yeah, we worked on solar panels in the past, and we exited this business for photovoltaics. Main reason was it was in the midst of the 2010s somewhere we exited the business, because main reason there came overcapacities from China. It was a very subsidized business, and despite taking the race for beating down costs on a level where it's really sustainable, we couldn't keep up with the overcapacity. So
I guess we should see that the glass-making industry is more than 100 billion, and the specialty glass is about a 10 billion something. Yeah. So that means glasses for windows or for solar panels is another game than having the best glasses in the world for the best optics in the world. Mm. So. I would not chase the cheap glass and be even cheaper. So we want to have these companies being sustainable, green, and the best glass, because we need the best glass. Do you have another? You want to say something still?
I just want to say, but nothing is forever dead. Yeah. So currently, what we are doing, coming back to your space
nothing
idea,
is forever dead is not.
We are supplying the right materials to make solar panels in space feasible.
Yeah. So from the Corning perspective, as a matter of fact, we just purchased a company called Hemlock Semiconductor about 3 years ago, I guess. And this is the biggest producer from polysilicon in the US market. So we are in this business now. And to answer your question, the sun is not shining 24/7, right? So we have nights, we have winters. And what if the sun doesn't shine? What if there is no wind blowing? We have requirements for energy at the night as well. So the flavor of nuclear fusion is it can run 24/7, and I don't see too sophisticated storage possibilities for electrical energy at the current time. There's a big gap.
Wonderful. So we're running out of time. I get the signs from left and right. So thank you very much for this very inspiring talks. And thanks for staying here, because nobody left the audience. Yeah. Everybody's here. It's not like the other conferences when in the late afternoon everybody's running away. Because we have so great panels and so great talks.
Darren Burns, Chief Technology Officer of IDEX Optical Technologies. IDEX Corporation, with over 7,000 employees globally, is a key player in applied solutions for critical sectors. The company's innovations in photonics drive advancements in precision healthcare, industrial manufacturing, and environmental technologies. Darren Burns, a leading authority in optical technologies, has been instrumental in the rapid advancement of photonics and optics capabilities at IDEX, particularly in high-precision applications. His leadership ensures the company's global competitive edge, plus its ability to meet the increasingly complex demands of modern industries.
I'd first like to thank the entire staff of Optica. Thanks again for the opportunity to present today. And also thanks to all of the previous presenters. So I guess I've got good news and I've got kind of in the middle news. So the good news is I'm the last person between you and a award ceremony and then dinner. So I'll try to be brief but on point. And then the medium news, I didn't want to say bad news, but the medium news is I'm going to take us back to the Cambrian period from the comments made earlier. And I actually made a few notes based on some of the phrases that were used, which I think is really useful, right? So we spent a lot of time today talking about what is inevitably the future of photonics and the future of photonics manufacturing. But I'm here to say that there are a lot of problems to solve still today and for the next 5 years, really, in small to medium volume, optics manufacturing, discrete optics manufacturing off the wafer, right? And it would be great if every single application was high enough volume and at the right point in the technology readiness level and at the right power level so that it could be used, you could build a photonics chip on a wafer and it would solve all your problems. I think the reality is that that's not true, right? It will be true for a lot of applications that we've all envisioned, but there are a lot of things in front of us today that don't fall into that category. And so there are a lot of businesses like IDEX and others who are really focusing on how do we solve those problems today and how do we build manufacturing capability that will be useful for certainly the next 5 years, perhaps the next 10 years, with an eye towards that future of us connecting electronics and optics in a way that we all hope to as we go. So a few of the phrases I heard, which are useful, and also I'll say that, sorry, I'll start over, with 3 key points. So I hope you take away 3 things today, and I'll start with the first one, and then we'll dive into the content. The first one is what I just said. Discrete optics is still alive and the current challenge for many. And that's going to be a point that we go. And so with that, Ashken, who was here earlier, said a few things. One was, why don't we make awful solutions work first? That was an interesting phrase. I appreciate that. And in large part, that's actually true, right? You can't always get to the best possible solution right out of the gate. And sometimes the solution you have is good enough, right? We at IDEX use a term called 80-20 all the time, right? And it's, another way is focus on the critical few. And there's a bunch of businesses, I think, that follow similar logic. But the general idea is don't kill yourself for the last maybe 20% if you're already 80% of the way there. Make it work and get it in people's hands. And then listen to the market. Right? Listen to what people have to tell you. You know, in many places and in marketing terminology, people talk about minimally viable product, right? And why do you do that? Well, it's because you may not be right. You know, you may believe you have the solution that someone's asked you for, but until you put it in front of them and you put it, in their face, they can't give you the feedback that you might need through that voice of customer to really know. So another theme I'll talk about a little bit later is getting to the problems to be solved in the market from the customers, and then make sure that we balance our technology development versus those problems to be solved. So that's point number 2. There's another phrase, I'm going to use you again, Ashken, that think of optics as a transmission line, with the idea that using optics can be as simple as thinking about it as transmitting information, but just doing it through a different pipe. IDEX, and I'll show you this in a second, we started out as a fluidics company, and now we have a considerable position in photonics. We think of them kind of the same way, right? We use the fluids analogy all the time when we talk about the flow of light, because in many ways, it's kind of the same thing, right? We in fluidics, we have pumps, we have valves, and boy, if you ever want to talk to your children about optics, just use plumbing, right? They understand plumbing, usually, so you can talk about it from that perspective. It works for me and with my kids, so I recommend you do the same thing. But the challenge I bring to all of us is, what if it's not information you're transferring, but energy? And what if that energy is really high? So I'm going to show you a couple of applications here at the end that really get into that bucket. And we just heard a wonderful description of laser fusion, and that falls into that bucket, but at the highest extreme level, right? Trying to transfer energy to a very small volume in the right way so that it actually can be used and combined into something else. That presents a problem. It presents a problem for this semiconductor model, I believe. Please tell me if you think I'm wrong. But it means that if you think the fluid analogy again, what if all of a sudden the pressures were really, really high and the temperatures were really high and you're trying to still shove the same fluid through the same pipe, right? It doesn't work at some point, right? Or if the pipe has to be really long, like let's imagine it has to go through space and it's 100 kilometers of free space. That's a different problem too. So I think when we think about photonics and optics in general, I think we have to step back and think about that broader vision. And someone said it a little bit earlier about let's open up the party, right? Let's talk about all the potential photonics applications. And I think what that does for us is it helps us go from where we're at today to where we will probably ultimately be with combining electronics and photonics 10 years from now, 15 years from now. But there's the place we have to go from here to get there. And in many ways, that's going to be the challenge of how do we scale current manufacturing solutions to kind of this medium to high scale, right? And even then, boy, wouldn't we all love in the photonics world, Chuck's over here, wouldn't we all love to be back in the telecom boom and bust, right? I remember in 1998, we had people calling us at a former company, Research Electro-Optics, where I was at, just begging us to make another manufacturing line for pentaprisms, right? And we were kicking out 20,000 pentaprisms, these discrete optics every week, and then it was higher and higher, and it was sort of like, can you spin up manufacturing, conventional manufacturing, fast enough to meet the needs of the market? And that honestly just hasn't existed since that time. Right? That boom and bust, the bubble of the telecom, datacom world died, and we went from millions and tens of millions of discrete components to, boy, if you're lucky today, it's 10,000, maybe 100,000 if you're really lucky. And so what we've talked about all day today and what we've talked about this morning is an awesome future, and I think we're going to get there, but it's going to still take some time, right? And it's going to take a period of sticking with the problem, to use Chuck's phrase earlier, that we've all talked about. But in the meantime, there's problems to solve today, and hopefully I can give you a little bit of perspective on that in the next 10 minutes or so. So who is IDEX? You might have heard our name. We're roughly a $3 to $4 billion company, founded in 1988, 8,000 employees. Most people have never heard of us. I always say we're like the BASF, if you ever saw those commercials, right? We're inside of everything that you do. And that's really true, and I'll show a couple of applications of that. This is another picture. These are all meant to be the companies that are part of IDEX. And when they were acquired by IDEX, starting in 89 and going out to 23, there's two additional companies that aren't on this list that were recently acquired by us. But it's really the tale of two companies, and I only tell you that to give you perspective on who IDEX is so that maybe some of the things I'm saying can kind of come with some background. But the first company was kind of until around the 2010 range, and that was we were an aggregator and an acquisition-based holding company. We would buy companies that were profitable in industries that was very industrially focused, And again, fluidics, Hale, Viking Pump, Warren Rupp. These are like big oil rig, water truck pumps and valve systems, but all for the intention of moving water and other fluids around. That was company number one. Company number two has really been in the last 10 years and probably more so in the last 5 years. And I think this gets to a lot of the themes that we've been talking about. And that is, how do you start to build a platform of businesses that ultimately can solve a set of critical problems because you have the critical mass to do it? And so you see on this list CVI, Melis Griot, they're part of IDEX, Semrock. There's a number of optical coating companies, a number of fabrication companies that are part of this list. But what I can honestly say, and we're quite proud of, is that there's only one or two of the companies on this list that are no longer part of IDEX. So they are brought into the business based on a strategic vision and then held there. Okay, global macro trends. We heard about this a bunch of different ways, so I won't dwell on it, but these are the things we really think are important. And we heard topics about this and comments about this earlier today. The one in the middle we didn't really talk about that much, but I'm here to say that it is an immediate challenge for us in this industry, for many industries as well. There are issues, we talked about issues associated with regulation, the CHIPS Act. I've been around long enough in this industry that it used to be that the only regulations that were really in the way of us transferring technology or product across from the United States to Europe were in the defense sector, for obvious reasons. That's no longer true, right? Chips, even designs for tooling that's associated with the manufacture of products for either the defense industry or now the semiconductor industry is also limited. We're probably not very far away from the life science sector being limited as well in terms of how do we transfer technology and information across borders. And since so much of the money, big money, is coming from the United States, this should be a cause for concern for all of us, right? How do we maintain the level of communication that we've all talked about in a world where the regulations are pressing down on us, right? And so I think that's a little bit of a takeaway. Is how do we deal with that as we move forward? Okay, so what do we bring to the table? Oops, let's go this way. So IDEX is really good at building platforms, leveraging technology with an innovative spirit and large capital backing. We, as I said earlier, we focus on the critical few and really try to focus on growth. And then it's really bringing this strategic vision to the table. So with that in mind, we think about things from this perspective: product positioning, innovation, operational excellence. These two on the right side, the balancing act between those is a challenge for everyone. It's kind of that long-term versus short-term. How do you do the business of today? How do you meet the needs of a public investor base while you still think about what's going to happen in 5, 10, 15, 20 years? It's a problem, but it's as Chuck said, it's table stakes. Couple of key phrases I think are really important. I think we all know this, right? Lasers and optical technologies can change our lives. Optics manufacturing, I think, really, if we think about it, provides the toolkit to control light. We've heard that term a few times. And then innovation in a number of areas really help to drive those solutions. So impact across a wide range of markets. Here's my comic relief of the day. Not sharks with lasers, right? So anybody who saw that movie, you can have a chuckle with that. Okay, getting to the final 2 points here. So fundamentally, innovations in all areas lead to the most differentiated solutions, right? So we look at it from this perspective. It's everything. It's how do you focus on materials that get you to where you want to go? How do you make sure that you can make shapes out of those materials And then how can you control what happens on the surface? So how do you functionalize the surface of this thing? So from an optical coating standpoint, it's a lot of things. We've been in the business of optical coatings for a very long time and really are industry leaders in this area, but we still don't know enough, right? And we need to know more. Fabrication of shapes, there's a whole bunch of topics we've talked about with so far. The one I'll mention down there at the bottom is we're actually starting to see a much bigger area of working with lasers interacting with materials to form things that then can help lasers work, right? So it's sort of that cycle of utilizing the technologies in a useful way. And then materials. We just had the gentleman up here from the glass manufacturers, but I'm here to say we need more, right? Glass has been the substrate of the last 100 years. Well, let's go back to a very long time ago. It's probably been for 1,000 years. But in reality, glass is primarily what we use for the most part for the substrates for materials, for the intention of creating curved surfaces for diffraction and refractive elements. Ceramics are potentially a future here. Nanocomposite ceramics offer the ability to create mechanical properties that you want and optical properties that you want as well, and so we're focused on that. Lastly, I'm going to get to 2 or 3 examples here, and then I think that's it for my time. So again, we use this term a lot, jobs to be done. So laser communications and environmental sensing. What is the problem? Right? So when we go to our customers and ask them, what is the problem? You're trying to move light tens to hundreds of kilometers across space, isolate it and control it to 7 or 8 orders of magnitude. So I've got a really bright beam shooting out of one satellite, and it has to be collected by another satellite that's 50 kilometers away at 10 to the minus 7, right, or 10 to the 7 orders of the other light, right? So the ratio is really big. This is a problem we solved ages ago with fiber optics, optical isolators, right? But now you need an optical isolator that works on a satellite, and you need to do it in a way that you can control the end result. So it's also optical coatings. How do you get rid of the sun? You've got to be able to isolate your signal in a way that also blocks out the sun to the same sort of degrees of extinction. And then you also have to be able to deposit coatings on surfaces that are very thin, super weird aspect ratios, and they can't bend very much, and oh, by the way, they're really big, right? So 6-inch optics that have to maintain nanometer level precision, because otherwise it bends the light beam enough that by the time you go 50 kilometers away, it doesn't look like the light beam you started with. Another example, next generation sequencing. So what's really the job to be done? We're trying to isolate pixel by pixel information that tells us something about the assay that's been done or the genetic information that's on, say, a microchannel plate or even just a general flow cell. Doing that quicker, faster, and then getting to a point where you can extract the information. Requires large field of view, diffraction-limited objectives, flat top illumination. These are all problems that are associated with, for the most part, discrete optics that are put together. Can we do this ultimately all on a chip? Absolutely, right? And that's the future. You put everything on the same chip. You put the flow cell on the same chip, you put the detectors, you put the sensors, you put it all together. But for the most part, that still doesn't exist today. So this is the problem we're faced with currently. And then how do you deal with that? Well, now we have to create illumination that's uniform, that's flat, do that all in free space optics. And then this is probably the solution that lasts for the next 4 or 5 years, and then we move to chips, lab on a chip, photonics on a chip, etc. Last one I'm going to leave you with is semiconductor metrology. Again, this is one we all know very well, but part of that in situ metrology of the entire process is to image what's happening, either at the mask or on the wafer. We talked about EUV metrology quite a bit earlier. What we forget about is that we have to measure the mask to the same level of precision as the chip you're trying to make, right? So if you're using EUV lithography and you have an EUV mask, now we have to look for defects, nanometer level defects on a wafer or on a mask at that same level of precision, and be able to move, by the way, this is the other part we forget about, but I'm a mechanical engineer, so I'll bring it up. You got to move the wafer with the same level of precision, right? This is something we often forget about on the optics side, but there's an entire industry, and we play some part in that, but of just the mechanics associated with moving a wafer to nanometer level precision and then stitching all that information together, because it's still using microscopes for the most part to image them. And now all of a sudden, oh yeah, now the masks or the pellicles that go over the masks are also made of materials that no longer transmit deep UV light. They transmit EUV light. So the microscope needs to be an EUV source as well. So that presents all kinds of challenges. But in many cases, we can still do imaging on most of the wafer systems with traditional glass-based systems. And so the solution for a lot of that is optical fabrication and assembly processes today that allow you to align glass elements to within a fraction of a micron so that you can get a high NA objective that can image the wafer that you want. We saw earlier EUV lithography systems moving to higher and higher NA, right, as the evolutions go up. That's going to be true. Those are still free space optics, right? They're still reflective optics built by our friends at Zeiss and others. Very big elements, right, that all have to fit together. So fundamentally, I'll leave you with that third point, and that is I think it's really important for us all to really listen to the voice of customer, as we say. Hear that message. Think about how do we go from where we're at today to where we need to be and where we want to be 10 years down the road. And that's going to involve some solutions that automate and allow us to be better at our current jobs. And back to Ashkin's phrase, let's take awful solutions and make them better, right? Or however you said that. So anyway, thank you. I appreciate your time.
What a great day. Just one question for you. When we had this event in 5 years, what is your preferred future for the optics industry? How do you want the optics industry to look then?
Oh, well, I would hope that we are talking more. I hope we're communicating more. And this fits the theme, I think, of this discussion. We're still in a world where everybody's afraid to share information. It's just honestly true. And I would say it's the United States and Europe, I think, have different problems. The United States has a lot of money. There's a lot of funding for a lot of things. But nobody wants to share. Everybody wants to develop their IP. They want to hold it tight. Their investor base is giving them hundreds of millions of dollars. And they see their way of differentiating by keeping that IP close to the chest and not sharing it with anyone. I think Europe has a different problem. I think from what we saw today, there's a little more information sharing. There's a number of institutions that are built fundamentally to share information. But there's not the same level of funding to take those ideas and that shared information and scale it as fast as is often done with the capital that's in the United States. So how do we get the best of both worlds? That's really what I wish for this industry. Because until we get there, a lot of these questions we've had today about scaling, about finding the right solution at the right time, it's really hard to work through the noise of all of what everybody says and really understand what are the critical few problems. What are they, right? Because if you ask me, I've got a different answer than you do and than you do.
Thank you, Darren, for a great presentation. Thank you. I'm already at La Pergola, the restaurant owned by Antonio Banderas. This is the location for this evening's gala dinner. But before we all leave for this place to engage in meaningful connections, we still have one very important matter to deal with here at the FICMA. The Global Photonics Economic Forum is delighted to announce the 2024 prizes for the Optica Global Innovation and Impact in Photonics, aka the Optica I4 prizes, celebrating the excellence of those who excel in industry by achieving our core values: innovation, integrity, inclusivity, and impact. There are 2 prizes this year, one for an organization, the other one is for a lifetime personal achievement. For the last year, my team and I have been traveling the globe visiting large and small organizations. As well as understanding what they need to succeed faster, we have also been assessing the global impact of what they do. Ladies and gentlemen, please welcome on stage my co-host for the prizes, Ulrike Fuchs, VP of Strategy for Asfericon and Optica's Chair for the Awards Council. We will now reveal who has been chosen and why.
Good evening, everyone. Well, what a day. This forum has reminded us just how crucial the photonics industry is for our society. It is an enabler of technology like AI, and it plays a significant role in keeping us all healthier and safer. The global photonics market, we learned today, is on track to grow to 1.2 trillion euros by 2027. Today, we want to recognize outstanding contributions to the growth and innovation of our field. With these prizes, we aim to encourage companies and individuals to contribute and to continue striving for excellence and to secure their fair share of research and manufacturing opportunities. So, well, let's now begin our celebration of achievements. The first prize I would like to announce is the individual prize. This recognition is dedicated to a person who has shown exceptional dedication, leadership, and impact in the field of photonics. Their work has set a standard and contributed significantly to the advancement of our industry. To present this important recognition, I invite Carolina España-Reyan, Minister of Economy, Finance and European Funds of the Andalusian Regional Government, to join me on the stage. Okay. Well then, the winner of the 2024 Optica I4 Individual Prize is Chuck Matera.
Chuck Matera's leadership over the past 2 decades has left an indelible mark on the photonics industry, making him a worthy recipient of the Optica I4 Lifetime Achievement Award. As CEO of Coherent, formerly 26, Chuck led the company through a remarkable transformation, taking it from a small domestic manufacturer to a global powerhouse in material science and laser technology. His strategic vision helps Coherent expand across multiple industries: communications, electronics, industrial, and instrumentation, with groundbreaking innovations that reshape these sectors. Under his stewardship, the company doubled shareholder returns compared to the S&P 500, a testament to his focus on long-term growth and market leadership. What sets Chuck apart is not only his professional achievements, but also his deep commitment to fostering a diverse and inclusive workspace. He championed the idea that diversity drives innovation, emphasizing the importance of bringing together the best people with different perspectives to solve complex challenges. This philosophy has been instrumental in shaping Coherent's success, as his global team continues to innovate and push boundaries. Chuck Matera's extraordinary contributions to the industry, combined with his inclusive leadership approach, make him a truly deserving recipient of this prestigious award.
Congratulations. Just wow. Okay. Next, we move on to our corporate prize. And with it, we celebrate a company's outstanding commitment to innovation, excellence, and contribution to the photonics industry. This recognition is not just about success, but it's also about setting an example for the entire sector. To present this prize, I invite the Mayor of Malaga, Francesco de la Torre Prados, to join me on the stage. And the winner of the 2024 Optica i4 Corporate Prize is IMEC.
IMEC exemplifies leadership in both innovation and inclusivity, making it a standout candidate for this year's Optica i4 award. Their pioneering work in hyperspectral imaging for satellite-based environmental monitoring, alongside breakthroughs in healthcare technologies such as non-invasive diagnostics, artificial organs, and precision surgical tools, are just two examples amongst hundreds, demonstrating global impact. Beyond these technological achievements, IMEC also acknowledges the pressing environmental challenges posed by chip manufacturing. It significantly contributes to the life cycle climate impact of consumer electronics. Recognizing the urgency, IMEC is actively implementing solutions to mitigate these effects as part of their broader commitment to reach net zero emissions by 2050. Their commitment to innovation, collaboration, and sustainability highlights IMEC's leadership in shaping the future of the global photonics industry. In addition to these efforts, IMEC is deeply committed to fostering diversity and inclusion as drivers of innovation. They recognize that diversity in leadership and research teams enhances decision-making, talent attraction, and market understanding. IMEC has prioritized their creation of a more inclusive workplace. Their gender equality plan sets ambitious goals for improving the representation of women, particularly in R&D. IMEC Expand, their venture capital arm, extends this inclusive approach by providing disruptive startups in photonics and other deep tech sectors with access to IMEC's cutting-edge technology and global network. This holistic commitment to innovation, integrity, inclusivity, and impact positions IMEC as a technology leader, but also as a positive force for global societal change.
No, I want to congratulate you. Never mind. Just ignore me.
Well, that was something, eh? Who thinks today was spectacular? I had the best time of my life. Thank you so much. We couldn't have done this with the interest and energy of every one of you. And now for me, it's the most important part of the day. Now is when we make those meaningful connections at La Pergola next to the lighthouse in Malaga. Let's all go there and continue this fantastic event. Thank you for a fantastic day. Thank you.